Hello, everyone. Welcome to GameDev Days online. It's actually our second day today. We had fantastic meetups in Amsterdam and Munich yesterday. No worries if you missed them. We recorded everything. We'll publish the recordings. So they were 4 fantastic talks and you'll catch up on them. Matt, did you love it yesterday?
Yeah, it was fantastic. It was great to be in the office here in Amsterdam and taking part in the offline talks. And I'm actually glad they're being recorded as well and being shown, because then I can see the ones from Munich. I was also looking forward to seeing some of the Munich talks as well. But great sessions, and it'll be good that they're available online.
Yeah, that's true. So let's explain the routines for the day for everyone who just joined us.
Yeah, absolutely. The day, of course, is being streamed. If you miss anything, you can pause and rewind the stream as you're going on. But we will also be recording everything, and we'll edit the sessions out and put those up as separate recordings once we're done as well. If you've got any questions, please post them into the chat. Just post them as we go along. If there's anything simple, we'll answer straight away. But otherwise, we'll pull them out and we'll take them to the speakers at the end of the session as well. So make sure, please, you do come in. Let us know what's going on in the chat. Let us know where you're from. You know what's going on. We'd love to hear everybody in the chat there as well.
Yeah, that's true. And we'll have some fun today. So we'll be running some polls and also some quizzes. And I think it's a good time to just warm up, to wake up everyone with just the very first quiz. So it will be very simple. Matt will ask you the question, and the first person to answer in the chat will get the prize. And the prize is actually huge. It's the All Products Back license for a year. So Matt, you have a question?
Yep, first question for today. It's a nice, simple one. First one to give us the answer is the winner. And the question is, what is the name of Epic's new programming language for Unreal?
Yeah, let's wait for the answers. I'm wondering what it could be. Maybe it's Kotlin. No?
Kotlin would be nice. It's
oh yeah.
not going to be happening, I don't think.
Yeah. I think we have a winner. We have a correct answer. It's verse. Yeah, absolutely. So I will contact the winner and we'll organize the prize for you. Thank you for everyone who participated. So, but we'll have more quizzes during the day. So we'll try to come up with more questions together with Matt and ask you during the stream. And so the day will be long today, but we will really appreciate you are all here, and we will really appreciate all your feedback. So please don't forget to fill up the surveys that we'll send you after the event, so that we know if you love it and what specifically you love about the event, and also for sure what you don't love as well, so that we can fix it for the next year. Okay, so and I think it's time to start. Matt, what do you think?
I think so. I think it's time to get going. Should we bring in our first speakers?
Who it could be? Yeah, so it's Matt and Daniel. Welcome.
Hi, Anastasia. Hi, Matt.
Yeah, so the stage is yours.
Awesome. Yeah, hi, everyone. So the first session today, we're going to be showing a walkthrough of Ryder, which is our awesome IDE that supports Unreal Engine for game development. So Matt's going to be showing the IDE features in Ryder, including the AI assistant and all of its capabilities for Unreal game development. And then we'll switch over to me, where I'll show a walkthrough of TeamCity, building the project and its support for Unreal Engine build pipelines. So Matt, over to you.
Yeah, thanks, Daniel. So the whole idea of this really is to kind of show you a bit of the overview of the entire life cycle of working with Unreal. With JetBrains tools, we can do the whole lot for you, from editing and working with the code to then building your actual project as well and working with that. So I'm going to start with giving you a quick overview of Ryder and some of its really cool features then for working with Unreal. And as I say, we'll then hand over to Daniel. We can see on the screen now, I've got Ryder up and running. I've also got Unreal. Where are we? There it's in the background. Got the editor running just with a simple project. It's the Lyra game project there. We can see we've got it loaded up here. We can see we've got the project itself with all of its files, and then the engine loaded there as well. The first time Ryder opens your project, we'll index all of your files. So we'll go through and build an index so we can very quickly navigate around. And one of the key things we do here is that we actually index the engine in the background. So we'll make sure we prioritize your own files so you can start working with your files quickly. And then in the background, we will then start to index the engine. So you can carry on working with your own project while that's going on. One of the key things as well is that we've got this index, and it gives us a lot of power then to be able to navigate around the code, but we keep that index up to date incrementally. So if you make any changes, we only have to index just the files that change. We don't have to sort of re-index the whole thing. And so it's a much sort of lighter system once it's done that initial index. So the first thing we can do with that index that we built there is navigate around your code. And you can use the Shift keyboard shortcut to bring up our search everywhere. This is a really powerful way of understanding your code, finding things, navigating around, and walking around your code. And you can then just sort of start typing then to be able to find things. And you can see that the searching is very much about search everywhere. We can find everything. We can search for classes, files, symbols, and so on. And so if I just start typing camera mode there, you can see I've actually found a couple of files up front. I can find this C++ file and header file, but it's also find some symbols for me as well. So it's actually found me a camera mode field there, property, which I can then navigate to and quickly jump to. If I do Shift again, I can then quickly jump to a C++ file. Let's just close the Solution Explorer there. We don't need the Solution Explorer. We can search. It's much easier and quicker to jump around and search and find things there without having to scroll around and look in your Solution Explorer. One thing we can do here as well, we can just start typing, and we can start typing something like Inventory Manager, and you can see we can very quickly find things, but we don't have to type the whole name there as well. So if we got the Lyra Inventory Manager component, I can just type LIMC, and it can then very quickly find those things too. So it matches based on the capital letters in those words as well, and it's a very quick way of navigating around to be able to find the code that you're looking for without having to type the whole thing out, which is pretty cool. When you are using Search Everywhere, you can see we've got items across the top. We've got all classes, files, symbols, and so on. And this is our way of being able to narrow down the search. So I can actually just hit Tab, and it can go off and it can find and search classes for me. Or I can hit Tab again, and it'll go and search files. And so it'll just go and find me things matching file names. Or I can go and search just for symbols as well. So I can then very quickly go and find a method. If I'm looking for a specific method, I can easily, such as the listen to input method change, I can very quickly go and find that. You can see we've also got a couple of other tabs here as well. We've got actions and we've got text. If you want to just search for text, we've got two different ways of doing this. We've got a quick search here for being able to find like a very specific bit there. We've also got a find in files function as well for doing that. So you can also search for text. One thing we've got which is really useful is to be able to search for actions as well. So LIMC is not particularly useful there. If you can't remember where a particular feature of the IDE lives, you don't have to go searching through all the different menus for it. You can just use Search Everywhere, use the Find Actions tab, and then just go and find it. So let's say we wanted to rename something. And if I can't remember what the keyboard shortcut is to rename, I can just find it in my actions there, and it'll show me the item. I can invoke that, and also show me the keyboard shortcut there as well. If I wanted to add a bookmark, so let's say I'm at this line here, this check method, and I wanted to add a bookmark so I can quickly jump back to this point at a later date. If I can't remember what the keyboard shortcuts are for bookmarks, I can just start typing here. I can use my Actions tab there, and I've got a whole bunch of different options for adding and working with bookmarks. I can view the bookmark tool window. I can toggle specific bookmarks there, or I can just use the first item here, which is going to give me my menu from which I can do a whole bunch of things to do with bookmarks. So finding actions is a really useful thing we can do. If we just hover over the Actions tab there, we also see it's got a dedicated keyboard shortcut. So I can just very quickly jump straight to Actions there. And it's a great way of being able to find how to do things in the IDE if you can't remember a keyboard shortcut and so on. So we've got a nice way of sort of being able to navigate around with our shift and our searching. When we're actually there, there's other things we can do as well. The main keyboard shortcut we've got inside the editor itself is Alt and Enter. So Alt Enter brings up a little context menu of all the actions you can do at this particular point of code. So for example here, yeah, we've got options to convert to a trailing return type, change the signature. We can add some documentation to it and so on. Down the bottom of this menu are some items which are almost always here. So this is a great way of kind of, again, being able to find your way around the IDE, find out all the functionality that we've got available. If I go to like an empty page, for example, sorry, an empty line, then I hit Alt-Enter there. There's no sort of context items I can do here specifically, but I get options for these entry points into functionality. So I can navigate, I can refactor, I've got inspection items there, and I can generate code. And there's also some AI actions as well. We'll talk about AI in a little bit. Let's just go to, in fact, let's go to the class for camera mode stack. There we go. So we've got our definition for class. Obviously, Control-click will navigate you to somewhere very easily too. If I hit Alt-Enter here, and I can have a look at things like the navigate to, we've got a whole load of very smart, rich navigation functionality built in here as well. We can do really interesting things like go and find the base symbols, and that will take me to UObject, and I could do that again, navigate to base symbol. If I wanted to do that more frequently, I don't have to go through the different menus. It's telling me there I can just use Command U to go up the class hierarchy, but I can then sort of very quickly navigate around. I can use my navigate to menu again and go to derived symbols. And probably let's go to something a little more simple with that one, because there's going to be a lot of objects derived from that. UObject is also going to have plenty as well. Let's go find something a little bit more useful. Camera mode, everything's going to be from UObject. Well, let's see if there are anything derived from camera mode. Derived symbols, as it happens, there are. This is great. So I can go and see the derived symbols as well. So I can walk up and down the class hierarchy nice and easily. I can also actually show it as a diagram as well. So let's try that. And I can bring things on there. I can right-click, add on reference types, and build up my type diagram with that too. So there's a lot of different sort of entry points we've got for navigation. So again, we can do navigate to. We can do other useful things here, but the one which is perhaps the most useful here is going to be find usages. This is a really useful feature because I've got this class here, my camera mode. It's really nice to understand what it's doing, but I probably actually want to go and see how it's being used there. So I can use find usages, and Ryder will very quickly show me all the different places it's being used there. This little window here is really helpful as well. It shows us grouped up the results all grouped. I can see I got one usage in plugins. There's more things going on in the sort of source folder, and I can then sort of very quickly navigate around and see what's going on there. There's a very useful item on the toolbar here, this group by usage type, which is really nice when you turn that on, because it not only kind of groups by location of the result, but also by how that is being used there. So for example, here we can see it's being used as a base type, or it's being used as a function return type. And that's really useful because you want to know how you can get a particular instance of something. And that, there we go. Now I've got an easy way of understanding where I can get an instance of this type. You can also see where it's being used as a variable declaration, nested symbol definition, other things, template argument, and so on. Also shows you things like new instance creation as well. So find usages is really helpful. You'll notice as well there's a preview window on the side here, and this is actually just another editor, so you can actually start typing here as well and edit the files even in the preview. Let's go and see, in fact, let's go to here. One of the other nice features we can do here is go to all the members of the file as well. And so I can see all of the items that are in this particular file here, and then I can just start typing to navigate around. And if I go to, let's actually go to the method here. If I've got this blend function here, what I want to be able to do here is use my inspect this menu item and have a look at the incoming calls. This is a really useful feature because find usages tells me where something is being used. And if I then see, well, okay, I can see where that's being used, but where is that thing being used itself? And I want to sort of continuously ask that question, then this incoming calls can answer that for me. So I've got my blend function here, and I say, well, who's calling this? And I can see that blend stack is calling that. And then I can click there and navigate around and see blend stack. And it's like, well, who's calling blend stack? And I can continually expand this call stack to find out how everything is being used. And then you can see then get a better understanding of what your code is doing, how it's being used, how it's being called, and the flow of the control flow of your program, which can be very useful. So that's some of the navigation features we've got, which is very helpful inside Ryder. Obviously, we do a whole load of things with editing as well. So for example, if you want to add a new class, you don't have to go to the Unreal editor and add it through there. You can actually just edit directly in the IDE itself. So if you right-click on a folder or a project inside your solution view there, you've got the add menu there. I can just add a new class or a struct, and it'll fill that in for me there, and it'll create it. Am I in the right place? Yeah, let's try that one again. Or I can go down the bottom here, and I can do add a new Unreal class or an Unreal test class as well. If I want to add a new Unreal class, I get a whole bunch of options there. I can give it a name. I can derive from one of many parent classes there. We give you some common items here, or we can then go and see all of the classes, and then I can sort of start to search for things there. So let's just search for character, and it'll very quickly find things. I can declare it to sit in the base folder, public folder, or put everything both in the private. So it's a great way of being able to quickly create your classes and work with your code without having to go through the Unreal editor itself. There's also some nice features for editing. Let's just get rid of that one. So for example, and let's close that. When you type, obviously we've got code completion there, and it's very quickly appears. You just start typing, will complete everything for you. We do a few things which are quite nice and smart as well, though. So obviously here I can use the arrow operator to do something. But if I can't remember whether it's the arrow operator, the dot operator, what's the method we're using there? Evaluate stack. So if I just do evaluate stack, then you can see that Ryder actually fixed that up for me. So I was using the dot operator instead of the arrow operator. Ryder knows that I've made that common mistake there, and it'll just fix it up for me, which is a really nice sort of convenient way of helping you and working with you while you're editing. We've got other nice features as well. If I go down towards the bottom of this, have we got? No, haven't got a method there. Another nice features with the idea of code templates as well, so you can just start typing and we'll expand a whole lot of code for you. But one of the nice things we can do is postfix completion. And this is a really nice way of working where you can have a template which is evaluated at the end of an expression. So the idea of this one is to actually allow you to concentrate more on the data, on the API calls that you're doing, and then you can actually add the syntax automatically for you. And we can do lots of different things with that. So where are we there? Determine camera mode delegates dot isBound, and then I can just do if again there, or I could do dot else or dot var to create a new variable. and it will fix up the code for me, and it'll just write all the things for me. So it's a very interesting way of changing how you work with things. Let's just roll that one back. Obviously, we've got integration with version control, and we can see what the differences are with your files and stuff, and I can quickly roll things back. We'll highlight items in the editor as you're working. Another useful thing for editing is the way that Ryder can automatically format your code. And one of the nice things we've got here is the ability to format slate calls as well. So we've got specific formatting for slate. So I got a bit of sort of DSL there. If I highlight this, use Alt-Enter, I've got my reformat and cleanup item, and I can just reformat the selection, and it'll rewrite that code, and it'll format it for me nicely into the sort of DSL that you expect from slate. We can do the same in this one. If I do Alt-Enter, reformat and cleanup, reformat selection, and you can see it's reformatted my code nicely. And you can see it's put all of these items onto different lines, but you can see with this one, they're still on the same lines. And one thing which is really useful is the ability to be able to configure this. So we can actually go to reformat and cleanup, again through Alt-Enter. And if we go to configure code styles, we actually get a dialog here which shows all of the code styles that are available for us to edit at this point. And there's a lot of different options we can have, but if we scroll down a little bit, we've got our slate formatting options here, and we can see that one of the items I've got is wrap slate chained calls. It says chop if long or multi-line. I can drop that down and I can say chop always. Let me just try and move this around a bit so we can see both things at the same time. So if I move that over there and highlight this again, Alt-Enter, configure, bring this over here, and down to the bottom here, chop if long or multi-line. If I do chop always, then it actually updates the text while I'm working with it there. So I can change my configuration and it'll actually show me what it looks like. And so I can very easily understand how I should be configuring my code to get the formatting that I want. And so if I just then save that, it's updated both my formatting styles and also the code itself. Another nice feature that we've got for editing as well, if I use Alt-Enter on my class name here, as another widget, again, I've got my different options and different features that I can do. I've got my main entry points down the bottom here, such as navigation, inspection, and so on. I've also got refactorings as well. And there's a number of different refactorings we can do where we can automatically rewrite your code for you. I can change the signature, so I could add another parameter in here if I wanted to, like, if I could add in a string or an integer or something. And let's just come out of that because I want to do another one. Let's refactor this. We can do a safe delete to make sure that it's not being used by anybody. So if I wanted to delete a function, I can just make sure that I'm not going to introduce any compile time errors here because I can it's actually being used. Or more importantly, I can do a rename. This is perhaps the most useful refactoring that we've got. I can safely rename something which is going to be used across lots of different files without having to do find and replace, which can always be a little bit tricky there. So I can just create another widget. And in fact, the AI assistant has jumped in there with some suggestions, which is rather nice. It's suggesting I'm going to call it a game API widget, and I'm going to go with that one. And so if I rename that, it can update it. It wants me to update my source controls. So let's just add those. And one of the nice things that we've got on top of that is if I go, let's do an item like this one, which is a component. There we go. That's the thing I want to see. If we were doing something which is an Unreal class, then obviously this can be used inside a blueprint, and renaming that might break things. So what we can actually do is Ryder, when it recognizes that you're going to rename an Unreal class, it can add a core redirect entry. And if we go to our commit class, commit page here, let's just pull that down a little bit. And if I go into the config file, I can see that the default engine.ini has added a core redirect here from Lyra camera component to my renamed instance there. So now it's not going to break the code when I want to work with it. Let's just rename it back to make sure everything's okay. There we go. And you can see that we'll have updated a whole bunch of files, and everywhere it's being used, we'll be using the new name. Let's go to our inventory component again. What do we want? The manager component. That's the one. Because there are some useful things in here that Ryder allows us to do with things like inlay hints. So for example, we've got a print statement here. We can see what the name of the parameters are. We've got the format item going on there. We've also got some nice little indicators here, such as this little inlay hint here, which if I highlight over that, shows us that there's a user-defined conversion going on. So it kind of gives us a nice little bit of an indicator to show that there's more happening here than perhaps you would see just based on the text there. We're calling an inline operator to convert that. Another example here is we've got the indicator to show us we're passing by reference, which is, again, very, very useful and helpful. We can go and see a few other things. Let's go to the cheat manager. And we've got a few more items being shown here with the parameter names, which is useful. We've got things to show us when you're at the end of a namespace, which is good. And if I actually go, let's go to the header file there, because nope. 1 second. Nope, I've just lost where I was going to go to in my code. Let's jump to a different item here. So we've got input.cpp. Some of the settings, some of the inspections that I wanted to show you. So there are a number of things going on here whereby we can actually help with your code. And so we'll inspect your code. We'll look for common issues and things which we can help improve your code and work with things. And one of the things we'll do is we will look at your include files and see what is possibly unused. We can highlight those to say that you're not using any symbols from these include files. And again, we can do the Alt-Enter item there to be able to remove all of the unused items there. So Alt-Enter can help you rewrite your code to fix some common errors and mistakes. We've got a couple of other sort of features and useful things. So if we go to our a demo file here, we've got I want that. So we've got an inspection here, which is being flagged up because what we actually do is we'll run Unreal header tool on your code as you type. So instead of having to wait until your code, until you build your code, you compile your code, we can actually run it as you type there, and we can show you that there's an error here. So we've got a replicated function there, but we're actually using a return type. We're using a return type. We can't have that. So that we do other things with that. So something with blueprint assignable. It's not allowed on a multicast delegate properties, and we'll obviously Unreal header type will flag this and show these as errors, and it'll show those immediately rather than having to wait until you compile. You're doing the next compile. We've got a similar kind of thing with support for reflection macros as well. So, for example, here, if we've got a property, there it is. The Unreal header tool's kind of getting in the way there. But we've got code completion then for all of your macro specifiers here. And so we can show all the items that are available there, and we'll actually give documentation for it as well, just as a little hover documentation to help you work with your code and understand what's going on with the reflection macros. There are a couple of other items which we've got here. So, for example, if you are using a uObject item without the uProperty macro there, then we'll warn you that this could actually get destroyed during garbage collection there. So you can actually see that you might get a stale pointer. We're going to help you out there, and that you need to have the uProperty macro available. Otherwise, you might encounter problems at runtime. Other sort of simple inspections nice one there. If you've got a struct, for example, then but you've got it with annotated with the uClass macro, we can highlight that actually it's a struct and you're using it with a class, so that's going to be incorrect there. And we have other items misgoing as well. So for example, a class with a generated body macro there, it's missing the uClass declaration. So we can actually use Alt-Enter to then very quickly add that in and carry on working. There's a number of different inspections and quick fixes to work with macros and so on. Now, one of the nice things that we'll do is index all of your files when we open up the project, but it's not just your source files that we index, we'll also index all of your blueprints as well. So we can see here we've got the camera mode item here. We've got an indicator just above it there to say that it's actually being used inside a blueprint class there as well. And if we click on that, you get to see where it's being used, and we can then also click on that, and if Unreal Editor is running, then we'll actually bring the editor, open the editor for that blueprint for you. So this isn't just for working with classes as well. It also works with serialized data. So you can see here, for example, we've got field of view. It's being set to the value 70 inside this particular blueprint. And again, we could navigate to that and we'll bring up the editor and allow you to change that. If we go to another one here, blend time, for example, that's actually being changed in 2 different places. You can see what the values are. It's a great way of being able to understand how your code is being used inside serialized data. And so if we open up this editor here, let's search for blend time. Blend time is this one here. You can see 0.22. If we change that to 0.35, for example, and if we save that and switch back to Ryder, then you can see if we click on that, Ryder has already updated it. So it's, again, very quick at being able to incrementally keep this data up to date with how you're using your code and how your code is being used inside blueprints, which is really powerful. Last couple of things then to finish up is that we've got some great integration with the Unreal editor itself. So for example, at the top of the of Ryder, we've got a couple of items here. So I can put us into play mode, and let's see if that's going to work or it's going to cause trouble based on the text that I've been working on. So that's switching us into play mode, and we can pause and carry on. And we can also stop as well. So I'll get full control of how I want to work with Unreal Editor from the tool window there. We've got some options here as well. So you can change things like the number of players, the spawn mode, and so on and so forth. We've also got some useful tool windows to integrate with the editor as well. So if you want to see what Unreal Build Tool is doing, you can see what the log file is there. Obviously, if it's a file, we give you a link so you can very quickly open the file itself. And we've got another a plugin as well, which allows us to bring in the Unreal Editor log into Ryder. And this is useful because it's kind of the information about the code. So let's show it where your code is. And we can recognize when you're using a class and a method there, and if we kind of click on that, we can very quickly sort of navigate around and take you to that code there. So it's really useful to be able to bring that log into Ryder so that it will work with the code and show you where the code is being used itself. Okay, so last couple of things then. Let's just quickly show you a few of the things about AI Assistant. So if we go to back to our camera mode, and if we go to the implementation of, let's see if Get World is a good one. There we go, Get Pivot Location. The AI Assistant that we have got allows us to do a number of different things, and we've got a bunch of interesting actions that you can work with. We've got a chat, so you can ask it questions, or you can have some actions which are already built in, such as explaining the code there. So if you've got a big method which is doing a lot of stuff and you want to sort of get a quick summary of what's going on, you can then just ask the AI assistant to look for you. My machine's has that frozen? Having a few demo problems. Oh, okay. And my machine's woken up again. There it is. And so yeah, so we can ask it to explain some C++ code for us. It can see what's happening, and it can walk through that code and break it down to you and explain what's going on. And so it can explain code. It can you can ask it for things like, how do you do interpolation? How do you use specific APIs inside Unreal itself? And it will gather the context from the editor and display that and give you all the information that you need. And then so finally, as I say, we've got lots of integration with source control here. We've seen it here. We can. I'm using it with Git in this particular case. What you can do is show. Have a look to see what the values are, what's changed, and then you can, when you're happy to work with that, you can stage items, you can type in a commit message, and you can then commit it. But one of the nice features we've got with AI Assistant is that it can generate the commit message for you, and that will then look at to see what the difference is between what has changed. It'll summarize that for you, and it'll generate a commit message and allow you to commit your code and push to the server. At which point, then I think we've now kind of shown everything shown a good introduction of what Ryder can do. There's a whole load more things we can do, but now we've committed code. I think we can probably bring Daniel in and show how we can use TeamCity then to build your code.
Yep, sounds good, Matt. Thanks for your demo. Yeah, Ryder's a really cool IDE. Thanks for that. Awesome. So I'm showing TeamCity here. I'm currently logged onto a TeamCity cloud server, and this has full support for working with Unreal projects. We also support Perforce. Matt was working with a Git-based version of the Lyra project, but I'm working on a Perforce version here in TeamCity. So if you're using Perforce, that's fully supported by TeamCity. So TeamCity is our CI/CD solution. It's a really mature solution, lots of features built in, and I'll show a few of those during the demo today. With TeamCity, if you have a Unreal project and you maybe are working with BuildGraph, we also have full support for working with BuildGraph. And if I go into one of my sample projects here, we can look at a build that finished earlier. I'm not going to show you a full working running build pipeline because it takes a long time to run. But if I switch to the dependencies tab here, we can see a visual representation of the whole build pipeline or build chain. So we're building the editor and cooking the game. So we're building for Windows and Linux. And on the configuration side of things, if I go to the configuration for this job, we can see that there is a dedicated option when you add a build step to choose Unreal Engine. So that's fully supported out of the box on TeamCity Cloud. And if I show you the configuration here, we have a Unreal build step, and I have chosen to run the BuildGraph command, and I'm pointing it to my BuildGraph script inside of my project, and passing in a few different parameters like the client platforms I want to build for, the server platforms, and the target configurations. More importantly, though, I have selected the distributed mode, and what this allows you to do is when TeamCity passes your BuildGraph script, it's going to distribute all of the different jobs across all available build machines that you have connected to TeamCity. So you're not just running this build on a single build machine, you can run this on several build machines and split up the workload so you have a much quicker overall build time. So with BuildGraph, if I go to my IDE, we can see I've got the BuildGraph script open here. If you're not familiar with BuildGraph, what this essentially means is you can define all the different jobs in here. So all the different agent tags define all the build different parts of the build pipeline. So we've got a node here for building the editor and the tools for a particular platform, and that platform is one of the options being passed in here. So what we're doing is we're passing all of these different agent tags inside of the XML file, and that gives us the dynamic build pipeline that we see on the screen here. So I've not needed to do any additional configuration for each of these jobs. This is fully automatically populated from our build graph script. So taking a step back, let's first of all look at the Lyra project configuration. So in the project settings, we can see I can define various VCS routes, and we can see that Perforce is one of the supported options, as well as Git. So you can come in here, add your streams as needed. And for this particular job, if I go back in here and we look at the dependencies, as well as looking at the build pipeline view, we can switch to the list view and see all of the jobs that were executed in this particular run. We can see that there were some tests executed. I can click on here and then see the exact tests that were run, and you get the results, and you can also expand them if there's a failure, and you can see the reason why that particular test may have failed. We're also storing build artifacts on TeamCity. So if I hover over some of the artifact icons, you can see the like the Linux server zipped up here, as well as the Windows client associated with the job down here. So TeamCity retains all of the artifacts, as well as retaining all of the test results and build results. In terms of how these jobs are executed, we have the server here, which holds the whole configuration for the TeamCity project, but you then have one or more build agents, so build machines that are responsible for running those jobs. So if I switch over to the agent screen, we can see I've connected some self-hosted agents. So with TeamCity Cloud, we do provide cloud agents for you, but if you want to use Unreal Engine, you need to connect a self-hosted agent, which could be your own internal build machine. It could be an agent running on AWS EC2. It's completely up to you. And if you are using cloud agents, TeamCity can also automatically start and stop them, so you don't have those build machines running 24/7 and incurring more costs than needed. So I've got two build agents I'm using for the demo project today. I've got a Linux agent and a Windows agent. These are running on AWS. On the parameters screen, we can see all of the different parameters for the build agent. If I search for Unreal, we can see that there are some specific Unreal Engine parameters. So we've defined a shared directory so that all of the build agents are sharing this directory between them. So as we're building out the build pipeline, running the different jobs, all of the dependencies, all of the build results are being shared between the different agents. We've also defined a type here, and this determines which parts of the pipeline can be run on this particular agent. So I've assigned it the compile Linux, cook Linux, Linux types, and that means that all of the Linux jobs will run on this agent. So that determines where the build will be executed on. So this is using a shared FSX volume. That's how it's being configured. So one of the other cool features that's going to be released soon is we are working on UGS integration as well. So if I come into my UGS demo here, I'll show you what this looks like. And I have a kind of replica of my normal build pipeline, but I can actually run this now. It's been trimmed down, so it's just running some kind of sample commands. And I can run this. And because we've got UGS integration being released soon, this is a very early preview, I can switch over to my Windows machine here that has UGS running. And if I zoom in, you can see I've got all of my commits from Perforce listed here. I committed a file earlier, an update to the README file. And what we'll see is, if I scroll over to the right, The actual results, the badges, will be populated by TeamCity as the build is running through. So we'll wait a few seconds for that to happen, and we can see the badges are starting to populate. So you've got the compile editor Linux, we've got the other jobs that are also waiting to run. So if I zoom out again, and you can actually click on one of those badges within Unreal GameSync, and that will take you straight to that build over in TeamCity. So you have the direct linkage from UGS over to TeamCity. The status of all of the jobs is reflected in here as they're being executed. So the green badges are gradually populating in UGS as all of the different parts of the pipeline are executing. And let's look at how this is configured. So on the configuration, I can go to my Unreal build step. And down here, we've got the option to post badges. Like I said, this isn't in the current version of the release plugin, but it will be coming in the next month or two. But with this selected, you can then specify your metadata server. So TeamCity will push the statuses to the metadata server so that UGS can show them. If you're not using Build Graph, though, one of the other options we support, if I go and add a brand new build step and I choose Unreal Engine, you can also define your commands manually. So rather than do Build Graph, you can choose Build, Cook, Run, and you can configure the Build, Cook, and Run commands directly inside of the TeamCity UI. So for build, for example, you can expand this. You can choose the build configurations. You can also choose the target configurations, the target platforms. So we try and make this as straightforward as possible to configure your Unreal build pipeline inside of TeamCity. And if you prefer not to do all of this configuration inside of the user interface, you can also define all of this through code. And in TeamCity, we support Kotlin DSL, so configuration as code is done through Kotlin. And if I click the View as Code button, we can see a preview of what the equivalent configuration would look like. So we've got a command here for build graph. We can see all of the different options and the parameters that have been set. So if you aren't using build graph, you can still push the status of the build over to UGS. So there is a build feature called the commit status publisher. And if I choose the publisher as UGS metadata server, you can define your URL, the badge, and the project, and this will push the statuses for you to UGS. And if I switch back to my Windows machine, we can see that all of the badges are nearly populated, which is cool. In TeamCity, some general features. We do have a lot of additional features you can enable on a build pipeline. For instance, we have like a build approval feature. So if you want to gate part of your build pipeline, maybe the deployment stage, you can add approval rules for particular users. So I could say that Matt needs to approve this job before it's executed, which is quite useful. We also have a build cache feature. So if you need to be able to cache some dependencies between builds, perhaps you're using single-use build machines, this can help you cache dependencies between the different executions. We also have full support for notifications. If you're working with, or if you're using Slack, for instance, you can send Slack notifications to a channel. So as the build pipeline is being executed, you can trigger notifications to a particular channel or a particular user. If you're executing lots of tests, we do also support parallel tests, and this helps you to split up the test workload across multiple build machines, and that shortens the overall time it takes to run the tests. We also have a performance monitor feature, and this is really useful for monitoring the performance of your build machine while the build is running. So TeamCity will actually collect the CPU usage, the memory consumption, and disk I/O while the build is running on your build machine, and show that in a graphical representation in the user interface. So really useful way to see whether your build machines are adequately resourced for your jobs. So just a couple more things. If I go to my configuration here and look at the trigger screen, you can add automatic triggers for your builds. If you want to run a build automatically every time you trigger a build, every time you make a commit, you can choose the VCS trigger. And what this will do is when you make a commit to Perforce or to Git, you can trigger an automatic build over in TeamCity. You can also set up schedule triggers. If you want to do, for example, a nightly build, then you can define a schedule trigger inside of here. If you want your build to run on a particular type of agent, there is also the agent requirements screen, so you can add specific requirements for where the build should be executed. So if you want to run the job on a high-spec machine, maybe where it has a large number of CPU cores, you could add a requirement for a particular number of CPU cores, such as 64, and that will add a requirement for a high-spec machine. So let's look at the finished build again. So we've got the finished build that I ran yesterday. We can see the commits that were included. We can see all of the changes here. On the build log tab, we can drill down and see the build log for each of the jobs. If I click on one of the jobs here, we can see the build log for that particular part of the build pipeline. So we can see we're setting up the tool chain. We can see the compile tools, and it's grouped by the different sections of, or the different steps within that particular job. If you're producing artifacts, those artifacts will show up here, and you can also view the entire build chain or build pipeline through here as well. And then finally, on the parameters tab, you can always go back and see exactly what state the build was in when this was executed. So this will show you the config parameters when the job was executed, as well as the parameters from the build machine. So you can always go back and see under what condition that build machine was in, what dependencies were installed, the versions, path variables. So if something changes between builds, it's more obvious through this UI. Okay, I think that's everything from my side. So, Matt, are you there still?
Yes, I'm still here.
Awesome. So I guess, yes, sorry, go ahead.
No, I was just going to say it's a fantastic overview of TeamCity there. I think it's a great platform and tool for working with Unreal. There's a lot of very useful features which are kind of built in to support Unreal directly.
Yeah, that's true. And as you can see, I've been using the nice dark themes. So if you prefer a dark theme, that is one of the options that we support. Yeah. And one thing to mention, if you would like to try TeamCity Cloud out yourself and configure your own Unreal project, if you go to this address, you can sign up for a free 14-day TeamCity Cloud trial, and we pre-install the Unreal Engine plugin, which means you can come in, you can create an instance, you can add an Unreal build step and connect your own self-hosted build machine and try running a Unreal build through TeamCity.
That looks cool. Thank you both. Actually, you just showed how to switch the team in TeamCity, and Matt, that was the command to you as well while you were presenting. Our audience actually notice you're using the light team, so maybe you could shed the light.
See, I'm team light theme. I like light theme.
Okay.
It's good. Light theme's good for presenting as well. It gives you a nice, good contrast and everything. But yes, of course, we've got a dark theme. We've got plenty of other themes which you can do. And if we can bring up my screen a second, if I switch over to me, then it's very easy to actually change that as well. If I use my keyboard shortcut again for actions, and yep, if I just type quick there, I've got quick switch scheme, which is easier to type than it is to say. And that kind of gives me then a bunch of different options. I can change the theme itself, I can change the editor color scheme as well, key map and so on. theme is a good one there. If I just highlight that, then I can quickly change to dark or light. I can swap between them. We've got sort of different options there as well, so you can do that. So if you want to use like a Visual Assist style or Visual Studio coloring that you're familiar with, then you can use that. What I like to do, though, even a bit more than that, if you go into settings, the appearance, what we've got in there is there is an option to sync with the operating system, and that's really nice. I've got the my operating system set up so that it's light theme during the day, and then in the evening, at sunset, it automatically switches over to dark theme. And Ryder can do the same. It can sync with the operating system. So if my operating system is in dark mode, then the Ryder itself will be in dark theme as well. So you kind of got a nice bit of options there. In fact, with that, you can then decide what particular theme you want it to be for dark or for light as well. So that's nice. But this kind of quick switch scheme is quite useful as well, because you can change the editor color scheme. And so you can actually change it to be, well, let's go, you can go crazy if you want to and put in a dark theme. Oh, no, I did that wrong. You can go crazy and have a light color scheme with a dark theme. And so if you really, really want to upset lots of people, then you can have a dark theme for your IDE, but a light theme for your actual editor as well. That's actually upsetting me. I've got to change that back. That's just not right. There we go.
That looks really cool. And syncing with the iOS settings means that you will definitely know that the day is over in your editor. You'll never miss that, right?
Yeah, exactly. When it's dark theme, it's time to go home.
Yeah, looks cool. Yeah, also there was another question, and kind of Daniel mentioned that there is a support for Perforce in TeamCity, and he was like showcasing this, the Perforce integration. What about Ryder? So you were using Git, I suppose, and there was a question if there is like a Perforce integration, Perforce div. So maybe you can say a few words about that.
Yeah, absolutely. So Ryder has great support for Perforce, and it will just work nicely there as well. So we can we can use the same sort of features that you'd expect from version control with Perforce. So we can see the current change list. You can edit change lists. You can move files around and so on, and also view diffs as well. As you'd expect. Pull data from the server and so on. You can work in offline mode and can automatically switch it to that between the two there as well. So yeah, great support for Perforce, and yeah, we're always sort of looking to see what we can do to improve things and make life better for people using Perforce there as well. Unfortunately, I couldn't demo that today. I don't have I was going to use a Perforce demo, but unfortunately, the version of the project that we're working on doesn't work with the modern version of Xcode, which the Mac is using. So thanks to version mismatches, I had to use a version in Git. But I would have liked to have been able to show Perforce. Maybe next time.
Yeah, and I guess quite many users of Ryder, because many of them are working in game dev, and for sure many of them are using Perforce, which is one of the most popular version control, especially like in AAA and big studios for many reasons. There are reasons for that. So yeah, and I guess there are lots of improvements coming every release to the Perforce integration.
Yeah.
Yeah, thank you. And also talking about like the TeamCity, we actually had a nice demo yesterday with the TeamCity and like Unity integration, and we had a very fantastic and inspiring Kotlin coding session for about an hour, looking at how you can do all this magic in Kotlin. And I wanted to ask Daniel, so like Kotlin might be maybe not a very familiar language to some of the game developers. Are there any other options or coming options for doing the same job?
Yeah, good question. So yeah, Kotlin isn't necessarily the first language you think of as a kind of configuration as code option for CI/CD. I would say it's very capable because it's a full programming language, so you can add lots of complex logic inside of your config as code file. Like you could have like a for loop and dynamically create lots of different jobs as you iterate over them. We do have some learning resources, so we have the full documentation for Kotlin, and inside of your IDE you can also get full code completion if you're using like the JetBrains IDEs. We are looking at other options though, so one of the initiatives we have on the TeamCity team is something called TeamCity Pipelines, which is a reimagining of the TeamCity user experience. And in that kind of lightweight CI tool, we are actually supporting YAML. So YAML is one of the options we're supporting in pipelines. So it doesn't necessarily apply to the demo I showed today, but in the future, YAML might be more sort of commonplace inside of TeamCity.
Yeah, cool. Thank you. It's always good to have like some kind of variety. Well, personally, I think we're from JetBrains side would definitely vote for Kotlin, but other options are so cool. Yeah, and so like if you missed yesterday, so for all the audience, it was a great demo and like great coding demo, and you could learn a lot about how you can configure that for Unity if you're from the Unity side. I'm talking about the engines maybe and like TeamCity integrations. Do you have any plans for any other engines maybe and any specific support to extend it beyond like Unity and Unreal Engine?
Yeah, so Unity and Unreal are kind of first-class citizens at the moment. We have done demos previously of Godot, but that's just using sort of basic command line build steps and running them inside of a Docker container with the Godot engine pre-installed. That might be something we release in the future, so maybe a Godot-specific build step, but for now it is possible to build Godot projects using TeamCity, and we are planning to release a blog post on how that can be done soon. Yeah.
Oh, sounds cool. I'm going to read that. I think we'll have more Godot for the day today, so there will be people talking more about the Godot, and there is some like Godot boost in Ryder as well. We just recently released the our own support for Godot script in Ryder 24.2. I guess that was the version. Yeah. Okay. Cool. So I don't know, Matt, Daniel, do you have any other things you would like to highlight still in regards to this topic?
Well, I think just to build on what you were saying there with the Godot support. I mean, if anybody's using Godot, please try out the latest version of Ryder. There, there is some great support in there. We've added support in for GD script, but not just for the code completion, syntax highlighting, and all that kind of stuff. We've also got support for debugging it as well, and that's really quite nifty. So you can connect to your game and you can debug. You can obviously step through and work through your code with Ryder. And it's been very interesting watching that happen because there's been some limitations to the debugging protocol that we're using, in that it doesn't always show you full information there, and there have been therefore updates to Godot itself to be able to support that. So as Godot itself is changing there, we're going to get more capabilities in Ryder for debugging as well. So it's a very nice sort of nice to see that happening from the Godot side of things. It's fantastic to get that kind of support.
Yeah, I agree. And it seems that all our tools become more engine agnostic, which is good.
Yeah, having Ryder being able to support all the engines it is great. It's a very useful thing.
Yeah. Okay, so I think that maybe we could thank Daniel for his part of the presentation, and then continue with you, Matt, and introduce our next speaker.
Awesome, thanks so much.
Yeah, thanks,
thank you, Daniel.
Yeah, I noticed there's another question there as well. Actually, someone was asking about keyboard shortcuts. I believe this is again. It was asking, as you're saying, we've got a number of keyboard shortcuts in Ryder, and the useful ones there are kind of Shift, and Alt-Enter. They're the same across all the different key maps and everything. And there's a bunch of keyboard shortcuts for things like rename and all the other refactorings as well. So you can basically, we've got hundreds of keyboard shortcuts, and you can do anything from the keyboard. If you're using the mouse, you're doing it wrong, basically. But the question was, if they coming from another tool, they might have a bunch of muscle memory and be used to existing key maps, and what can we do with that? And the nice thing is the Ryder comes with a bunch of different keyboard key maps. So we obviously have the sort of the classic traditional support for the key maps, which are in use across all the different IDEs. So Ryder is built on top of the IntelliJ platform. So if you're familiar with WebStorm, IntelliJ IDEA, PHP Storm, whatever, then you can share keyboard shortcuts across all of those. But we've also got keyboard shortcuts for things like Visual Studio and Visual Assist and so on as well. So if you are familiar with another tool and you want to use those key maps, we can then very quickly, very easily change that in Ryder, and you're good to go, basically. So it's very flexible. and you can do that. And of course, you can assign
that's
your own
magic.
keyboard shortcuts as well. Yeah,
Yeah, that's absolute magic. I came to IntelliJ from Vim, and so Vim emulation mode is, yeah, that's me. I'm from the Vim camp.
Oh, yeah, I'm very much in the Vim camp as well, and I'm going to obviously take the opportunity to plug IDEA Vim, which is the plugin which provides Vim support for the editors for across the board, whether it's Ryder, IntelliJ IDEA, and so on. It's a great plugin. It gives you a great set of Vim functionality, all of the editing facilities, your text objects, and all of this kind of stuff. Don't get me started, basically. I don't talk.
Yeah, I think it's time to bring our next speaker, right?
Yes, just to stop me talking about Vim.
Hello.
Hi, Ilya. How's it going?
Hi, everybody. I'm also using Vim.
Oh, so this
Yes.
is our Vim camp. Good.
Yeah,
Yep.
exactly. So enough with Game Dev Day. Let's just have Vim Day, I think.
Yeah, I love that.
Yep.
Okay, but seriously speaking, I'm so much impressed by the next topic. At least it sounds great for me. So, like developer experience in mobile game dev, how we rebuild a plane in flight. I mean, I would like to listen to that. You, Matt?
Very much so. I'm looking forward to this one.
Okay, so then let's start.
Okay, thank you, everybody, for letting me present you the presentation about developer experience, about PlayerX, about how we change the developer experience in our company. And I hope this information will help you in your own company to understand the importance of the developer experience as a whole process, and maybe to take some recipes or tips and tricks from my presentation and implement it on your own projects in your own companies and make your developers more happy and more productive. So let's start. My name is Ilya Bogin. I'm working at PlayerX and I'm a technical producer. I will say a couple of words about what is exactly the technical producers at PlayerX a little bit later. But let's start from the PlayerX. I hope that most of you has already known this company and maybe even play our games, maybe even on a regular basis play our games. But if you have not know anything about PlayerX, let me give you some brief numbers and brief description about what the PlayerX is. We are the #1 mobile game publisher in Europe. We have more than 3,000 people who are working on those games, and our players, our active players number are much more than 100 millions of people per month. That's very, very large number. So yes, we have a lot of work to do and a lot of games which we have worked on. But let's look at the PlayerX from the developer point of view. What are the PlayerX? What is the PlayerX if we are a developer or if we are in charge of developers inside of the PlayerX? We have more than 10 different projects at different stages. Some of them are major game projects that has already been launched and have a very large number of players. Some of them are just started their way to the success, and some are at the middle. If we talk about the number of the developers, we have more than 500 contributors. We are using GitHub as a repository, so the number of GitHub contributors are from 500 to 1,000. It depends how we measure it, whom we included and whom not. We develop the games based on our own game engine. It has both advantages and disadvantages, of course. From one side, we have the full control of everything about the game engine. We can improve the performance, we can add the features when we want it and how we want them. But we are at the full responsibility of what happened with our engine. So there is no somebody who can fix or improve or add some functionality if we do not do it by ourselves. Our projects are about several millions lines of code if we talk about the project size. And our main platforms for the players, iOS and Android, of course. Also, we support the web. But if we talk about the developers, they are mostly worked with builds on Windows, macOS, or Linux. So we have to support a large number of different platforms as a build targets. And our release cycle is about 1 per 6 weeks. And we want to improve it, and we want to submit our games more often, but let's talk about it in detail a little bit later. So this is some information about the Playrix and who am I? I'm a technical producer. I'm not the developer, and I'm not the engineering leadership, so I'm not the head of engineering or some head of some development team. I'm more like a product owner, but from the technical point of view. So I am responsible for the strategy, for the formulating what should we do as a technical platform and how we should implement different development practices, and then help the teams to use those practices in their real work. So this is what technical producers are doing at the Playrix. Now let's go to the developer experience. Developer experience is a very, very broad term, and even we have not the short name for developer experience, which are used by everyone. Different companies, different peoples use different terms, DevX, DevX, DX, and also there are different names for almost the same thing as a developer experience. Some named it engineering effectiveness. Some named it engineering excellence. Also, there are the term from the LinkedIn, which I used in the LinkedIn company, and I'm also fond of this name, developer productivity and happiness. Why do I like it? Because it describes what do we want from developer experience. We want our developer to be productive, and we want them to be happy. So there are different names, different short names, but when we talk about developer experience, everybody, maybe not everybody, but most people agrees that when we're talking about developer experience, we are talking about productivity and the satisfaction of our developers. Let's start from the developer satisfaction. Why it is important for us? No, first of all, we love our developers and we want them to be as happy as possible in our working environment. The second reason why it's important for the company is because of the developer retention. Because if the developers are not happy in our company, they will change the company. And our turnover rate, attrition rate will be much higher than we want. And to getting the new developers is a large, is very, very complex work because first of all, you need to find the developers, and when you have found him and get him to your company, you need to introduce him to your working environment, to onboard him, and this can take a lot of time. It can be even months for the new developer to get to the optimal performance stage. So if your developers goes away, your overall performance will not be at the optimal stage. It will be every time it will be near the middle, and it is not what we want. Also, the last but not least is that the developer dissatisfaction can be the top of the iceberg, and the problem can be much more bigger and much more complex. the underwater part of the iceberg can be that you have very high level of the technical debt. Maybe you have very non-optimal processes. And if you focus and try to understand why your developer are dissatisfied, maybe you will be able to find the main problems inside the organization that prevents you to develop faster, develop better, develop with better quality. So developer satisfaction matters, and it is very, very important. But it's hard to measure. Let's talk now about the productivity. I want to introduce you the quote from the Laura Tahoe as the CTO of DX company. It highlights very, very interesting problems about developer productivity. If we ask different groups about what the developer productivity means, we can receive very, very different answers. If we ask the engineering leadership, they will tell us about the value, about how much value we generate, about whether we will be able to ship the new features at the right time. Are we working efficiently? But if we ask the same question to our developers, they usually gave us very, very different answers. They will talk about how much code have we shipped in terms of code, in terms of lines of code, in terms of pull requests, in terms of tickets. And this is a very, very different metrics. We can try to summarize it as two kind of develop productivity metrics. Some of them are value oriented. So we try to estimate how much value we achieve during our work. And other metrics are process oriented. They tell us about how optimal and how fast are our processes of code and feature delivery. What should we do with these different type of metrics? The engineering leadership, as you remembered, would like to use value-oriented metrics because they are more important to the company. The company wants to bring the value to create the new games, to add the new features to the games, to ship these new features as fast as possible. But when we are talking with the developers, we are talking mostly about the process-oriented metrics. So process-oriented metrics is required, but they may be not sufficient enough to get the good value-oriented metrics. But there are main consequences. If we had bad process-oriented performance and bad processes, so we have non-optimal delivery process and we have slow delivery process, we almost impossible to achieve the good value-oriented performances. It's hard to get the value to the company, to our gamers, to our players, if we do it in very non-optimal and in very, very slow way. So yes, we need to achieve the process-oriented performance and to improve process-oriented performance as much as possible, but we should understand that it may be not sufficient. So we cannot just stop at this level and say, okay, we have shipped as many PR, as many code as possible, and that's okay. That can be not enough to get the real value. And this is the important point. So I hope that you understand that the situation is rather complex and we have a lot of problems when we try to do anything with the developer experience. We do not understand what exact metrics we should use. We do not know how we can measure either productivity or either satisfaction. And also, we do not know yet how we can influence what should we do to improve these areas. Because to do something, we need an object. We need an object which we should focus on, which we should improve. So let's talk about it. what are the objects which we can influence when we talk about developer experience, with what we should work to improve the developer experience. There are different approaches of trying to understand what are the objects when we're talking about developer experience. There are, of course, the space framework, and we will discuss it a little bit later. But I am fond of the following framework, which divide the developer experience on the three main areas: feedback loops, cognitive load, and flow state. Let's try to understand what are they exactly. Feedback loops is the processes when the developer receives some feedback about the changes that he has made. For example, our build or our test failed. This is a feedback. Or QA checks the feature and finds some additional bug. This is also the feedback. Or we have the crash report from the production stage. This is also the feedback loop. We have received additional information that helps us to improve the code quality, to change it, to make it better. The cognitive load is the area about how complex is for developer to introduce the new changes. What are required? How many steps should be performed by developers to implement the change and to deliver the change? And also the flow state. This is the area about the optimal state. Are we at the optimal state of performance or not? Maybe we can do better, but something prevent it. So what prevent it and how we can overcome it, this is the area of the flow state. It can be a little bit complex. So let's try to describe it on some example which are not connected to development at all. For example, we want to get some packages from the location A to location B, and we want it to be done as fast as possible. What can help us, or what can be the problem during this way? First of all, feedback loops is about the roads itself. They can be straightforward from A to B, or they can have a lot of detours or some complex roads. And of course, the more straight and the more easier is the road, the faster we can get from point A to point B. The cognitive load can be described as the quality of the road. If the road quality is good enough, we can move as fast as possible. But if it's not good enough, we cannot move as fast as possible, and we need to slow down because the quality is not very good. And the flow state is about interruptions. If there are a lot of traffic lights during our way, and we need to stop at each traffic light, we cannot get from point A to point B very fast. But if we have the green line, when all traffic lights are green, then we can move much, much, much faster. I hope that this metaphor will help you to understand what are exactly feedback loops, cognitive load, and flow state. But how do we use it in a process of improvement the developer experience? Let's go deeper and decompose the feedback loops at the different stages. So what are the different feedback loops which are used in almost all of the projects and which are also used in Playrix in our game projects? First of all, the first feedback loop, almost first one, is the local build and testing. So you receive the feedback whether your changes has been able to compile or have been able to interpret it if you use interpreted language or transpiled language, and are your local tests are green or broken. Then, when you have finished the changes, you can make the pull request, and usually there are some builds that are running upon this pull request to check its quality, and there are also code review by your peers or by your team leads to check some additional qualities, attributes, properties of the changes that you want to make. After this, there are at some point check by quality assurance, or also the check from the product management, who tries to understand whether this change is really doing what they wanted to do or not. And also there is feedback from the real users and some product and technical metrics from the real product after it's submitted. So these are the different feedback loops. And of course, they have different metrics. So we can measure the performance of each different loop and can try to improve the speed of each of the loop. The better will be the speed of each loop, the better will be the overall productivity, the better will be the time to market of our features. So what we have done at Playrix? We have started to measure all these types of all these different steps of feedback loops, but also we decided to introduce the concept of green master because we think that it is very, very important to make the feedback loops as fast as possible. But let's first try to understand what is a green master in our terms, what we try to achieve using this approach. We say that our branches are green if, first of all, they are ready for development of new features. Every developer can check out this branch, make the new branch, and start the development. There is nothing that stops him. For example, if the branch does not compile, it really stops you. You cannot try to add new feature if currently the master is your branch is the broken state, it cannot be compiled, and you need to wait for the fix. The second main properties of the green branch is that it should be ready for testing. The quality assurance or automation test should be able to be launched at any moment to check whether we are ready, for example, for submit, or whether one of the feature are ready to submit or not. If they cannot do such a work, we cannot move faster. And how it influences the overall time to market and overall performance. If we implement the green branches, when we talk about the green branches, we usually talk about the green master branch and the green release branch. But this term can also be applied to some other branch. For example, you can try to make almost all of your branches, the feature branches, the team branches, if you use them as a green. But we are focused on master branch and on the release branches. So one of the main properties of the feedback loops is that they are ordered by timeline, and the latest feedback loops require much more time to be if something has been broken than earlier feedback loops. So saying it a different way, if some problem has been found only at the latest stages, for example, in production or only during regression before the submit, it requires much more time and much more resources to be fixed. And if you will be able to find it and fix it at the early stage, you will spend much lesser time and much lesser resources. And the green master help us to shift these quality gates, shift the number of problems that we have found at the earliest stages as possible, before the changes has been merged to the branches. So this is why Green Master is important. And if we implement it, we will be able to drastically increase the overall speed, because we will spend less time on fixing the problems, because we will be able to find them on the much earlier stage before they have been merged to the main branches or release branches. So we decided that we need Green Master, but how we can achieve it? We cannot say, okay, now the master and release branches are green and everything will work. No, we need to do something to make it work. We have chosen the 10 steps which should be performed by the project one by one, from point 1 to point 10, in this order, to achieve the Green Master. Each project uses this as a path, as a plan, and move with its own speed during this plan. And the platform team, the developer experience team, helps the projects to move through these stages and to implement all of these required changes. So if we are trying to achieve something, it will be very helpful if we can measure whether we are already at this point, or how long should we have to go before we have been able to achieve the Green Master. So we introduced the Green Master metric, and it told us how can we calculate it. We calculate it on the basis of how much time per month the controlled branch has been green. How we can measure it? We create the regular builds. In some companies, they call nightly builds, top-notch builds, that are launched on the regular basis, once per day, or maybe several times per day. And if this bundle consists of different builds, it can consist of 10 builds or maybe more, and has some complex dependencies inside of it. But if any of the builds inside this regular check bundle has failed, we treated the overall check as failed and said that this branch has been broken. Then we use a pessimistic approach to estimate the time, how long the branch has been broken. We measure that it has been broken from the time of the last successful build until the time of the next successful build. All of this period we threaded as a period of broken branch, and it will decrease the percent of time when the branch has been green. And we use it as a target. We use it as a metrics of how close are we to the Green Master itself. So we choose the targets of what we should do to improve the feedback loops and how we should measure our progress through this process. First of all, this is a Green Master, which we have discussed before, and our target is 100% of green state. We want to be at this point. And the second and the third metrics are the time of local build and the time of the PR bundle. We have a target about 1 minute average for local build time. We want, in average, the local build time to be under the 1 minute. And for the builds, for the bundle, overall bundle, which launched during the pull request check, we want it to be near 1 hour. Also, this is a interesting point. Should we do PR bundle less than 1 hour or not? Of course, if we make it more faster, the overall time to market should be a little bit faster too. But it can maybe you should add additional checks, additional builds to this bundle, because if your green master is not green yet, it means that you should add additional checks to the earlier stage, to the pull request bundle. And if you are not yet at the 1 hour, maybe you should add additional checks and not decrease it more, because 1 hour from our point of view is good enough. And if you make it faster, maybe you should add additional checks, create additional automation tests, increase the percent of smoke, etc. So this is our targets. Also, I would like to highlight some problems with choosing the right measure. We have talked about we should measure the build time, both the local build time and the pull request build time. But how can we measure? What we should use as a measure for this time? There are different approaches. We can use average or mean, it is the same. Or we can use, for example, the percentiles, the 50th percentile, P50, or 95 percentile, P95. What is the better? What should we choose? The mean, the average value, is much more descriptive, because it's much closer to the overall experience. But it has a problem of high noise, because when we talk about measuring the duration of some processes connected with the build, it's a long tail distribution. It has very, very long tail, and the average in such case can give you very, very noisy results, because some rare builds, but with a very high time, with a very high duration, can bring your mean, can give also the peak at your average level. And it's very hard to check whether you improve or not if there is a high level of noise. So there is a problem with the average, with using the average as a measure. The standard way in such situation, use the percentile, because the percentiles are much more better working with noise. They're not affected by the rare peaks because of their nature. They just take all the builds before, and they are not looking at the builds which time are more than, which are for example the 5% of the lowest build, or the 50% of lowest build. They are looking only on the fastest build when calculating the real value. But the problem with them is that they are not very descriptive. You can see the real value from our charts, and you can see that P50 is very optimistic. It's not getting us any information about what are the experience of the 50%, is this very, very large number, of the 50% of more lower builds. They may be very, very low. We don't know, because if we look just at 15 percentiles, the P95 is very, very pessimistic. It's also not very descriptive, because you can see currently it displays us 20 minutes, and this is not the real experience. This is a rather rare experience. And if we improved it, for example, from 20 minutes to 10 minutes, it does not tell us any information about the real experience of the users. Maybe they will stay the same in terms of average value. And maybe it gives us worse average value or better. So working with a percentile also has its own disadvantages, but they are much, much better working with the noise. And we decided to use a little bit uncommon metric, which named Winsorized mean. What does it mean? The Winsorized mean. We for the builds, for the values that are larger than P95 value, we do not use the real value. We use a saturation at P95 value, for example. You can Winsorize on different levels, but we use the P95 saturation. So if there are rare builds with a high duration, they will add to the average value, not their full value, but only the P95 value, which is 20 minutes in case of this chart. So this gives us the both advantages. It is much more, it has much lesser noise, but it is very descriptive because it describes the real experience of the user. So what we are doing exactly, what the steps are we performed to improve the feedback loops. First of all, we try to implement the 10 steps to achieve the green master, and also we improve our build time. To improving the build time, there are 3 main areas, and we try to do different projects in each of this area. First of all, you can try to do it faster, try to build faster. You can use more powerful agents if we talk about the, for example, TeamCity, or you can improve and upgrade the local computers for the developers. And so you can try to do it faster. You can try to profile the build, to find the bottlenecks, and also to improve it. So this is about do it faster. Also, the important approach is to try to reuse the previous results, because usually builds are not launched once. If we change something, we regularly build it. The PR bundles are regularly rebuilt on the same branch with the different additional changes. So if we can reuse the results using the local cache, the distributed cache, it can decrease the time required for rebuilding this build. And also we can try to do it in parallel. If we can decompose it on different steps, on different jobs that can be launched in parallel, we can do it much faster. And we have done the projects in each of these stages, in each of these areas. At this slide, there are some tips and tricks that we have tried, that we have achieved as a new knowledge during this process. I will not get in detail because we not have very large time. But during the Q&A session, I can try to answer your question, or you can try to connect with me, and I will also answer you and give you more detailed description about these tips and tricks and what we have achieved. Okay, I think this is all about feedback loops. Let's go to the next area, to the cognitive load. First of all, what we want to achieve when we talk about cognitive load. We want our developer to be at the following state. I, as a developer, fully understand what are required to implement these changes. And all the steps are automated as much as possible. I do not need to do a lot of manual routine steps to finish the work. What's the problems? It's hard to measure and it's hard to improve. Let's try to decompose it. We have asked our developers and try to find the main areas connected with the cognitive load that can be improved, that affect their work. And we have found the 3 main areas. In your case, it can be a little bit different, but at Playrix, these are the 3 main areas that that are non-trivial, as they require a lot of additional cognitive load. First of all, this is a setup of the new target platform. The second one is to find the info how to implement the change. And the third one is to implement the change itself because of the complex architecture of our project. And we have started with the knowledge management. This is about the information, getting in the information of how to achieve, how to understand what should be done. What are the main problems during this way in trying to find what should be done and how can we do it? First of all, the information in a big companies, and Playrix are very big company, the information is scattered through different sources. There are a lot of different wiki-style documentations. There are Slack channels with a lot of additional information. some information are kept as the comments, in the comments or in the README files. And it's not easily understandable where should I go to find how to do something. The second problem is that the search results can give you not the one answer, a number of documents, and to get the real answer, you need to combine the information from those documents. The third problem, we do not understand the quality of each part of the documentation, of each part of our knowledge, because it's very, very scattered, and we do not understand what exact searches has been done, and whether the author of this question have found its answer or not. And also because currently most of the company are spread around the world, and we are working in a distributed team, in a multi-language team, there is a problem with the language because people speak different language, and it is also the problem. So how to fulfill these problems? What we should do? We think that we have found the silver bullet. Of course, it's not silver bullet, but it looks very, very promising. We use retrieval augmented generation plus general LLM approaches to process all the documents, all the different sources. So we collect through connectors the information from all of the possible sources. It doesn't matter where the exact knowledge has been introduced. We use connector to get it to the same RAG vector database. Then we have minimized number of entry points. For example, Slack bot, web widget, maybe some additional integration through IP. We ask each user to give us a feedback. Because we have the minimal number of entry points, we can integrate the feedback solution to each of these points. And we ask everybody to press like or dislike if the answer of the quality is good enough or it's not good enough, and we should improve our knowledge. And it helps us to create a pipeline to understand what exact areas of knowledge are not sufficient and what we should improve based on uncertainties of the answers by RAG and LLM, and based on the user feedback through dislike. And also, it's language transparent because the modern LLM can answer in any language. It does not matter for them what language has been used as a source. They can easily create the answer on the target language. So it helps us as a language transparent solution. As for developer assistance, we are just at the beginning of this way. We are using Copilot, but we are not understand exactly what we are achieving, whether it really improves and how much it improves. So currently we are only at the beginning of this way to really improve the cognitive load by using the AI code assistance. Let's go to the flow state and why it is matter. If we are at the optimal state, if we're in the optimal stage and writing the code, and something interrupts us, we cannot return immediately to the same optimal state. We need some time to refocus and to get to the same state. Usual estimation, it can take up to 30 minutes to get in the optimal state. So if such interruptions are often enough, you can be optimal. It can be in non-optimal state all of the time. So what we have done to improve it? We try to control the number of meetings for our developers. We try to make them as effective as possible, for example, using document-driven approach. And we try not to interrupt all of the users. If there are some operational work, for example, it can be done by some developer who is on duty, and only he will be interrupted and not all of the team. Also, when we talk about developer experience, we need to understand how to make it work as a pipeline. Because yes, we can make certain projects to improve the feedback loops, the cognitive load, the flow state, but how to make it work as a pipeline with the constant improvement. First of all, who can work with the developer experience metrics and with developer experience solutions? It can be the platform team, who is responsible for developer experience, for example. It can be the engineering leadership, and it can be the team leaders who are working directly with the developers. What we want to create, what kind of pipeline we want to create. We want the team leaders to be the main leaders in this process. They should use their own team-specific dashboards to understand what happens with their own team. They should try to use the recites and implement it to improve the developer experience. And when they cannot do something by these recites, they should escalate this problem to the platform team. And the platform team should prepare such a guidance, should create such a dashboard and helps to automate to collect all these metrics. And the engineering leadership helps in this process to prioritize everything and to supply the resources which are required to fix the developer experience. So we try to move the focus from the development team and from the engineering leadership to the team leaders itself, because they are much, much closer to the developers and to their problems. Also, let's talk a little bit about metric frameworks, because it is much better and much useful not to try to create your own metrics, but to use the standardized metrics frameworks for developer experience. There are a lot of different metrics, but I would like to highlight the two different types of metrics: self-reported and system. For example, if we ask the developer, how much builds have you done through the day? And he answers us, I think it's about 10 or 20 builds. This is a self-reported metric, self-reported type of metric. If we use some special script which sends the event when any local build has been launched, this is the system type of metrics. Both of them are important because some areas can be measured only through self-reported metrics and some only through system. And when we have overlap, when we have both self-reported and system, we can get much more broader view on the subject. If we talk about the frameworks, the most famous one and the most used one are the Dora, Space, and DX. The Dora is the oldest one, and I think the most known, and I think most of us has been met such a metrics framework. But from my point of view, it's not very useful for game development and for mobile game development. It has been created for DevOps, and it is very operational. It is very focused on operational level, and it's not cover all of the problems and all of the aspects of mobile game development and game development itself. The Space has a very broad view, but it's not exactly about the metrics. It's about the areas which you should be focused on. But it's not told you about the exact metrics which should be used, for example, to measure the satisfaction and well-being of the developers. It can be used as a framework to think about developer experience, but it's not about the real metrics. The DX4 looking the most promising because first of all, it's about the real metrics that can be measured. And also, if you remember to the beginning of our presentations, I have told you about two types of productivity measurement. Measurements through value and measurements through speed of the process speed. And DX score looks on the both of the types of the metrics. The speed and effectiveness told us about the quality of our delivery process, and the quality and the impact try to estimate the value of our work. So it looks very promising, and it also includes the developer satisfaction through the effectiveness by using the surveys, developer surveys. So what next? Where are we at the project, at the Playrix right now, and what we are plan to do in the next stages? We need to finish all the projects, all the projects that we have started. We are not finished them. So let me use a quote of William Churchill. We are just at the end of the beginning of these processes. And we would like to try the DX Core 4 framework to overall to make the overall metrics for the overall processes. And we will make more focuses or making developer experience improvement as a pipeline and work at the team leaders level. And I hope that I will be able to meet with you maybe next year and tell you what we have achieved during this way and what interesting tips and tricks and what knowledge we have achieved, and we'll be glad to share it with you. So thank you very much for your attention, and I am ready to answer your question.
Thank you. Thank you.
Yeah, thanks, Ilya. It's a very, very interesting topic. I've got a question straight away there. Is this an ongoing process, or is it like a one-off process, or is it something you're going to kind of keep on doing, basically? I was unclear whether you. Sorry, I was just going to say I was unclear whether you've already put this in place, or whether it's something which you're kind of continuing to do.
First of all, if you are continuing the development, you need to continue the development experience improvement also, because it's not the process that can be stopped at some of the moment. They say, okay, now we are it's the best developer experience, and we can shut up the developer experience team. So yes, it should be done as a pipeline. As you have the continuous integration pipeline, continuous delivery pipeline, you should have developer experience improvement pipeline. And we are at the middle of improving the developer experience and to go from the projects to the pipeline. And I hope that in the near future we will be at the stage of the working with it as a pipeline, not as a number of initiatives.
Mm-hmm. So then a follow-on into that really is how often are you kind of evaluating these metrics? You know, do you have like a dashboard, or do you kind of have to sort of regularly sit down and look for this information?
Yeah, as I have told before, there are two kinds of metrics: self-reported and system. The system can be measured at the regular basis because they measure some processes. The script has been launched and sends the value to our dashboards, and it appears immediately. But if we talk about the self-reported metrics, we should go to the developer and ask it, how do you feel yourself? Whether it's complex to integrate new changes, etc., etc., etc. Of course, we want it to do as much as possible, but it's also the interruptions, because we talk about the flow state, we should minimize the number of interruptions. And if we interrupt the developers with a lot of additional questions, they will not have enough time to do the work itself. So yes, we should do it as a regular basis, for example, once per several months. Once per 3 months usually is a good enough. It's often enough to get the updated results and understand how your changes have influenced the developer experience itself, but it's not very often to make it noisy for the developers, because they want to work. They do not want to answer your questions. They do want to do the work.
Yeah.
Yeah,
no,
so
sounds
many
good.
actually inspiring processes, and like because we also do now revise some processes in JetBrains and put some new processes in work. I'm just wondering, how long did it take you to put all these processes in place? So how many, I don't know, months, years, days did it take you?
Months.
Okay.
It take months. But if we talk about the playrix, as I have told before, we have a number of projects. We have more than 10 different projects. So in our case, it is much more complex task because the projects are very different. It is a different team with different processes inside of the different developer processes. So we need to go to each of the team to understand what happened with them and how we can help them. If you have the single projects, of course, it's a little bit easier. So
Yeah, sure.
in such a case, it's not require years. Maybe it can be done in half a year.
Okay.
Or maybe
Yeah.
less.
Sounds impressive. Okay, we would like to thank you for the great presentation. I hope that people here learned many new stuff and maybe will improve their processes. So thank you, Ilya, once again. Thank you for joining
thank you.
us.
Thank you. I have been glad to be able to participate.
Yeah, thanks. Bye.
Thank you.
Okay, Matt. So before we move forward, how about playing another game?
Do you want to give away another license?
Yeah, why not?
Okay, well, we can do that. Again, we'll do the same thing. First person to answer in the chat will get the license. And let's have a question. How about what major franchise has just recently announced that their future games are going to be in Unreal Engine?
Yeah,
See if anybody can
that's
answer
an
this one.
impressive question.
It's a bit tricky.
A bit, but like if you are kind of into gaming news, yeah, I think we have a correct answer.
We do have a correct answer, and it's not Khalid. I'm sorry. No, Fortnite is going to become a Unity game. Surprisingly enough, no, it's not. It's not. But yes, the answer is Halo, and Halo is going to become an Unreal game, and they're going to be producing a whole load of more games, all based on Unreal.
Yeah, and so congrats to the winner. As I wrote you in the chat, just drop me an email to my mail address and you'll get your prize. Okay, so with that, I think we can move to the next topic. It's not the talk, but it's something more impressive, right? So it's Roundtable. Let's do that. Let's chat. Let's bring our fantastic guests to the stage. Yeah, great quorum. So many good people. Yeah, and also we can get our a few slides. Just I won't bother you with many slides here. Yeah, cool. So today we're gonna talk about the state of game technology, and we have experts like with different experience and different roles and different backgrounds here. And I think that's good for the roundtable, right? So when we get the people not from one area, not from one directions, but from different ones. So I suggest we discussed a few topics, but to explain to our audience where the topics are actually sourced from, I would like, first of all, to ask Chris to help me a little bit and to talk a bit about this report where actually we grabbed a few topics for today's discussion. So Chris, hello, can you please tell us a few words about this report?
Yeah, for sure. Hello, good to see you all. So yeah, this is our 4th annual Gaming Report. I work at Perforce. I'm their director of product marketing, and I look over their media and gaming verticals. So traditionally in these reports, we've looked at like the tools and challenges teams have in game dev specifically. But as you know, we've all seen, and as we're probably talking about here on these calls and sessions, is just that, you know, we've seen game technology expand just beyond like game development use, right? So we've seen, you know, game engines, the tools that work with game engines start to be used in use cases like virtual production, animation, building like HMI displays for automotive. And I know Anastasia will talk about that more in a bit. But we wanted to get some data on that, just like see how much game technology is making an impact for these teams. So we launched this survey. We actually co-launched it with JetBrains back at GDC this year and got a lot of great response. So we have over 576 respondents, 64 countries that are involved in this survey, and that culminate into the results we show in this report. So we touched many of the roles involved through those use cases, and there's interesting insights that we'll unpack today. But yeah, use that QR code displayed to get the full copy.
Yeah, thank you, Chris. It was a pleasure actually doing this nice report with Perforce. JetBrains is also doing like lots of researches around the ecosystem, and it was just an interesting experience for us to join Perforce in their effort and to grab some insights and to bring some like our vision also to the stage. So, okay, we will be just covering 4 topics today, and I invite our audience online also to join the conversation. So if you have any ideas or thoughts, just throw them into the chat and we'll read them through. And we will start with maybe a little bit unusual thing when we talk about the game dev, but we'll start about talking from where the game dev technology is actually used. Because if you look at the report, the first thing that actually spotted and attracted my attention was that it's not just games, it's so many other things. And I would like to say that I just collected here a few cases where the game tag is used not in gaming. And the first one was exactly that attracted my attention a couple of years ago when I noticed this, and I was like, oh, wow, so it could be used this way. So if you don't know about the case, it's like the film production and the like gaming technology used in the film production, like The Mandalorian, which was captured with this, amazing scenes just created with Unreal Engine and projected on a big sphere. And so all the actors and like they just look at that as they're in the real world. So this real world is just simulated by Unreal Engine. And I just took this as a new stage of like, a new evolution of the overall film production pipeline. So that looked quite impressive to me, but there are more cases of that, and there are lots of usages to the game tag. And I would like to
it's not just like virtual
Yeah.
production, like we're seeing it, animation, people are doing that in Unreal. I don't know if a lot of people here were at Unreal Fest, I'm sure, watching, and just so many talks there, just talking about the pipeline that they're using, with game engines to primarily Unreal in the animation and for visual effects space to, just really innovate there.
Yeah, that's true. That's true. And I don't know, maybe our other guests have seen other cases that impressed you in terms of the using game tag not in gaming.
Yeah, if I might go first here, I've seen this a lot. I've myself worked in AR and VR in the automotive space, and they're more in the simulation space. But what I've also seen quite a lot is the defense sector or the military space, right? And that is probably has a very, very long history. If you think about America's Army, if you think about Bohemia Interactive's Arma, which I think started or at least has a spin-off in defense, right? Where they do battlefield simulations, and obviously or I guess it's not represented in the study here because it's a very secretive environment, I think. But I think it's a very, very big thing there as well, because what we can do, a lot of the requirements are the same, right? In very low latency operations, high visual fidelity, and large scale simulations, right, that need to be very accurate. And I think game technology does help there a lot, right? Whether you like it or not, that's something.
Yeah, that looks impressive. Any other
Looking
cases?
at this, looking at this, to be honest, I was surprised that there's so little representation of film or television in this graph. Which actually, it's more of a mirror on the audience that is getting this survey, because there's way more film and TV. Like Unreal is everywhere in the movie industry because of pre-visualizations and like rapid prototyping. It's not just the Mandalorian, it's not just the what's it called, the space, the screen, the thing, the stage where they filmed the Mandalorian, that's all rendered
like the LED volumes and the
volume. Yes, it's not just the volume, it's previs, it's like rendering scenes very quickly to see how they would look. like simulating lighting or simulating, because a lot of things, even more and more shot in green screens, and you kind of want to put something in the background to see how it looks. So like Unreal's just dominating that industry, which was very, very funny when Unreal changed their licensing very recently, because it doesn't just affect games.
Right,
it affects
right.
everybody, and there's a lot of everybody outside of
Yeah.
games in Unreal. So all of these things are connected. Anything that like simulations, the driving simulators, or rendering for movies, or NASA doing simulations for space, which you kind of need to have like accurate, high fidelity simulations to be able to kind of like visualize what would happen. But anything that you can think about, architecture, anything, is going to use a game engine, because the game engine is optimized for this. Everybody's using a game engine, and the game engine is a 3D rendering engine. It's used for games because that's how it started.
Yeah,
That's true. And I'm wondering if that's going to change the game engines themselves. Is it going to affect
It's
the
already
tech
affected.
itself?
Yeah, it's already affected. You can see how Unity expanded Inland 5 in like the last 5 or 6 years to all kinds of different industries, because the revenue that they get from casinos or from automotive or manufacturing, it has a real impact for them. They're not just a game engine. And these are the things that you can tell by looking at their licensing terms for the different industries.
Oh, yeah.
If there are highlighting industries that are not game specific, like direct game related industries in their licensing terms, it's because that industry has a lot of impact on their revenue, enough that they will make special licensing terms for that industry. And that's like since 2018, 2017, that's been a big thing.
Yeah, and it creates a chasm between games industry and maybe the engine providers or the other industries, because it influences it so much, as Andreia said, because there's all the money that some of the game developers think that it's taken away the focus of where the engine used to be going, right? And that's definitely something that has happened to Unity, right, with their recent announcement to kind of like refocus on the games business again with the engine, right? It remains to be seen whether they kind of like fork into other industries and make a separate product out of that, but it has certainly taken away from gaming in the last couple of years.
Yeah. I'm pretty much sure it will affect all the tech around this, and it's not just the engines. Like we from the tooling side, sometimes when we do talk with the users of the engines, and we kind of surprisingly realize that's not gaming. So we talk to them as they're doing the games because they're using the game engine, but then their answer is like, "Oh, but we are not doing a game," and we're like, "Ah, okay." So yeah, and I think we should stop thinking about all the game dev tech users as game creators only. So it's much more, and you can literally see that from the plots. And I'm wondering, actually would be super interesting to see how these numbers will evolve and change, say next year and a couple of years, and if the share of the non-games projects here grows, or if some specific segment grows, I don't know, filming or any others. And maybe indeed the comment regarding that there might be even more, but they're just not in the survey because probably they were not reached with this message, and it didn't come to them, so they just didn't fill it, and we don't have them here, but they are using the tech already. So yeah, that's pretty much interesting.
Yeah, and I think it influences the the roles in the space too. Like I see people in these other industries represented as like those are other areas where game developers or people familiar with game engines are moving. Moving into like techno director and technical producer roles for these M&E companies. That's really neat too.
Yeah, that's a good point. With the game industry currently imploding, the market, like the hiring market being what it is right now because of all the needless layoffs, those people are going to move somewhere. And there's way more industries that are using this tech than just games. Those people will be more accessible to this type of surveys because they've come from that industry. And so I wonder how that impacts of like the reach of game versus non-game type is going to happen when people start having to diversify, because they still want to work in this tech, but they just can't work in the game industry.
Yeah, and I think Tristan has a comment, right?
Yes, so I'm surprised to not see in those data the presence of AI training, because from my experience, something I see often is people using game engines to create a virtual environment to train agents. And I mean, I guess we can have this example with the BMW driving simulator, but I've seen people training more stuff different from from cars. So I've seen example with trains. I've seen example from just making humanoid agent working in virtual space and be able to avoid obstacles. So yeah, instead of using pre-existing data you collect and you use it to train your agent, no, you just simulate an environment and you create your data on the fly. That's, I think, an application I see often. So I'm surprised it's not there.
Yeah, I think I did recall there were a few of those in represented in like the other slides here. But you're right, it's something that's growing a lot. I think if I recall this correctly, like, you know, people are even speculating that OpenAI's video creator Sona was like maybe being using Unreal Engine to develop some of its things or being trained through that. But yeah, that's a good point.
I'm sure we'll have a bright new future quite soon. Okay, so talking about the bright future, but let's look at the challenges, how they look to the those using the game tech now, and especially game developers. And it's interesting that while like preparing the report together with Perforce from JetBrains side, we were super interested to slice the data into two groups, because we previously already saw that when the AAA studios and like midsize or indie studios, they have completely different data. So they talk about different things and different challenges. So we slide a few questions in the Perforce report by this specific metric. And indeed, there are differences. So, and if you look, for example, at the challenges impacting teams, they are for sure absolutely different for like smaller studios and like bigger companies. So I can't say that I'm quite surprised here, but yeah, that's kind of expected result that they will be different. But I'm wondering, so what do you think here about these differences and these specific challenges? Do you agree, or maybe any other comment?
Yeah, money's hard.
Yeah. No surprise. Yeah, we were at Gamescom in August, and we saw all these huge regional booths which are supporting the local smallish game studios like GameDev in Germany. I guess that's the biggest one, and there are also others. And so, yeah, all these studios, all these starting in game development, they were going rounds and looking for funding. So no surprise that it's like 33%, I guess. I agree with you here, Andreia.
Yeah, I mean, collaboration is also a thing that impacts indies and small size studios deeply. It's just, I think they're more worried about money than collaboration, and they'll just get by with whatever they need to get by, which sometimes is like worse than AAA. AAA has access to Perforce licenses for like large teams and tooling if they need to, custom pipelines. They will have a tooling team that can supply that for their tools. So in one way, they're better off in all aspects than small and mid-sized studios, because mid-sized studios and indie studios will not have it. They will have one person trying to set things up, and then everybody else trying to get with whatever is available. Which might or might not work for them, but they will struggle with whatever is there. And yet, AAA studios say that collaboration is a big challenge for them. I think that's because all of the other considerations are fixed. Like they're not worrying as much about money and everything else. And large teams, extremely large teams, much larger than other studios, trying to juggle everything around. I think maybe it's less about tooling and more about just having a bunch of people from markedly different backgrounds and technical levels trying to come together and put everything together.
Yeah, but it's also actually about tooling, because that's the request we hear quite often from big studios, is all related to collaborative tooling. So we hear often about those collaborative features, for example, in the IDE, or like something setting synchronization, so like how they can collaborate as a developer team and use the same setup, or some warming up or remote functionalities, because I do guess these big teams are now all remote, which like the COVID made it even worse. So quite many people are just spread around the globe, so and it's hard to collaborate, even just the time zones, right? So just think on that.
And when I say like collab, go ahead.
I just wanted to say, like, team collaboration, I think, is a natural issue for huge projects, right?
Yeah.
And if we look at AAA, we often have like teams more than 100 people, or far more than 100 people, and it's really, really difficult, even if they're in the same office, to put those teams together, right? And of course, tooling can help mitigate some of those challenges, particularly when people are apart. And Anastasia, that is definitely an issue that I've seen with many studios, even have multiple, like one developer having multiple studios across multiple time zones, right? And needing to move data via Perez, for example, across the big pond, right? That's certainly something that can help there and get together. But I think it's still that the nature of the thing that it is so big, right? And there are so many people needing to collaborate. And then if you look at indies, right, or smaller studios, they don't really have that problem of too many people, right? It's much easier to coordinate 5 to 10 people than it is to coordinate a couple of hundred people, right? And you don't need to have those hierarchies that you need to put in place. You don't need to have lots of processes that you need to go through trial and error to get everything together, right? So
yeah,
I think that's that part.
Yeah, thank you. Chris?
Yeah, for sure. And yeah, I was thinking, like, I wonder, like, just how much of the data also represents just, what we've seen in the industry lately, right? So you have AAA studios, like a lot of them doing acquisitions. From those acquisitions, just trying to do integration strategies. So like, you're trying to collaborate amongst those teams and merge and consolidate them with their other groups. And then from that as well, like I've seen, lots of people that were successful in that, getting acquired or moving into the bigger studios, like starting to, want to replicate that success. So then now they're going to start another indie studio and try to build that up again. And, it's like that cycle begins again of like, looking for funding for those projects and then, trying to replicate that success.
Yeah, I agree. Any other comments here on the challenges?
I do find that indies do not use CI. If you're thinking people use CI for game development, no. Doing cloud builds for games, for whatever, how many platforms you need is possible. Having the hardware locally, a bunch of computers, and some Jenkins instances that are unpatched to try and get that thing is already a mid-sized studio challenge, not an indie at all. So I feel like when AAA studios talk about collaboration and their challenges in collaboration, they're talking about a slightly different level of collaboration than indies.
Yeah.
Indies, for them, collaboration means people sitting down and designing a game, or because they're a small team and they can just be in sync in the mind and design a game. While AAA are collaborating in how does the product, like the producer, see the state of the game today and communicate needs to the team design lead that goes into the art director, et cetera, and that type of collaboration, which is why I suspect they ask for tools for collaboration, but not because they need to transfer large files, although they do, but because they want to be signaled on, like, the cinematics director needs an approval on this latest cutscene from the producer. How do I signal that across the team? It's like a kind of like a more communication collaboration tooling needs that AAA studios, I think, when they speak about the challenges of collaboration, that's kind of, I think, where they're going more, as opposed to basically, I need to run this thing on CI. I don't know how to build this thing for iOS.
Yeah,
So
I agree with you here. Yeah. Okay, let's move on to next topic. And yeah, we could talk, I guess, hours about that, but let's follow our schedule. So game engines. And again, so we did the similar thing as with the challenges here. So we kind of sliced the answers into two groups. And this is no surprise, I guess. The only surprise which this year I was literally very happy surprise, I would say, is the growth of Godot, specifically for the smaller companies, as I saw it here. And the rest is maybe not that surprising to me, but I'm not sure. What about you? So does it look surprising to you?
Actually, I'm surprised that Unreal Engine is so high for indie games. I thought it was mostly Unity, but apparently that's ahead. Because Unreal Engine is known to be much more complex than Unity and Godot. So usually indie developer won't pick it up because they don't need that complexity, or they don't need to create some huge open world game. So that surprised me.
Okay, thank you.
Yeah, I think I would like to compare these values with 2 years ago, maybe, if there's an equivalent.
Yeah.
Like next year you can do a comparison of, because I think it might be a blip due to the whole Unity drama of the last year and the amount of people that ran away from Unity.
Yeah, that's a good point.
It might normalize now that sanity is restored, or it might not. Unreal also has a problem for indies, which it is surprising, but it might be that they are not shipping games yet, and then they will hit this when they're trying to ship a game with Unreal. Unreal, like you can't run this on the web, and in certain platforms they just don't have an easy path to export your game to those and publish those games to those platforms, which AAA studios don't care about, because they don't publish to the web, and they will have teams that can port the engine if needed to whatever platform they want to publish to. But indies don't have that, and so Unreal is like not a full comprehensive engine for targeting every single platform out there like Unity is. And so that's a problem that comes up. People don't realize this until they go like, oh, but I want to publish to platform X. Seems like, oops. So yeah.
True.
Well, I could agree on your comment on it might be a blip for Godot here. I believe it is not, right?
Oh, no, not for Godot, for Unity. Sorry, Godot, not a blip.
Okay, yeah, because in Godot, what I see is a lot of professionalization and the creation or emergence of a commercial ecosystem finally, right?
Yeah.
And I think we see an even increased growth, and that would also kind of like open up the funnel for bigger studios as well, as the Godot project starts to implement more and more double and triple A needed features, coming into that with W4's console ports now being available, right? I think and your own JetBrains investment into that tooling space, I think we will see quite a bigger growth even, right? Unity, I really hope for them, because I still think it is a fantastic engine, particularly for indies and smaller studios, with whatever it's offering. The new licensing will kind of like give it some life back here, right? Because I think that it is good to have a bigger ecosystem and actually choice in the industry, and that's something that I'm missing kind of like in the AAA space, right? Everyone, including now Halo Studios, like sitting around the Unreal Engine fire, while it is good in one way that we have much more development there, right? And I really hope everyone is feeding back to that central core, right? But in a way, I doubt it, right? And I believe everyone kind of like will maintain their own fork of Unreal Engine and continuously like merges the upstream changes, but not contributing too much back. And so we will see, I personally feel a deterioration of technology and kind of like overall ecosystem, for lack of a better word.
Yeah, I agree here. And actually, with also with the Godot, I want to add that I was like interested when Second Dinner announced that they are now participating in Godot Foundation, I guess, and they will be doing some like games on the Godot. I think that's huge for Godot. I mean, I've haven't seen this kind of a company, this level of a company. I mean, in terms of the like quite a big studio supporting the Godot and trying to do some production games on that. So that would be an interesting story and definitely a new boost, I guess, for Godot with that. And I also wanted to address, like Khalid in the comments, he was wondering like what is the big shares of, like our own, for example. But I'm not surprised with that personally, because I think in-house engines for AAA is a must. I mean, you can use Unreal Engine, but at some point of time, many of this AAA just realizes that they need their own engine, and all these in-house, mostly C++ engines are there. And we know nothing about them, which is sometimes very sad fact to me as a like person working for like a tooling vendor, because we can't properly support them. But they are there, and the share is great, because if you do a like complex game, you quite likely tune in the engine, and you just start with maybe your own. And I think that's a common thing, and that's why the share is quite big. I even surprised that it's not that big.
Yeah, I think it was a lot bigger a couple of years before, right? If you look at particularly Sweden is kind of like the engine hub. Everyone and their brother had their own engine for their game, right? And most of them have now defaulted to Unreal Engine. And so we basically only see Ubisoft and EA still carrying their own engines.
And Guerrilla Games.
Yeah, there's a couple. I was just like kind of making a point. There is a very few that are still carrying their own big engine, and they are really, really specialized, right? And I think that speaks to Rebellion here, but also like, for example, specialized things like for racing games, right? Unreal Engine might just not be the best thing here, or for very large MMOs like World of Warcraft, right? A custom engine is still very much needed or warranted here.
Yeah, like commercial engines favor the bootstrap. They have flows for creating a game. You know, new game template, start here, put things there, and then which ends up they have to work hard at being both good at the beginning and good at the end, right? So Unity is very good at the beginning. Like you start off, like you have everything up front. You can just prototype super quickly and test it out and go. And a lot of studios actually start with an Unity, and then once they have a prototype in place and know what they want, they switch engines, because their custom engine doesn't have a new game start here. They will take the previous shipped game, strip out all the things to have like the basic files in place and start there. There's no like easy way of starting a new game, because that's not what the engine is for. The engine exists to publish the game, to run it at the target. So prototyping those things is hard. There's no easy start. Like let's start a new thing. The tooling is made for the game and not the other way around. And so like our own 11%, not surprised. It's probably much higher because depends on the audience that's
it's
these
sure
questions,
high
honestly.
for AAA and last for small studios which don't have this, capacity for owning their own engine, developing it.
But
and it's a good use case to call out, because like this is
multiple.
Yeah, and this is like a choice where like, people could fill out multiple choices, right? So lots of people using Unreal and Unity, people using, Unity with some of their own engines too, just depending on like what cycle they're in. So that's definitely good to point out.
Yeah, absolutely.
I would like to see the Decima engine released. is what I'd like to see.
Let's talk to Gorilla. maybe they will. Okay, let's move to the last topic, and that's really like a safe space to talk about anything related to tooling. I couldn't go without this slide. You could probably understand. I'm like a tooling person, but there are a few interesting things here. So whatever you would like to highlight. So these are not all the toolings in game dev for sure. They're just like the top in each group collected on this plot. So any insights or commands anyone sees here?
Yeah, I don't think AI for generating code is there yet. I tried different ones, and it's extremely hard to have something that actually works. I see like almost 50% for ChatGPT. From experience, unless you want to create some Python script, if you ask something that's not an algorithm that everyone else already used, is going to give you garbage, and you're going to spend more time fixing whatever generated instead of doing it yourself.
Yeah, I think the current state of the AI is, to me at least, I see the bigger value in like explaining things or helping with some things than just the pure code generation. Like, let's take this take from Andreia about like starting some new game and like doing this kind of onboarding or something. If you have a huge in-house engine, if you like, reach enough to get your own on-prem AI train on that engine, so then you maybe could solve all these issues on starting on this engine easily, because the whole knowledge and there is lots of help of then based on this knowledge from AI to you. So, and it could explain things, it could summarize things, which I personally find them like very, very valuable thing. So it's not just the code generation, which is probably not of the best quality. I would agree here with you at the current stage. But like all these summarizing things from AI are really, really helpful to me. I don't know about you guys, but I really love that.
But yeah, as a knowledge base, it's really good. You can analyze your whole code base, ask a question, or even if you, I don't know, search for some method or algorithm you don't know what to use, well, then AI can be some extremely specialized search engine.
Yeah, agree. Great.
Yeah, AI is garbage for most things, to be honest, and it's a waste of time trying to shove them into everything. I agree. Summarizing information, even like on Slack, there's people doing this because everybody asks the same question. Might as well get AI to respond to the same answer.
Yeah.
But like Midjourney et al., completely useless. To never use this in your games, please, because none of this is copyrightable. And best case scenario, you'll just get taken out of store for using violating copyrights of other people because the AI generated a thing for you. I mean, worst case scenario, just lose copyright on your game, which is even worse. AI has been used forever in games and everything, not as AI, but as ML, to train data, movement data, NPCs, generating terrains, generating noise, like all sorts of like procedural generation is a thing in games forever, never, never. And their AI ML can actually like boost that because it can do not just random noise, but actually like learned noise. It can generate data that's meaningful to the context of the thing that needs the data, not just data. So those very, very, very specialized pipelines are a thing that is useful for this whole AI thing, where you can just plug those into the game, because like you can do useful things with it in a very specialized way for generating assets, for generating stuff. Otherwise,
yeah, I have to say that I've seen several very impressive usages of the AI for like creative roles. I guess it was a couple of years at GDC when there was a setup and like someone was just talking to AI, explaining, like exactly as Khalid wrote in the comments, like Italian plumber with fuzzy mustache. So, and like the person was just talking to AI and like saying, I want a street and then some houses here and then some park and then like, and it was just the prototyping scenes with the help of the AI. And it was so nice and quick and essential. And I was like really impressed. Like I felt that I'm like maybe my code and my boring stuff is too boring for this way of creating cool stuff. But anyway, so we have just a couple of minutes left. So maybe someone else would like to comment on this tool set, maybe something not related to AI in your mind?
Yeah, I always find it very interesting when I speak to game developers, and I'm a lot very back-end focused, so to say, and I hear a lot from these developers. Oh, I'm so forced. I'm sorry, Chris. Here, I'm forced to use Perez. I'd rather use GitHub, and it's so funny because for a lot of like just software developers, Git is so much more straightforward, so much more directly useful in terms of interacting just with code, right? And it's interesting to see that total change in the games industry, where all of the rest of the software development industry is basically defaulted to Git, and then the games industry is very much focused on Perez, and we all know why, right? In terms of like big assets and really all the art part of the production pipeline is very much this is where Perez really shines. But it's interesting actually to see these high numbers in Git, and I assume, speaking to a lot of AAA developers who are not using Git, this is also kind of like a little bit of an audience fact here, how you, or of the people you have reached here, I think, because I think this is also a very different share in AAA and then other developers or indies, I would say, because I think indies go more towards Git, whereas everyone who is like more professional will default to Perez for that particular reason.
Yeah. Okay, thank you, Johannes. So actually, you're nice. I love talking to you people, but I think there will be Matt soon coming and kicking us out of the stage. So I would like just to share for the second time the QR code where you could get the report if you're interested and get more like insights, and please continue discussing that and like in social media somewhere where like you could comment on that. And thank you everyone for joining us for this roundtable. I hope you enjoyed that, and I hope the audience also enjoyed that. And hello, Matt, we're already going away.
Yeah, it's about to come and kick you off,
Thanks,
but it's all fine. Fascinating conversation, though. So lots of really good topics covered there. It's interesting to see the difference with the game engines. The results from the survey there, they're different to what we've got in the chat. And we've got more people using Unity, for example, than Unreal. And Godot is got a much better representation in our chat today.
Yeah, we're very agnostic today to all.
Oh, yeah.
Okay, so thank you, everyone. Thank you.
Thanks for having us.
Switch to the next talk. Thanks.
Yeah, thanks, folks.
Thanks, everyone. Thanks, guys.
Thanks.
So yeah, great talk there. Great session.
Thank you, Matt.
Insights and things. I think we should get straight on with our next session. Really,
sure.
We've got
Tristan back.
Yeah, I'm back.
Tristan's back, and we've got Pierre-Thomas and Cedric as well. Going to join us, and they're going to be talking today about game development in Godot and Kotlin, which is going to be an interesting one.
I already love that. Let's go.
Hi, everyone. Thank you for attending to this talk. Today we'll speak about Godot Kotlin, which is JVM bindings to the Godot engine that enables to write some your game logics, your game scripts using Kotlin or Java. So let's start with the basics. Tristan, go ahead.
Yeah. So if we can switch my screen. Yeah. So to use Kotlin with Godot, you need to use a custom build of Godot. it's similar to how you have to use a different build for using C#. So to do that, you need to visit our GitHub page, which is simply called Godot Kotlin JVM, and go to the release page to find the latest version. So here, that's the version of our latest release. And you can find the version of Godot it's built against. And you can simply download the editor that matches your system. And once this is done, you're going to find in it just the Godot editor plus a jar. So if you want to run Kotlin alongside Godot, you need the jar always next to your editor, otherwise it won't run. And because we're talking about the JVM, you also need Java installed on your computer, at least version 11, and the Java home environment variable set on your computer as well. So let's start by trying to create a Godot project using Kotlin. So for that, you start the editor and you create a new project, just like you do in a regular Godot project as well. So we start the engine here. And as you can see, we have a new project here, which is a perfectly normal Godot project. You just have project Godot and all the minimal files. But we need to create now a Kotlin project. So we're going to use Gradle. And nicely enough, we got a utility to do that. You go to Project, Tool, Kotlin JVM, and you generate a project. Generate all files. And now you got on top of your Godot project, a Gradle project. It's extremely basic. Like if you open it, it's simply going to use our own custom Gradle plugin, which is going to download all the dependencies for you, as well as a compiler plugin to create the glue code necessary to communicate with Godot. I won't go into details about what those parameters are. Just know that by default you can run on desktop, but if you want to run on Android or iOS, you need some extra configuration, and you can find that in our documentation. So as part of the generation, we had a basic Kotlin script created. You can open that in the Godot editor, but I don't recommend this way because we don't have auto-completion, we don't have static analysis or anything. So just forget about doing that in Godot, and instead we're going to use what most people would use for a Kotlin project, which is IntelliJ. So just open the created project. We wait for the Gradle project to build. So just a second. And we can then open our script. So how to create a script using Kotlin? It's extremely basic. So you create a regular Kotlin class and you just inherit a Godot type. So if you want to know the Godot type to use, you can just go to the official documentation of Godot, because we are trying to get to be one-to-one with the official documentation. So any type or any method and properties are going to be the same. Only difference is the spelling will be camel case instead of snake case. And we have a few differences, and if you want to find them, you can just visit our own documentation to see the Kotlin-specific syntax. So you also have the whole documentation available directly in Kotlin as well. So if you have doubts, you don't need to visit it. You can just check here. So now, once you created your script, your class, you have to add a few notations. Register class for the class, register properties for the property, and register function for the function. Here, it's a simple hello world script. So when the object is going to enter your scene, it's simply going to print hello Godot to the screen. So let's try to do that. So we create a node, and to add the script, you just drag and drop it on it. And if you try to start the scene, you see that nothing happens. Why? Because you didn't build the Kotlin project. So for that, you just simply press build here, or you can use a regular Gradle action. It's going to build. And as you can see, there was a warning here before. It disappeared. So if you forgot to build your project, you are going to get a warning to tell you, okay, you forgot. If you try to run the sim now, okay, we have a hello world put in the console. Nice. And here in this script, we are missing one key function of Godot, which are signals. Signals are the way you can remove coupling in your code. So basically, it's a publish subscribe system. So let's try to use a signal here. So for that, we just create val max signal by signal one string. So here we are going to use a signal that emits a string, and you have to name it as well. So there is a key difference here compared to regular Godot when you use JavaScript. In JavaScript, signals are untyped, and they use a vararg. It means that when you emit a signal, they can emit any number, any kind of argument. In Kotlin, we like to be type safe, so you have to type your signals using generics. And if you want to use that, you need to connect this signal to a callable, a function. So we can try to do this. Fun, print a text. We are going to take a string as parameter, and we are simply going to move the text here, this code here, and instead we're going to connect the signal. So you just simply do my signal, connect this, and you can simply pass a method reference to your function, and it's going to work. Here it's type safe, so max signal emit a string. You can hit it to a function that also take a string, and if you remove the parameter, you get an error because it's no longer matching the types. Also, again, don't forget the annotations, register function, and for the signal, you simply use register signals. There we go. So if you go back to Godot, wait a second, we just need to emit this string, and then you need to also emit the signal itself. So emit, and let's say I want to simply emit the property here. So we go back to Godot. As you can see, we have the warning back because we changed the source code, and it means we need to rebuild again. Okay, and it's gone. So if we try, for example, to change the string, hello GameDev Day, and we simply save and start the scene, we have our hello world using the signals with Godot. So yeah, that's it for the basics. And now I'm going to let Pierre-Thomas talk for more interesting things.
So in this part, I'll show you how you can use some awesome Kotlin features to create your game using Godot engine. And for this purpose, I'll use the JDQuest 3D demo that was originally implemented in JavaScript, and we just readapted it to Kotlin to show the language features. So as you can see in this game, we have some water, and if the player goes into this water, its position should be reset. So let's take a look at how it's done in code. So here we have a really simple class, which is called DisplayN, that represents the water. It extends the Area 3D class from the Godot engine. And this class has an already implemented signal, which is called body entered. This signal takes a node 3D as a parameter, and it's basically the node that enters the area. So Tristan already shows you how you can create some signal, connect the signal to a method, and emit a signal. But here I'd like to show you one feature we implemented in Godot Kotlin. As Kotlin is object-oriented but also functional programming language, you can directly connect a signal to a lambda. So this means that each time the body entered signal is emitted, this code block will be run. So in here, we just check if the parameter that we have is a player, and if it's the case, we just reset its position. So if I go in the water in the game, my position is reset. Then you see we have some boxes in the game, and I'd like to show you the code of the game script of those boxes to show you some Kotlin features. So let's take a look. So here is the box class that inherits rigid body 3D, which is a physics class from Godot engine, but also implements a damageable interface. This interface just defines a damage method, and interfaces can be a good alternative in some cases to Godot node groups. Let's take as an example the bullet script. So the player can fire a bullet in the game, and when it collides with the node, here we just check if the node is damageable. Then, thanks to Kotlin Smartcast, we can directly call the damage method on the damageable. We also have some helpers methods to directly cast some nodes to the desired type. So let's take a look in the Godot editor to the box scene. So in here you can see we have a node called destroyed sound that is of type audio stream player 3D. In the code of the box, we just fetch this node from the scene tree, and thanks to this method, it will be directly casted to audio stream player 3D. We have some kinds of method on the packed scene. You can directly instantiate a packed scene to the desired type. Here we have destroyed box, which is a type we implemented in Kotlin. Then we saw that the bullet script is calling a damage method from the interface, and I'd like to show you the implementation of the damageable interface in this box script, because in here we use one of the coolest feature Kotlin has, which is coroutines. Coroutines is a way to make some code to run concurrently with the rest of your code. It's a way to switch between threads without taking care of those threads. So in this coroutine, what we do, we just await load a packed scene. So this means that it will load in background. The coroutine will pause until the packed scene is loaded. When it's loaded and instantiated, we just await main thread. So here it's another method we implemented. The coroutine will just pause for this code block to be executed on the main thread. So here we just add it as child. Then we just do pretty much the same with the coins that should pop when the box is destroyed. We just load the resource, and then we just instantiate it and add it to the scene. The last part is disabling the collision shape and playing the destroy sound. The destroy sound, so from audio stream player 3D, has a signal which is finished, and we implemented a way to wait for signals in a coroutine. So here the coroutine will pause until the finished signal of the destroy sound is emitted. And after it's emitted, we just free the original box. So if I go in the game and fire at some boxes, you can see that the box is destroyed and we have some coins popping. One other feature, the last feature I'd like to talk to you about is abstract classes. So here we just defined an enemy abstract classes that also inherits rigid bodies really in the damageable. This abstract class just define a death method in here that does pretty much the same as what we saw in the box game script, except we don't load a destroyed box but a smoke. And there's also another change you might notice, that we are not using a constant to make the coin spawn. So in here, we just use an abstract property that is implemented in both of the inheritors. So if you look to the B-bot, which is the flying enemy in the game, here we have the default value of 7. And for the beetle here, we have a default value of 5. You can still override those properties in the Godot editor, like any regular exported property to the Godot engine. So if I go in the game and find some enemies to fire at, and hoping I'm not too bad to this game, I'm bad. So here I got 5 counts that spawns, and here I got 7. And that's it for the feature I wanted to show you. But I still have one more thing. During this project, we managed to make some JVM code to run on the iOS platform. And I'd like to make a big thanks to the multi-OS engine maintainers that helped us by speaking with us about how to get this running on iOS using GraalVM native image. And so you can see here on my iPhone the game running using Kotlin game scripts. So now I'll pass the mic to Cedric. The floor is yours.
Thank you very much. We now just saw how to set up a basic Godot Kotlin JVM project, and we saw how to use some of the awesome Kotlin features and helpers that we ship with the project. But what about third-party libraries? I mean, one of the key advantages of the JVM ecosystem is its vast amount of battle-tested libraries and frameworks. So we might want to use them. And to quote Tristan here, Godot doesn't have a dependency manager, but the JVM does. So we want to make use of that. So to showcase that and how you can use regular JVM dependencies in your Godot games, I threw together a quick demo for you. If we run that game, it doesn't do much currently, because what I want to do now is basically display just the time. So I know I won't talk too long in this talk, and we finish on time. So how do we do that? Because I'm lazy and I don't want to implement the timer myself, I want to use a library for that. Luckily, JetBrains has got my back, and they provided a nice little library called Kotlin X datetime. And I'm going to just use that. We add that as a regular Gradle dependency, like we would do for any other JVM-based project. And with that dependency added to our project, we should now be able to use that. Because I want to display the time in that label, I maybe want to format it, because like for most datetime libraries, I get back an instant and not a nicely formatted string. So let's quickly write a formatter for that. And down here, you see the label that we previously saw, which we want to fill now with the current time. We do that in the process function, and the process function in Godot runs once every frame. So let's quickly populate that. We get the current system time from the library. We convert that to my current time zone, where I'm living, because, well, the timer is for me. And we format the instant that we get back. And just with that, after we recompile and run the game again, we should see the current time. Lovely. While this is quite simple, this allows us many things to do, because I basically just imported the datetime library, but this could be anything like JSON or checksum for JSON serialization or XML serialization, or basically almost any other JVM library that is out there. Well, this is nice. We want to develop games, and we want to develop a lot of games sometimes, and we sometimes write code that we want to use over and over in each of our individual projects. So what about our own libraries? To showcase how our project can help with you, if you are a library developer, I quickly threw together a chat SDK. This chat SDK is a JVM library, or JVM dependency, which consists of a backend, which runs on a server, and a client implemented solely on the JVM as a terminal client. If we quickly see how this looks like, we can quickly run our JVM client, and this just prints the chat messages that are running on our server. And we see our users happily chatting along. Let's keep that running for now. So let's see, I want to integrate that chat SDK that I wrote for different JVMs. For example, for the server, I maybe have an Android client somewhere, or just as a command line client. I want to use that in my Godot games. So I can quickly just create a Godot SDK and write Godot specific code, where I can register classes to Godot, export some properties, and set up the whole SDK in my project. So this is nice, but how can I use that in my project? Well, it's basically the same like any other dependency. I just add that to my project dependency list down there, and I resync the project, and I built the project. And that was basically it. After my project is built, Godot should now be aware of these classes that I just put there as a library. And after it has finished compiling for me, we can just show the Godot editor. In there, we see the sample scene that I showed previously with the time label that we saw there. I prepared a little chat window alongside it, so we can see the chat messages in there. This is implemented as another scene, and on top of that, we now want to add the script of our library. You saw previously that you can just drag and drop your source code onto a node. But we only see the demo code that we have had earlier in our project in there. So what we're going to do now, because our libraries are distributed as a jar file, and there we don't have access anymore to the source code we had. So we can't just drag and drop the source code file onto the node and expect it to work. Well, for that, we create so-called registration files for you. For each class that you write, like the demo, for example, back there, we create a secondary file called demo.gdj. GDJ stands for Go.jvm. In this registration file, this is just a metadata file, so Godot knows that this class exists. Instead of dragging and dropping source code files directly onto nodes, we can also drag and drop these registration files. These have some nifty features which are documented in our documentation page. And as you see now, we have a secondary folder in there called dependencies. And in here, we now see our chat SDK together with the two classes that our SDK provides for us. So let's drag and drop that one onto our node. And on the right side, we now see the properties which are provided by the library for us. So let's quickly fill that up. We want to have a packed scene which gets instantiated for each chat message that we want to receive. We want to assign the chat list node to which chat messages are drawn to. We will provide the scroll container, the message input label so we can send chat messages, and the send button. After we set that up, we need to also set up the individual chat list items. Here, it's basically the same deal. We drag and drop the registration file onto it and just populate the individual exported properties from the library. And with that all set up, we can basically just run the game again, and we should have chat messages pop up again. And we just see the chat messages that we have. Just like that, we have implemented a little chat client. And as you can see, they are in sync. And we can also just send a test message, which arrives also on the JVM client down there. So just like that, I implemented a small library that I wrote myself, which runs on the JVM, which I already had, because I had a chat application already maybe, which was running on a server. This chat SDK can share JVM code. We have a shared module, which can be shared between the backend, between the regular JVM client, and now also between our Godot projects. And just like that, I quickly implemented the chat functionality within my game without writing too much code for that. So what have we just saw now in my part? We have seen how to easily add third-party dependencies from the JVM ecosystem. And we saw how you can create your own libraries with your own functionalities which you can ship together with your individual game projects. You don't have to re-implement it, everything each time. We also saw that we not only allow to drag and drop scripts onto nodes, but also so-called registration files. I really encourage you to read the documentation on our project site regarding them, because these are really nice features that we offer in our project and can really help you write nice Kotlin code. And yeah, that's basically it from my side. I want to thank you very much for your attention, and have fun writing games with Godot.
Yeah, thank you very much. That was so impressive.
Yeah, great demo. Thank you.
Yeah.
I'm going to dive straight in with a... Sorry, Anastasia.
Yeah, go on. I was just commenting
Yeah.
that the demo was so fluent that I was just like, yeah.
It was nice, it was slick, it was good. I got a question from chat straight in there actually, and it's I guess it's how would you pitch this? It's like, what are some advantages of using Kotlin over GDScript or other languages in Godot?
Well, I can go quickly answer that if you want to. From my point of view, if you already are an Android developer, for example, you already know, or a JVM developer for that matter, you already know the JVM quite well, and you already know a language that you use to work with every day. So if you do that as a hobby, for example, you can just use the language that you are used to and that you want to use. Another great advantage is also, as I just mentioned in my part of the talk, there's a vast amount of already readily available libraries and projects which can help you get to a goal really quickly. And one thing I want to really emphasize here, the JVM really got a bad reputation for performances and memory consumptions, which just were from Java 5 and 6 days. And in today's world, the JVM is really a different kind of beast. It really is very impressive regarding performance and memory consumption overall. So it's quite, performance-wise also interesting to use it in a game engine.
Yeah, we agree with the comments about the JVM. We use it extensively.
We know what you're talking about.
Yeah, we find that it's great. Speaking of Android, I mean, that's a great sort of question then to follow on is what's the deployment story for Kotlin-based Godot games? So what targets are available? So Android sounds like one, but what else can you target?
I can answer this one. So currently we can target all the desktop platforms, so Windows, Mac OS, Linux. We can also target Android, but as I show, you can also target iOS thanks to GraalVM native image, which enables to do some ahead of time compilation. So with this, you don't have the JVM just in time, but you have the ahead of time that enables to do so. And as we are an open source project, we don't have the rights to test the console platform. But if we are able to run on iOS, I think it will be possible to make a JVM port to the console platforms too. But that should be tried.
Yeah, thank you. And I wanted to ask, so Cedric was mentioning like the Kotlin library, saying how it helped him for this little app. So what are the must-have Kotlin libraries that work well with Godot? You could recommend maybe those who will be following your steps here.
One is, of course, Kotlin coroutines. This is one of the best things, in my opinion, that Kotlin has to offer. It's so crazy what you can do with coroutines. But yeah, that's something we already provide with our project. It's like toggling a switch and you can just use it. It's easy to use. But other third-party libraries, JetBrains really has a great collection of libraries. I'm not sponsored by JetBrains, but just like your product, sorry. For example, I really like Kotlin X serialization because this is a serialization library which works without reflection. Personally, while reflection is crazy and allows you many things to do, it's also quite dangerous. And or I don't like reflection that much. And having a serialization library which just works without reflection is really nice. It works with a Kotlin compiler plugin. You can just use that. And it allows you to write game code, for example, in a debug scenario where you talk a client with a server. And with Kotlin X, you can just have that talk with JSON. But once you're going to production or you want some more performance, you can basically enable a switch and have all that serialization happening with protobuf, for example, and not use huge JSON objects. And the code remains almost the same. So that's also a really nice library to use.
Yeah, thank you.
Cool. Yeah, speaking of coroutines, I was going to ask about how well that integrates. Well, if people don't already know, by the way, coroutines is how Kotlin does sort of asynchronous programming, and it can work with threading and do tasks and all sorts of fun things. So I was wondering, how does it integrate with whatever threading model that Godot has? You know, is you using JVM threads, or how does it work out there?
So currently, yeah, we are just using the available pool of threads provided by Kotlin. You can run on the Godot main thread. Godot also has its own pool of threads, but yeah, we don't provide yet a way to run the coroutine on them, but that's a feature we want to implement soon.
Mm-hmm.
Cool, thank you.
Cool. Okay, I do have another question before we wrap up there. Compared to C#, Kotlin's looking much more explicit there with sort of the annotations and everything, you know, especially with properties and class registration and so on. The C# is more convention based. So why did you kind of go for an annotation, you know, something which is more explicit?
Well, we went with annotation because we think the mindset of Kotlin is to avoid as much as possible implicit stuff. Mm-hmm. And so we could have gone the road of just saying, okay, if you have a public property, it's going to automatically register to Godot, but registering a function or property to Godot always has some hidden cost, being in processing power or in memory. So we just want to have a way to make users say, okay, I want to expose that to Godot, and I want to be explicit about that. No hidden cost, no automatic features.
And one thing I really like to emphasize here is that this is a choice we made, not a technical limitation. And one thing that really drives me personally, at least, into that direction is because I want to be explicit in my code. So with that, I can precisely control what parts of my code are visible to the engine and what parts are internal. Even if I develop a library, for example, where stuff is public, with that one, I can precisely tell from the library which part of my API is visible to Godot and which part is only visible to Kotlin code, which just implements that library. So there's a clear distinction there, and the public keyword sadly isn't enough for that, because solely with that, we don't know if the user wants to have that visible in the engine world. Like, for example, you can also crosstalk to GDScript, the regular language of Godot. And if we just would make everything public, GDScript would also see those properties and functions which I, as a developer, might not want to have public. So with that, we can have a really fine-grained control at the cost of a little bit of more boilerplate code.
Mm-hmm. That's good. It's interesting to hear the reasoning behind those kinds of things. Anastasia, do you have anything else you wish to ask?
No, I think we're done here. Let's let the people go for their lunch and thank our fantastic speakers. And I don't know, maybe we'll soon get some more requests for Kotlin and Ryder because of this stuff.
And just to comment as well that the Khalid has posted the link in the comments there. So if anybody wants to go and check this out, you can find the link in the chat and find out more.
Thank you very much.
Thank you very much.
Yeah, thank you very much for your presentation.
Bye-bye.
Bye.
Bye. Yeah, so Matt, I think with you, we're done here. We're now ready to, first of all, let everyone have some break, like lunchtime, and then we're passing to Khalid and Alex coming after us.
Exactly. We've got some new hosts coming up and after the break. So a great first half and plenty more sessions to come.
Yeah, enjoy the rest of the day. Thank you.
See you soon.
See you.
left England.
Yes.
Yeah.
Where you come from?
England.
In the UK or London?
Yeah, London.
London.
one of 'em winning. I'm one of 'em winning. Maximum beat. I'm one of 'em winning. I'm one of 'em winning. I'm one of 'em winning. I'm shooting my shot and I'm already grinning. You know that I'm one of 'em. One that you're sending. You know you've been cutting. You know I'm ascending. I'm one of 'em winning. I'm one of 'em winning. Go take a look at the pen that I'm making my money like it's never ending. I took all my losses. I roll with the bosses. I know where they cost and I'm so independent. Go take a look at the pen that I'm making my money like it's never ending. I took all my losses. I roll with the bosses. I know where they cost and I'm so independent. You can skate up, down the screen now. 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 You can skate up, you can skate up, you can skate up, you can skate up, you can skate up.
Hey folks, welcome back to JetBrains GameDev Days 2024. Let's first start by thanking all the previous guests. Amazing talks. Remember, they're all recorded. You can like, subscribe, and kind of watch all those talks later. So if you missed anything, you can do that. So Alex, how are you doing today?
What up? I am doing great. Actually, I've been unpacking recently some goodies that I got from Unreal Fest recently, and think out, are you even gaming at this point if you don't have these pliers to eat those so you don't get your greasy hands ready? And what about you, Khalid? What's cooking?
Nothing much. I'm really excited about this next talk. Our next speaker helps out indie game devs port their games. So I'm a big indie game fan. So big ups to them because I think that's awesome. But yeah, I'm really excited about it. I think this is a good time to introduce them to the live stream. So Andreia, welcome. I'm super excited about this talk. C#, you have a history with Mono and C# and indie game dev, so super exciting stuff. So
Thank you. I'm excited. Nervous? Excited? We'll see how it goes.
Don't be nervous. So there's a lot of people in chat. Alex and I are going to take care of watching chat. So folks, if you have any questions, please ask them there. We'll kind of gather up all
I'm
those.
not going to be looking at chat, guys, until this is done.
yeah. Don't look at chat. We're here to help you. So don't.
No worries, we got your back.
Fine.
If you need anything from us, we'll be here in the background. But as of right now, we're going to give you the stage, and we're going to disappear into the background. So good luck.
Perfect. Thank you. All right, let's do this. Hi, everyone. Let's see how this goes because the Godot console sports launch was this week, and that took all of my time because I've been doing that since last year and barely had enough time to get through this in a sane way. So fingers crossed that demos work and everything. Let's see. All right. So hi, I'm Shanna. I help out indie devs port their games. I also work on game engines. That's why I'm working on the Godot console port. I used to work at Unity on the game engine. I used to work at GitHub with GitHub for Unity and GitHub for Visual Studio. I've ported a bunch of games, and I worked on the Mono project on Mono. So we're talking about embedding C# right now, and it's a thing that I've been doing for a really long time, and it doesn't really get any easier with time. So my hope with this talk is that it is a bit easier for you to do this, and I have tried to document how to do it in a cross-platform way, and hopefully you can replicate and do this, which is a fun thing, running C# on your C++ app. So let's do this and hope for the best. All right. So why C#? So why would we want to embed C# on a game engine or an C++ app? To be honest, so you can run other scripting languages. You can do a lot of things, but the reason why one would want to embed a scripting language in the C++ environment is because every language exists and doesn't exist in a vacuum. Every language has its own uses, its own things that it does best. And C# is a particularly expressive and powerful and performant language that people without an engineering background can easily get into. It can be used for scripting, for programming. It kind of combines the values of performance and ease of use in a way that not a lot of languages do. You can also embed Lua, you can embed Python, you can embed all sorts of languages. They will always be embedded for that purpose, to provide a quick and easy tool for someone to quickly script behaviors without worrying about memory pointers and C++ and whatever. C# I think is more powerful than most other languages out there for scripting. It can live in a lot of environments that other languages don't perform well at. So that's my excuse for this. I've also been doing C# since 2005, so I'm biased. What can I say? So how to embed C# is a complicated problem because there's a lot of words and concepts involved. And if I just throw you the code or the concept, like if I start explaining this stuff technically, it will make no sense. It might make sense for some of you, probably not all of you. There's too much jargon, too many words. So before we start on the technical things, we're going to go through the words and try to make sense of what the vocabulary for C# and embedding environments is, so that we can make sense of the technical parts. And so let's start with the story, because just throwing a bunch of words doesn't make not fun. Let's get a story going, and let's start with Java, because why not? So Java appeared in the world 1997, 1995. It exploded in the world, not necessarily appeared then, but it exploded in the world, and it was all the rage back then. In 96, I think it was when we came in. And they came in with a really, really nice, catchy tagline, which was write once, debug everywhere. Sorry, run everywhere, anywhere, run anywhere. That's it. Got it wrong. It's fine. Java, write once, run anywhere. And the reason for that is because Java, instead of being a normal language where you write some code and it gets compiled into the machine code that is going to run on that machine architecture, Java introduced the concept of a virtual machine that abstracts away the particulars, specifics, and differences of the actual machine that your code is going to run into. So the virtual machine is a little sandbox inside the OS, hiding away all the specifics, and Java targets that virtual machine. And the virtual machine executes, and the virtual machine's job is to do the actual native things that that particular machine needs to. And it does this by Java creating a bytecode that's standardized for the virtual machine, so that when you write your code, that code gets compiled to bytecode, the virtual machine executes it. And now which OS and hardware that virtual machine is going to run to is no longer typically your concern. It is whoever implements the virtual machine implementation for a specific OS, for specific hardware, will implement that, but your code is going to be running on a virtual machine, and it doesn't really matter where that virtual machine is. And so you don't have to worry about the details of how the assembly code needed to run on this machine, or what a network call looks like on this machine, or what the file system looks like. You write it once, and it runs, which is where the run once, write once, run anywhere comes from, but also write once, debug everywhere, because turns out it's kind of hard to make an abstract virtual machine that runs anywhere. But it was a super, super, super powerful concept for a time where all languages are either just interpreted or assembly code. And with barely levels on top of something that was more abstracted and easy to get into, but really still hard. Like programming is very, very, very hard to do, because all of the languages that were powerful enough to do it were just very complex, and still are, a lot of them. So this is super hot idea. Everybody was on this board, including Microsoft. Microsoft is super excited about this because they had a really big problem. They needed to expand their developer market. They want more developers to build apps for Windows, but like programming for Win32 is something. Win32 APIs, COM APIs, C and C++. It was really, really hard for people to make apps that were secure, that ran without crashing all the time, like all of the problems of creating native apps in C and C++. And they wanted an easier way to give tools to people to create apps. And Java came in with this idea where, hey, we can just have a simpler language that just hides away all this complexity. It was great, portable, perfect. The problem was native calls. So in order for Java to be performant on Windows, because Windows is all Win32 native APIs, Java needed really performant in native calls. It would just have to be fast. Otherwise, an app written in Java running on Windows would be super slow. And the problem was Java was never meant to run like this. It was never meant to allow you to call the operating system directly. It's always meant to run on specialized Java hardware. There was even Java machines. It was always meant to run on a virtual machine and hide everything for you. So this was a problem for Microsoft. And so they decided to do something about it. And this is our first concept, first couple of word clouds. So now we're going to be putting up some word clouds together here. So we have native calls is kind of a key thing here, which is where the ability to be able to call a API, a function that is written in another language, C, C++ usually, and in a performant way. So Microsoft's solution to this was to create Visual J++, which is basically the fastest VM Java implementation by far, because Microsoft kind of knows how to do this. So they were better at it than everybody else, with some extra features on top, which is the fast native calls. And so what they did was for Java, it's literally just Java, and then they added some extra syntax in form of a comment when you call a function that's supposed to be a native function of a thing that was implemented in a library written in C, and you put a little comment on top of the signature, the declaration of the signature that you're going to call, saying which library where this thing should be called into. And the Java VM, the Visual J++ VM implemented by Microsoft, would interpret this, and bypass the garbage collector, bypass everything, and just go straight down to C. This is the JDirect, an example of a JDirect call from '96. And if you notice, and if you've done this sort of thing in C# before, you might find this syntax strangely familiar, because this is the C# invoke call. And I will actually put them side by side so that you can compare how this evolved, where this came from, basically. So this was all fun, and this is all fun. July, August '96. Everybody was raving about this, and then by '97, Microsoft's getting sued by Sun. And the funniest bit of the articles around this time is that their complaint, the major complaint that ended up triggering the massive antitrust lawsuit that ended up forcing Microsoft to take out Internet Explorer from your desktop, is because Sun was very annoyed that Microsoft has added functions on top of their API. So they didn't change Java, they just added 50 methods on top of it. And that is highly offensive, extending the Java libraries with 50 methods. And this is specifically in the complaint. And there's a bunch of keywords here that that are relevant to our conversation, that we're going to put on our word cloud, which is native calls and class libraries. Class library concept comes that you might or might not have heard from C# is the set of libraries that are made available as part of the language itself. And that set of libraries is called class libraries because they're available as part of the language. And usually, like, they don't change that much. You can rely on them. And that comes from Java, and we have those in C#. And native calls is the other concept that we have. It's the eternal struggle of the native calls. So we can't have J++ because we have a lawsuit and we're getting sued by the American government over adding things to a library. So let's not call it J++. Let's call it C#. Might as well. Like, just make a new language, which is the same language, but with a different name. Might as well improve on some things, but I mean, not change that much because it already had the thing. The interesting part of all of this is that Java was never open source. It was never standardized. It was never open source. They got sued specifically because the license agreement for Sun and Java did not allow anyone to extend the library, to implement VMs, to do anything other than use the thing that was there. And so they decided to do C#, but in an open source way. So it was just open source up front, open standard, standardized. This is what it is, as a proof of good intentions, I guess. So it's just highly ironic. So now we have C#. And let's go back to our virtual machine bytecode Java thing and put in C# instead, because we're still in the same model. This is what C# is. The compiler produces bytecode, and then the virtual machine is executed. If we expand this more, we have the native calls at the bottom. The virtual machine will do the native calls into the OS, depending on what it needs to do, those native calls that are super, super important to be very, 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 very fast. If we expand this a bit more and we introduce a couple more concepts here, the virtual machine is the common language runtime, as it's called on the C# land, and it's composed of either an interpreter or the just-in-time compiler, depending on what type of mode the virtual machine is running in. It has an exception handling service. It has type safety, garbage collector, thread management. So it's kind of like a little OS inside the OS, doing its thing and then calling out into the actual real-world OS. And then the OS calls back into C#, et cetera, et cetera. Those go into our little bag of words. So we have the common language runtime, the interpreter, and just-in-time compiler. A few more words going in here. We're starting to get a lot of words, so get these into acronyms. CLR is what we call the runtime. GC for garbage collector. JIT is the just-in-time compiler. Interpreter, we still call it interpreter. The bytecode we call IL because it's an intermediate language representation. It's what it's called, and it's basically literally what it says in the tin. It's an intermediate language. It's not exactly what the thing is actually going to run natively in the end, but it is not C#. It's at middle level. It's a standard that looks like assembly, but it is not assembly. So all of this is called .NET Framework, or was called the .NET Framework back when it came out. At which point we need to talk about naming conventions for .NET, because this is going to be starting to be very complicated if I start saying .NET 10 times and it means 10 different things. And Microsoft's just so good at naming things that we need to talk about this. Initially, .NET, it was the ecosystem, the brand, .NET. .NET Framework, the actual language tools, the class libraries, the runtime, that was a thing. And when we talked about .NET, we were talking about the whole overall thing. .NET Framework, that specific version of the thing that we were using, is what we were doing. And it's been around for 20 years, finally stopped being updated. So that's nice. And for .NET Framework, kind of important, hopefully less important as we go forward, we have versions 1 to 4.8.1 of .NET Framework. As I said, it's based on public standards. The languages are available. You can download them. You can see them. The standard for the language has been updated. It's constantly being updated, but the infrastructure, the IL and everything, surprisingly, it's stopped since 2012. It hasn't been needed to update it, which means the runtime basically has all the needed features for any future feature, current or future feature that C# actually has. The runtime already supports it. Anything that's been done in C# these days is just, syntactic sugar, like changing syntax, but the runtime can already run everything, which is important to us because that means anything that's compiled today, a runtime from 10 years ago can run, which is interesting if you imagine compile something, create a DLL with a .NET Core compiler version, language 9, 10, whatever, and you can run it on Mono from 10 years ago, and it will run because the VM, the CLR, the IL standard hasn't changed. All the features are there, and so it can run, which is really super interesting when you're wanting to build a thing on one version of the .NET Framework, .NET Core, and then run it on a different one. It also comes with patent promises, which is super important. That means that anything that's implemented that might be covered by a patent in the implementation of this stuff this patents will not be enforced. You're fine. You'll never get sued for them, which is the whole problem with Sun. So that's burned, kind of like being different for Microsoft, trying to be better. So at some point in 2016, they decided that .NET was too meh, and let's call ourselves .NET Core and do a cleanup. There's a lot of APIs that really needed to be cleaned up, and you really can't throw away the class libraries that are backwards compatible and everything if you don't clean up house. And so cleanup was needed, and they decided .NET Core and .NET Core 1.0. But not the language version, because the language version is based on the standard, and the standard they can't reset that. So now the language version of C# and the .NET version became out of sync. But that's fine. Okay, that's okay. .NET Core 1.0 to 3.1, we're good. And then .NET Core 4 was about to happen, and they realized people were, when they're running code, embedded code, they were looking for the framework, the version that was stamped into the DLL, saying which .NET version it had been compiled against or run against, or it was running against. And if it was .NET 4, do X. Of course, they weren't checking whether it was .NET 4 or .NET Core 4. So that was a problem. Turns out their tooling did that too, to kind of go like, oh, we're in .NET Framework 4, do something else. So that's okay. Let's skip .NET Core 4. It's fine. It's not a problem. We got this. But I mean, if we're skipping .NET Core 4, might as well rebrand the whole thing, because like this is still not like, we don't really like this. .NET Core kind of weird. And let's call it, what are we gonna call it? .com? That's silly. Maybe .NET. Let's call it .NET. But the problem is the command line tool. So like there's a CL, that's the compiler, Mono has its own compilers, like there's all these different toolings, and we really, really need to have like a uniform standardized thing. Let's rename everything. Let's just really do good renaming in here. Let's call it .NET. So now .NET is the ecosystem, .NET is the tooling, and .NET is the command line. Okay, clear? Easy to follow. It's fine. Don't have to remember anything. Everything is .NET. This is not up to date because there's more versions now, but this is the thing. When a Visual Studio says this feature is not available in the C# version, it's not complaining about the .NET or .NET Core, the .NET Framework or .NET Core version. It's complaining about the C# specific language. But all of these target different. It's a mess. It's a mess. I don't like this. I can't talk about this if everything is .NET. So when I say .NET, it's the ecosystem. It's the thing. It's the whole bundle. When I say .NET Core, it's the tooling and CLR and class libraries. Especially because the runtime is called literally the DLL is called Core CLR, so it's .NET Core. It's Core. And I'm going to say the .NET tool. Well, what else can we say? It's called .NET, and I can't say a dot instead of dot. It's very confusing, but I will say the .NET tool, and hopefully it's not going to be confusing during this talk. Your mileage may vary afterwards. So, word cloud, we got ourselves the .NET tool, .NET Core, into the mix. We got ourselves some p-invokes, compilers, C# tools, class libraries, all of the nice words. This is .NET. So, going back to our little picture of what's happening between the C#, the virtual machine, and native calls. We saw before that C# turns to bytecode, virtual machine executed, and then OS calls happen because the virtual machine needs to call down to the native to do actual like things on the OS. Let's turn this sideways because our goal here for this talk is embedding C# in a C++ application, which means our entry point is C++. So we're going to come in from the left side of this chart. We start up our app or game, whatever, like this. Can be a game engine, C# embedding, it can be app, it doesn't really matter. It's all the same. We start with C++ land, and at some point in C++, we initialize the CLR, the runtime, and we tell it, go please run me this code. And the runtime will start up and run C#. It will load the DLL from disk, it will interpret and start reading the IL that's in the file and start interpreting or running the JIT over it, which is a just-in-time compiler. So it literally, as it's interpreting the intermediate language, it is compiling it at the same time to machine code. So the next time that code runs, it now runs full machine code. It doesn't have to interpret the IL again. So that's a just-in-time compiler. It will run the GC, etc. And at some point, managed side is going to scale. Oh, I need to call this C method or C++ method, and the CLR is going to call back into us. If that's what the C# is calling in back into us. So that's the loop. We start on the left side, and then it goes back and forth data between these lands. And this is another two things that we want to make sure we are clear. The C++ side is called the native land. And the C# side, VM, CLR, everybody, is called managed land. And managed land is a term that's used very commonly to describe everything that happens on that side of this fence. And you might hear terms like native peer, managed peer, which are like objects that are like linked together. So if one of them is garbage collector, dies or destroyed, the equivalent on the other side is also destroyed, and which is very common in game engines, in Unity, definitely. So these two native and managed lands are like where we're going to be living. So the calls back from C# from managed land into native land is called a p invoke. I can't even remember what platform invoke. It's a platform invocation. That's why it's called p invoke. So p invokes are, there's many ways of doing them, but there's generally, if you're going from managed to native, it's a p invoke. If you're going to native and managed, it's just running C# code. There's no word for it. So C# as an embedded language started, I'm sorry, I think I ran out of. Can you hear me? Yeah, I ran out of battery on my headphones. Sorry about that.
We can still hear you and see you, so everything's still okay.
Okay, give me a second here because. All right. Okay, sorry about that. I ran out of battery on my headphones. It didn't even tell me. All right, so C# as an embedded language started with the Mono project because the Mono project was an implementation of .NET, the language, the compiler, everything on Linux. And for ease of use in general, just to make that thing, just re-implement the whole thing, it was just much easier to start from C and C++ than to start as a pure C# environment, especially because Linux runs on so many things. It was just like the way that it got created just lent itself to being a very small embeddable engine that you could just put somewhere and run. So much easier to test too. And so Mono project first released in 2004, and it was basically just reading the standards and implementing the thing. And cross-platform, because we kind of had to run this on Windows to be able to test, because you're implementing a thing, like you're bootstrapping your own thing. It's kind of hard to build a compiler for a language when you can't compile the language, so you need to build. It's chicken and egg thing. So it ran on Windows and Linux and Mac, just because everything's Unix in the end, and open source. And for a treat, it came with an ahead of time compiler, which we're going to shove into our little word cloud here. So AOT is the third mode of execution. We have the interpreter, where it just goes through one by one of the intermediate language and executes it. We have the JIT, which goes through and compiles it as executing. And AOT, where it's literally compiling to native code the IL before it's executing. So doing what the JIT does, but ahead of time. This is so that in environments where the JIT can't execute because memory can't be written to or whatever, you can pre-generate the machine code for that architecture ahead of time. That's why it's called ahead of time compiler. So Mono's used everywhere, acquired. I'm going to skip through the history lesson here. I'm mostly have these slides for reference so that you can later see the slides. Just going to briefly mention that Unity leveraged the C# Mono compiler and runtime to be able to put C# in games. And embedding Mono until at least in 2011 when everybody got fired. And then the license just went up in smoke, and Xamarin was created, which took the IP from Novell and ran with the Mono projects and gave license to everyone. So we can still embed C#, except Unity. Unity didn't get a license. This is where IL to CPP exists. because of this licensing problem. So Unity had two problems. They couldn't run GPL. The Mono open source license was GPL. Then Apple didn't like that. Mono had a commercial license, was not GPL, but Unity didn't have one of that after 2011. So Unity decided to create IL2CPP, which is basically taking the intermediate language, instead of running the runtime with it, it transforms it into C++, which can then be compiled with a normal C++ compiler, and then it's no longer running in that VM, which is licensed badly, and they can do their game engine. So this is what Unity looks like. It's an extra step at compilation time to execute the C#. So, and then everything went open source, and Xamarin got acquired by Microsoft, which is really nice because Mono now lives in the .NET runtime repo, which is going to be handy for us right now as we're going to be looking into how to embed this thing. .NET also went open source, but I mean, it was not made to be embedded, so it's never very useful for embedding. The advantage of having Mono and the Mono team working with the same team as .NET Core is that their embedding capabilities could slowly propagated into the Core CLR, and actually added embedding capabilities into the Core CLR. So now everything is .NET, Mono is .NET, .NET Core is .NET, everybody's .NET. So let's talk about actual embedding. So we have two runtimes. We have Mono and Core CLR. They all run in Mono runs everywhere, basically. Core CLR runs on desktops and on some other platforms, depending on some other platforms. Maybe iOS. There's experimental previews. Maybe not now anymore experimental, but there's a subset of platforms where Core CLR runs. Mono has three modes: JIT, interpreter, and AOT. Core CLR has two. They never built an interpreter. The interpreter that they have is only for testing, and it's not actually good for production. And which one do we use? How do we choose? We use all of them. Because it really depends on which platform you're going to be trying to run C# on and what tooling exists for it. So if it's Win, Mac, and Linux, you can use any modes. All of them are available. If it's iOS, you need to use an interpreter or EOT. You cannot use JIT on that platform. And there's no Core CLR interpreters. So there you can only use AOT. For Mono, you can use either. Android, you can use all of them, but you either do interpreter or AOT because JIT is super heavy at runtime, and you probably just don't want that. On the web, AOT or a JIT interpreter. WebAssembly, there's a lot of like retranspilations of IL for web. And then on consoles, you can only use AOT interpreters, the same restrictions in iOS. You're not allowed to JIT. So let's look at actual code. The basic embedding steps for embedding C# is you're on your C++ app and you call something to initialize the runtime, whichever runtime it is. It could be Mono, it could be Core CLR. Once the runtime is initialized, you can call C# methods, and C# can call you. And basically that's it. And now you're passing around data as arguments and return values, and you're good. Because we have all of these combinations of setups, mostly we have like three broad setup types, which is AOT is not a runtime, but for the purposes of this, because the tooling is so different, it kind of is. And like the initialization of the AOT mode is just so different. You can almost think of it as a different runtime to initialize. So we've got Mono, and it doesn't really matter which mode it's just a flag to tell it which mode you want, Core CLR or AOT. For both runtimes expose a C API to do the setup. Mono is an extensive API. You can really control the runtime and do everything that you want. Core CLI is bare minimum, but because Mono's living in .NET runtime and Xamarin Mono for Android, Xamarin Android needs a lot of control, and Xamarin for iOS as well needs a lot of control over how the runtime is initialized. Some of these APIs, like some of these embedding capabilities, have been slowly trickling into Core CLR, so we actually have more stuff in there that we did before. Also, you don't have to compile Mono or Core CLR or any of it from source to embed C#, because all of the packages for the runtimes are available, and you can just reference them with NuGet and grab them and start using them directly. Also, another advantage, like this came out of the fact that Mono runs on all of these environments, so it's kind of handy for their tooling to have the Xamarin tooling to have access to all this stuff, and so over time this stuff became available. The Core CLR initialization is on Windows is horrible because it makes assumptions that why would you ever embed anything? Terrible, horrible. It's convoluted and really annoying. The Core CLR non-Windows is one call, Core CLR initialize. Done. No OSFXR, no nothing, just done. For Mono, there's a bunch of different calls that you have to do in order for actually getting the setup to go. And this is where we start talking about CSharpify, which is a little project that I put together that takes care of all this stuff, because just taking care of all this stuff is just so much really annoying work of trying to figure out what each runtime is doing, that I got tired of it and put it all together in one thing. So that's the URL. It's also where a version of these slides is. And that's what we're going to be looking at it today. It's a header and source and CMake library that you can just consume as source. And it has like, just load the runtime. Okay, thanks, bye. But also has a little example of how to embed C# in a game engine by taking a DRM GUI, which is a GUI library, C GUI library that has a bunch of examples, and just plugging C# into it so that we have a nice window. So the way to do, once you have initialized this, and I promise we'll get to an example 2 minutes. Once you have initialized your runtime, the next thing you need to do is to call a C# method. To call a C# method from the native side, you need a pointer to it. You need to ask the runtime to give you a pointer that you can use to call it. And you do that with Core CLR create delegate, where you give it the handle of the runtime that you've initialized, and then you give it the name of the assembly, the type, and the method that you want to call, and it'll give you back a little function pointer, a delegate. Delegate is the word that you've probably seen if you do any C#, which is literally just means a thing that you can execute that represents some function, but it wasn't, it wasn't determined at compile time. You create it at runtime, and that thing points to that function that you want to call. Goes into our word cloud. On Mono and non-Windows, Core CLR doesn't even need domain IDs. You just call a little pointer. It doesn't use it. It can just go. So this is what the code for running on C# and C++ code for calling a method would look like. On C#, you would have, imagine you want to call from C++ to C#. You want to call a method. And so you declare it on C#. In this case, it's a static method, because that's the easiest version of this. It's a static method called isOK that returns false on the C# side. You have a attribute called unmanaged callers only, which tells the runtime when it's compiling, tells the compiler when it's compiling, don't throw this away, even though nobody's using it, because this is going to be called from the native side. That's important because the compiler will trim anything that's not getting used. There's no point in compiling it. If this isn't used on the C# side, it'll get thrown away. So that's what that attribute is for. On the native side, the C++ side, you have a declaration, C++ declaration of the function, which is a static bool, returns bool, and doesn't take any parameters. And then at some point in your code, you're going to call core CLR create delegate, and it will return you that function pointer, and you just call it. The types that are returned, the data that is returned, this is an important little detail. You can only move data around that's splittable, and by splittable it means it can be copied from C# to C++, or at least represented from one side to the other. It's a chunk of memory that one side and the other agree that it represents that. The managed callers only attribute also makes sure that the types that you're calling, like using for your calls, match, are splittable and can be passed around. So some more words for our word called trimming and splittable. So you want to go from C# to C++. It's our friend DLL import that we saw at the beginning, and you tell it which library you want to call, and in this case, it's the name of your native executable library, or magic names that we will see in a bit. And you call and you declare that as a static extern. Extern is important because it's an external. It's not there's no implementation of it on C#. And then when you call it, it goes here into our is okay. So in practice, let's look at this in practice. In practice for CSharpify, I have CSharpify here. In practice, what this means is that this call here, like this is the entry point to my C++ app. It's going to come over here and call our onStart method. And I'm going to put a little breakpoint right there. And I'm going to be, I don't have. Let's put a little breakpoint right there. So this is our C# unmanaged callers only. It's a static void. Visibility doesn't matter. And this is our C#. And that's our C++. Oof. So this is our C# call, and you can see. Let me get. Oh, I probably didn't compile. I moved code to run and didn't compile, so my breakpoint didn't hit. But we started here on our little native side and called onStart, which is somewhere over here. This gets the pointer from the core CLR that in CSharpify is a little function implemented there that does the same thing as core CLR create delegate, because the signature is slightly different depending on the runtime, so this hides that and grabs the method from the assembly and then calls it. And this is where we are. We are here and we are getting called. And then when we continue, we have my cool window, which is the IMGUI C++ app running on my little app. And then, but on C#, I'm initializing that little window and I'm doing some text. And then I am calling a method here that is our DLL import that we saw before. And this is going into, this DLL import is going into magic name internal. which will redirect our calls into our own running app, because that's what we want to do. We want to call ourselves on the native side. And it's going to call the native method called returning bool. This native method called returning bool is declared here. And if I won't, the breakpoint won't hit because I didn't compile this one briefly, but this one is returning false, and this goes back to C# and gets shown. So the DLL import, pinvoke, you can only call C functions because C functions are, the names are known. C++ names are not known. And this is what we're doing, is just calling the pinvoke. So now there's two ways of doing pinvokes. You can do it with DLL import, or we can do it with library import. I have, this code is available for you to look at. I have all of the examples of different ways of doing DLL import and library import with and without bool marshalling. I'm actually running out of time, unfortunately. So, and there's so many more cute examples to show. I just want to give you one question for the audience. You can look at the comments. Does that code run? If it is a method called check if okay, it is calling if okay right here. This is a native call that's going back into C++, and C++ is just returning false. So if this is false, does fail run? Does fail run? We don't have a lot of time. So maybe let's look at our code, because the code is actually running. So we can look at it. So I'm going to run this again. And our code that we were looking at is, this is calling the bool. Bool is returning false. Should be false, but it is true. If you learn anything from this one talk, is that sizes matter. When bool in C++ is 1 byte, 8 bits, bool in C# is a full 32 bits. So when C++ returns false, it returns 8 bits of false. But when C# reads the bool on the C# side, it reads full 32 bits. Now, it reads whatever memory is in there. So if, there's other parts of the memory that have ones in it, it is no longer false. It is true. So never use naked bools to pass information around because it won't. It just won't work. And so there's this example. We have all of the different ways of marshalling a bool, custom marshalling, and automatic marshalling. The one more thing that I want to leave you with, and you can just look at the code. I will give you the URL again so you can see all of this, is that the way that the magic that is happening here, in order for you to just say, call this thing, and it gets called, is with a little package called the DNNE, which is actually a Microsoft internal project that they use for testing, which auto-generates C calls and C definitions from C#, which is the thing that makes all of these things so easy to do. So it will generate all of these calls, all of these signatures on the C side based on what you have on the C# side, and so you can quickly and easily just add things on the C# side, and it will automatically show up. And so I will We have 5 minutes to 5. I want to leave some room for questions. Where am I? So all of the slides, these slides, and I'll put up another version of these, the updated version of these slides are on the CSharpify repo. And all of the code is in there. And just ping me because there's a lot in here that I did not cover. And if you want to know more, you can go and look at it. But yeah, questions.
Okay, that I have to admit, I laughed the whole time you were describing .NET's naming because it is confusing, for one. And for two, Martin, a colleague of mine, and I have gotten in trouble for saying drop the dot because we are pained by putting .NET at the beginning of any sentence because it becomes a nightmare because there's 7 periods and you're dealing with all this nonsense. So I really appreciated that part of the talk.
I mean, my stupid C++ hat is still boiling from all the history. Right?
Yeah. Like there was way more slides. And there's way more information here. I just don't know how to cover all of this stuff without giving a high overview. I mean, it's also really good excuse to give an overview of this history, which is super stupid. And I like telling it. But really, look at the code, look at the examples, and look at the rest of the slides to get a better idea of how this works. This runs on, right now it's running on Mac and Windows, probably iOS. I need to go test it again because I keep fixing one and breaking the other. But my goal with this is to actually have a little just source drop library that you can pull in and just target any platform because it doesn't really matter at some point once you got those covered, like all the other ones will work, and then we just do C# and C++ and not worry about any of the other details.
Well, I mean, I have an interesting question because when you were talking about embedding kind of all that C sharpness into a native application and C++ is your entry point, do you feel like C# has to go through essentially a compilation process, whether it's like interpreted or AOT or whatever? Do you feel like that impacts the feedback loop that developers are looking for when picking a scripting language? You had mentioned Lua as well. So like,
yeah.
Oh, go ahead.
I mean, I don't know if that impacts it because the tooling is so good. When like for C#, like the iteration process for doing C# is so good that you really don't feel like it. And to be honest, in like an iteration environment, or an editor, if Unity had doing an interpreter mode instead of compiling, you can still get those iteration times down even more because the interpreter is there, at least on mono, to be available. I understand how like things like Python or Lua are easier to plug in because there's here's how you do it for all platforms, which is the problem for C#. When .NET comes out and goes like, we support all platforms as long as it's Linux, Mac, or Windows, that's not helpful. People want to run this on the web. They want this on iOS or Android or consoles, whatever. And they run into this stupid barrier of how I do this, right? Unity fixed that on their side, but like other sides, you don't have this. Unreal or any other game engine, you don't have it. That's why the other languages that are there, and people have already ported them and done the thing to run. That's why people go through and pick those.
Yeah,
that's what irritates me about this is that.
Yeah, I know the Godot team is currently still struggling to target C# to the web because they have WebAssembly issues. I mean, that leads to another interesting question. It's like, do you feel like have you played around with WebAssembly? Does WebAssembly change the embedding story for you? Does it open up new opportunities? Like, what are your thoughts around WebAssembly and native targeting.
Well, for web, the problem with not problem, like the scenario with WebAssembly is just one more step away from where you were original with C#, which makes debugging extremely hard because you're already going from C# to IL, and then you're going from IL to WebAssembly, which is a completely different bytecode, and now you're debugging that. And like, how do you do this for a developer workflow experience? That's hard. That's not a nice experience for a person who just wants to run a thing. Right? So but I don't think there's any way to go around it. You really need to be able to target WebAssembly, and C# can do it, but the tooling needs to be there. It needs to be solid. And like Microsoft needs to understand that all platforms are not just Microsoft, Windows, and Linux, that it's all platforms. And if they want to own the ecosystem, they need to own the responsibility to running this thing on all of the ecosystem, not just the ones that they happen to like.
Yeah, that's true. Ironically, I wanted to point this out. I think a week or two ago, Microsoft and the .NET team actually transitioned the maintenance of Mono over to the Wine project team. So
yes,
I actually put a link to that in chat.
Worries me, hopefully, because the thing about Mono being inside .NET is that it's just like making .NET so much better. Because the Mono team knows how to do cross-platform. They know how to do this. Like half of these APIs that I'm using right now to embed are things that the Mono for Android and Mono for iOS team introduced in .NET because they needed them for embedding. And because everything is inside .NET/runtime, and you need to test. You can't, and like the Mono's runtime is no longer its own separate thing. It's embedded inside it's together. Like the APIs need to be exposed on both sides of the equation, basically, and it's just making the whole thing better.
Yeah,
basically.
I agree with you 100%.
So I hope Mono going into Wine doesn't make that go away because that cross-pollination has been really good for .NET.
Yeah. Alex, I think you have a question here. I know you're a C++ god, so this C# stuff is...
Yeah, I've been trying to avoid touching C# with the 6-meter foot as much as I could. I mostly like C++, but I was really curious about a few things. So if we're initializing our C# engine inside of a C++, and we want to call some method from C++, the method is in C++ or C, and we want to call it, but it is not in a separate DLL. It is still like in the main executable. Like, do we still call it like DLL import and the name of the executable, or is that some other way around?
Yes. So you call it, if we can get the screen back up, and I will move this way. You call it. So you do this. The DLL name is now internal.
Gotcha.
And then on the runtime initialization side, because this name, Mono knows this and knows that this is the running process. So any method exported from your running processes, Mono just handles it, but Core CLR doesn't. But you can tell Core CLR when you initialize it. Wait, give me a second here. It's somewhere here. You can tell Core CLR that you want to be called whenever any of those calls happen. And you can just redirect anything into your own internally. So this function is going to get called with the whenever a DLL import happens, whenever pvoc happens, with the library name and entry point name, and it can go like, oh, it's internal, or in this case, because I'm compiling, in this example, I'm compiling both SDL2 and C. I'm going all together into this app. It's not a dynamic linking, it's static linking. Everything is in this one app. So any calls from C# land that come to one of these libraries, I'm just going to load the symbol directly. So that's how you work around that on Core CLR. Mono, you can just say internal and it'll just go directly. So yeah.
Gotcha. That's neat.
Alex, C# scares you? That C++. I'm so grateful for you folks, because if I have to touch any of that stuff, my head will just explode. So all the credit to you folks for doing that stuff.
That C++ might be a little dirty. It's a proof of concept thing.
I just see it's like looking at matrix code to me. So here's an interesting question. You had mentioned AOT. I know Mono has kind of laid the groundwork for AOT, but the current versions of .NET are also introducing AOT. Do you feel like those features are going to help developers? I know developers, especially on the Unity side, there's the infamous GC stutter that is known with managed languages. Do you feel like AOT could maybe help a lot of people, or do you still feel like there's a little missing there?
You can't get rid of the GC stutter even on AOT, because the runtime, like all of the lifetime of the expectations of a lifetime of a C# object that's in running still need to exist. The only thing that AOT is giving you is, instead of the IL, the bytecode being interpreted at runtime, it gets pre-compiled into the machine architecture, but everything else in there is the same. It's you still have all the mechanisms, all the assumptions, because that's how the lifetime of a thing on C# exists. And native AOT is, native AOT is a necessity for platforms that don't allow JIT, iOS, all consoles. You have to have it. Like, it will not run unless you have an interpreter, and the only interpreter that exists is Mono's interpreter. So now, like if you're targeting Core CLR, if you're all the thing running around Core CLR, now you have to bring in the Mono interpreter, which is fine. Again, the point of this is so that you don't have to worry about it, but it's still another variable that you might not want, and you might not want to run your code on interpreter if you want to be really efficient about it. So you either do interpreter or do AOT. There's no other way around it. You're still going to have your garbage collector hitches, and for that, the only solution really is to do what Unity did, honestly, is to write their own IL compiler that can generate C++ or whatever, that knows the alignment of data that is important for the game, that knows which points the garbage collector should be getting called and which points shouldn't be getting called. Because the garbage collector is not a problem unless it's freezing your mainframe right when you're doing a hit on a boss, right? So the garbage collector needs to be called at specific points that are loading scenes that are fine. Like, the garbage collector needs to be contextual. It can't just be generic. So, and managed languages, ideally we have a managed language without a garbage collector. We have reference counting and other things, to be honest. But to do that, I think you'd need your own transpilation, not a runtime implementation like this, because I don't think you can replace, like, the idea of garbage collection is too embedded in this thing already. You can't go around it.
Well, I'll just say .NET is like letting you swap in different garbage collectors. I'm curious to see if anyone out there ends up building like a game engine specific garbage collector. So that's interesting. But I'll leave you with kind of a last question here. And this is a softball one, but I think you'll enjoy it. I know Alex is going to enjoy this one. maybe he can chime in. But we talked about the ECMAScript specification for C#. As someone who works with indie game developers and kind of helps them port their games, is there a specific feature in the C# language that you would love to see kind of added, and what would it be?
Oh God, I want. There's two things. There's a couple of things that I would like, not as a C# language, but as a good implementation, which is a functional version like F#, but actually performant, that doesn't fucking copy meme around. Sorry about the swearing, but oh my God. The runtime can support it. Again, it's all a language thing. Because functional programming for scripting games is actually super, super useful. Like all the Uncharted games were written in a variant of Scheme.
Mhm.
Like designers can do this with those languages, and I'd love to see that. And I mean, that would be like, I was gonna say better p-invoke support, but actually, like the stuff that I'm using now that they introduced in .NET 7 is actually allowing for very, very good support for auto-generating signatures on both sides. So you can just auto-generate everything and not worry about it. So things are getting better, but functional, like better scripting environment. C# has like, you need to have a class and you create, like top to bottom. That's also why people like to script in games with Python and Lua. You start at the top and you just write your logic. No class creation, none of this. C# is just like,
it
too
does
much.
feel like a relic sometimes, and from object-oriented programming. So I totally
Yeah.
understand the scripting need there. So on
Just
that,
give them the pure assembly. No classes, no functions, just pure logic.
Just pure logic. Just do this. I just want to do this.
just copying memory slots. Oh man, you folks really are C++ people. Again, I couldn't do what you do. So yeah. But on that note, that was an awesome talk. I really enjoyed it. If you want to check out Shauna's other stuff, rewind, look at her slide, follow her on all her social media. If you're an indie dev that needs to port any of your games to consoles, she's your person. Yep. So on that note, again, thank you. And we'll catch you next time. Bye.
Thank you. Bye.
Bye-bye.
All right, Alex, we have another person here coming up next. I think you should introduce them because two Alex makes a right, I think. So
I mean, it always makes it right. The more Alex, the better. So I would like to introduce an Alexander Bondarev, a developer from the Ryder team who has implemented the support of the HLSL, I believe, for the Unity and bunch of other stuff. And I don't know if we are already allowed to talk about any debugging capabilities, or are they even implemented? But oh well, let's give a word to Alex and let him show what we're cooking.
Hi. Yeah, so as Alex said, I'm Alex, other Alex, and I'm working in GameDev team. So actually, it was not me who added HLSL, but I improved it a lot, I believe. So because I think during this day you're already a bit tired, so let's just play some games. Okay, so probably you all know this demo game from Unity, Sample. So I will just try to complete it during this meeting. So, and of course, I can just play game from Unity, so I modified it a bit. You see this blue guy become green guy. Okay, so I'm going to finish. No. Okay, so as you may see, we can spend a lot of time trying to complete this game, but you may see I'm not best gamer, but probably not worst programmer. So I tried to apply my skills to this goal. So I will show how we can use Ryder to improve your gaming experience, to improve your game, and actually make it possible to complete. So let me start with things I changed to this game. So I won't do everything during this session, so I prepare something. And let's start with modifications to the player character. So first of all, I think it jumps not long enough, and also it moves not fast enough. It will take a lot of time to complete this level. So to this, prefabs player, I added few properties to original code. First of this is max jump count. So you can make double jump. It may save you in some situations. And also I added boost speed on jump. So every time when you jump, you improve your speed. So let's try to change something. So like I change to 2 jumps and boost speed on jump. And yeah, another thing I improve it because I realized I can't complete this one life. So allowed to have more than one life. So now we have 3 lives. And let's try again. So as you can see, it jumps higher and now double jump. Okay, and I like Superman. Okay, still bad. But yeah, so we have these properties, and but you can see the guy is jumping higher and higher, and moving really fast. And then, okay, if I start this game again and face some enemy, then okay, I survive it. I survive it. Okay, first time I died. So I have 3 lives, but I don't have any visualization. And so I can add some nasty UI. But okay, I'm not good in UI as well. Almost as good as playing games. So, but I'm, as Alexander said, a bit know something about shaders. So let's go to shader and let's see what we can do. So I prepared the shader and I added speed % property and also added some magic property keyword to null, which allows you control shaded keywords. And then you can see in Ryder, so you can see the shader, you can see all highlight we have in Ryder. And also you can see special highlighting for shader features. So I got 2 steps forward and added 3 modes. So actually you can have no highlight for speed. You may have continuous highlight, like it just left function, and you have step mode when it changes color on specific fixed steps. So let's see a bit on code. So you can see here this piece of code, and then okay, it's all gray. So let's use one of features I added to Ryder, so we can control shaded keywords. So for example, if I want to see how it looks with continuous mode, I can just activate keyword, and you see it's changed visualization and it's underscored, and now block active. And also you can see this information. So this is shader variant branch, and it's not active in right now. So okay, so what we have here, we have the speed %. And when we have speed color mode, that's activated. And you can see for speed % we have 5 steps, and just use like simple arithmetic to like make it more granular. And okay, for color we just apply your function, and then it just changes from color to max speed color by speed %, which we calculate from difference from base speed we have. And so let's return back and check this player and check material we have here. So I changed mode to continuous, and let's see what changes. So you can see this guy changes his color. So it becomes more red and red as he adds his speed. So much better, I think, now. Okay, our clouds. Yeah. Okay, so much better. You see? Yeah, but one thing I forgot. So still no visualization for his lives. So back to green after that. And so let's try to add this visualization. So go back to the shader and start with adding attribute. As you can see here, I can use live templates like code snippets, and you can easily add property, and then you can call it something like else alpha, and then use another magic attribute from Unity like this. And then I can go use structure view, for example, for better navigation. So I can go to shader, can go to my program, and then I need to add shader feature. So now it says it enabled, and I can disable it, of course. So let's keep it enabled, and then go to this code, and okay, what we want to have here, if keyword is active, in that case, we need to modify core alpha, and they clamp it to something like health. Let's use some hard code, and then it's something like this. So from 50% to 100%, and then I can create a variable for health, of course. Sorry. Okay, now I think we have everything we need, except one thing. We need to set this health from code. So we can go to player controller. And I already have this update material properties method. And I already have this set float for health, which sets current HP. So it should work. Let's try. Okay, you see this guy is like transparent. But nothing changes really. So let's try again. So as you can see, as once I jump it changed it to solid color, so no more transparent guy. But when I face it slime and okay, I need another jump and another jump to update state. So what's going wrong here? Let's check the code. We have this update material properties, but it called from set max speed because before we only needed these material properties update changes values. So when we change it max speed, when we jump it. So let's fix it easy enough. Just move this method to update. So we have this update. We already have update gem state, and then we have material properties. Let's return to editor. Try again. Okay, this guy is solid. Face is slime, semi-transparent, even less visible, and died finally. So everything seems to work. Let's return back to our code, and we probably noticed some highlights here, so like speed percent and health. So Ryder tries to help you to find inefficient code and fix it. So here we see string-based property lookup is inefficient. Why it happens? Because every time when you set float, it basically calls shader property to ID to transform this string to identifier. And then it adds some overhead, which we want to avoid. But with Ryder, you can easily fix. Just automatically add new variable for speed percent, and it will do basically the same thing, but you don't need to look up every time. So let's fix both cases. I don't like to have health one. Let's do it as property ID, something like that. Okay, so now we have everything in place, but let's check one thing. Because on previous speaker said about garbage collector, and it may be not problem itself, but it may be problem if it causes like garbage collector interrupts. And so you have all this in game, you have lags, things you want to avoid. And one of ways how you can face this issue, so simplest and fastest way to have problem with garbage collector if you have allocation in every frame. Because okay, if you have like 120 or 240 frames. In that case, you have 240 allocations per frame. And more allocations you have, more problem. So let's enable profiler. Let's move it to bottom. Try to run this code. Probably don't need to play it. Oh, sorry. So like disable maximize it. So yeah, let's play a bit. Press pause and then try to analyze what we have in profiler. And you see here in player loop, we have 300, like 400 bytes allocated. Let's check what's happened here. And we can see most of bytes allocated in GUI repaint, and it's actually not a problem because, okay, it probably will be rebooted in release build. But let's see this update script behavior. And we here in update C, we have some allocations L player controller. So probably we have problem we need to identify. And one way to identify it, so you can just look into code, but and try to understand where you have this allocation. You can just and try to analyze all branches, or you can just use debugger, something like that, and try to step with debugger and understand where you may have these allocations. So let's try it. We have this breakpoint, and while we are here, I want to show you some features we have in Ryder, especially for debugging. So you have active scene here, view, and then for game object, you may see components. You may see some information about these components. So you have special predefined views for Unity, which may be handy. And like visualizers, you can explore. You can make queries for collections, things like that. Okay. So I won't go deep into details. Probably George already covered most of these things. So let's just debug something. So we have this update jump state, but nothing happens here. And let's go to next. And now I may notice this underscored new keywords. Okay, it's oblivious. It's allocation here, but also I have inspection, which shows there is instance creation. And this inspection is actually comes from a plugin which I love a lot. It's Heap Allocation Viewer. So it's absolute must-have plugin, I believe, for Unity development, because it's so useful to see where you may create garbage. And for this Heap Allocation Viewer, let me show some cases. So for new, it's oblivious, it makes memory allocation. But for example, if you have something like struct ABC, and then you have new ABC, in that case, it doesn't show there is memory allocation. So you don't need to check, and actually it shows structures and class names in different color. But if you have same color, in that case, it will be just simpler to understand if it's allocation or not. But if you have not so obvious case, then you probably may use other features. Okay, like allocation showcase. I prepared some cases here. So let's check a few of them. So basically allocation of new object. Then you see this conversion for boxing. like I need to stop debugger. Yeah. So there is bulk allocation because every time when you assign primitive time to object, there happens hidden memory allocation, and same things for closures. So for example, you have allocation for, because you have captured I inside of this section, and if I comment this line, then there is no allocation. And same thing when you build string with primitive time, there box allocation, and when you build string, there are allocation for string as well. So a lot of things which may help you identify such heap allocation problems easily and fix potential problems with garbage collector. And also one more thing I want to highlight here is hot paths highlight. So like for update function, you have event function with this fire sign. So it shows it really executes very often, basically every frame. But even better, when you go to material properties, now you see this frequently called, and you can check incoming calls and understand where is this path coming from to this method. So you can, if you see allocations, if you see this frequently called method, then you can easily understand it may be a problem, or maybe not. It all depends. Okay, but how we can fix this allocation problem? Basically, you can just make property or property block, and instead of creating a new block every time, you can just reuse this. And in that case, if we run again, and if I pause game and check allocations, okay, actually, let me see. Okay, to be honest, it still shows because of logging. Okay, actually it shows, okay, there are no instances, sorry. Okay, let's try again. Hopefully this time it will be better. Sorry, it was not my intention, so. Something goes wrong, so probably need to initialize an awake method. Okay, let's return just all the way. I don't want to debug it right now. Okay, so basically after all these improvements, we now have C visualization, and it's much simpler for me to complete this game. And probably I will be even successful in that. No, probably not. Okay, let's try. One more thing I forgot. When I kill enemy, I have extra life. Okay, I did it. Oh, now we have for like 5 more minutes, and I want to highlight a few other features. So first of all, for example, for this demo, I prepared 2 menu items. You may see them here in game. Make impossible and make possible. So basically, make impossible makes standard settings you have in game. So like 1 life, no extra jump, things like that. And make possible is of course better rush of game. And you have 3 lives, you can double jump, and you have increased jump height and length. So much better, I think. And let's check the code. So basically have this special function with prefabs, which modifies this prefab, and then I have some settings here. And yeah, if you debug in Kit, then you can just run directly from editor, so like this, and then you can see log. So you don't need to even switch to editor. Check if is it working or run such commands. So it might be very helpful in development. And then also we have things like that. So we can have inspections, Unity-specific inspections for physics, like recast all have no allocation version, which is recommended to use instead of this version, especially if you have something like that every frame. So you can easily convert to null memory allocation, and just then you need to create result here. And it will automatically even create type for this. And then I'll like initialize to something like, I don't know, 10 recasts. And then other inspections here for layers. So it says basically for, we don't have mask with this name platformer. So you can also see problems like that. And even better, you have code completion. So like you can just complete. And then of course, you have same thing for shaders. So if you have some shader in game, and then you need to look up it, then you can use, and then you can navigate to shader, and you can see usages. We have highlight for implicit checks for Unity object lifetime, like here. So you can easily understand if it's just regular C# null check, or it's something behind that, because in Unity it's some magic when comparing to nulls. And also I want to show you integration with assets. So like here, you may have max jump count, and then you can see it unchanged in assets. And then you can see right here prefabs and values in these prefabs. And you can then navigate to that prefab and see it in your editor. And if, for example, I use my special make possible. Okay, no, make impossible, because in code I have correct values, right? In that case, so I'd have max jump count, and then if I check, okay, did it work? Yeah, probably issue with indexes. Anyway, and yeah, what else? So I think my time is over, and let's get the questions in that case.
Yeah, that's awesome. You know, I've only seen this Unity tool window today. So that's kind of a cool feature that I didn't know we had when doing Unity development. So that's pretty cool. But Alex, do you have a specific question? I saw you wrote one down.
Yeah, I mean, first of all, I've never seen the speedrunning technique using shaders. That's cool for sure. Yeah, the question is I mean, that's a cool feature to have a code completion for some arbitrary strings for like shaders or some resources. What if I have some, I don't know, custom resources that I would like to add code completion for it as well. What do I need to do for it?
Actually, right now, we all code completion we have for resources as part of Unity plugins. So it's like not like we have some kind of customization. So we have indexes, which is part of Unity plugin, because not simple. But I think in Unity you don't have like custom resources because well, so it's either assets, and for assets you have code completion. So for example, if you go to this code, and you can see code completion here as well. So or you have shaders, or you have materials, so you have layers. So there are very restricted set of resources you may have. And so it's not really a case when you need kind of custom resource, because only if you have like a native plugin, maybe, I don't know, or something very special. But in that case, yeah, so you can write plugin for Ryder always to support this, but it's not like easy way to code completion.
Gotcha. So I need to take inspiration from a Unity plugin and to roll out my own implementation.
Yeah, actually, Unity plugin is open source. It's on GitHub, so you can check how other things implemented that do it in your own plugin if you need to.
So,
gotcha.
So Unity Game Dev uses a lot of C#. I noticed that when you're writing lines of C#, AI Assistant was kicking in and giving you like full line code completion. Like, have you used AI Assistant with your Unity demos, and kind of what has your experience been there?
Okay, yeah, actually, because full line completion enabled by default, so yeah, to be honest, it's not always useful, but sometimes it really saves you time, because it's like 50-50, 50% you remove whatever it's a guess, but in other case, it's like 3 lines of code you can just accept, and okay, it's fine. So like it often really good works in cases when I don't know if it will work now, but like if I have something like this. Okay, it's probably already have. Okay, should have return time. Writing writing on Kotlin too much. Yeah, and then I have like, so it is a magic happens or not? I don't know.
You're too fast of a typer. You gotta let the AI catch up to you.
Yeah. Okay, you see here, so it's suggested to complete A and B for arguments. And so if you have functions with a lot of arguments, pass it again.
I've noticed
yeah, maybe useful.
Yeah, I've noticed Matt Ellis, who's still watching and talking in chat, he's used it a couple times to maybe find issues in a particular script file, or even just kind of explain what a method is doing and maybe how you could refactor. You were showing like object allocations. I'm curious if folks could use AI Assistant there to maybe optimize some of those allocations away as well. So yeah, folks, definitely try that out.
Actually try to ask. So like find problems.
Mm-hmm.
And let's see what AI assistant will say. Okay, a lot of things. Okay, it says refraining from creating the material property block inside of this method is called frequently. So actually,
Yeah,
it
that's
highlighted
awesome.
problem. So yeah, you can use AI assistant to highlighting problems. I'm curious if it say why. In my case, it didn't work for material property block and instance creation.
Well, one of my favorite features is, I know you were running into that null exception earlier. If that null exception is actually shown inside of Ryder, there's typically the AI assistant button that can kind of tell you where that exception's happening and potential fixes for that. So I think that's kind of a cool feature as well.
Yes, yeah, probably because material property block can be created just outside of okay, so let's try to. So how it called start, I believe.
I thought I saw the override method in there somewhere.
Yeah, so it's even a function. So probably that way it will work. Okay, but yeah. So yeah, actually AI assistant I use it for things like you said, finding potential problems. So if you're lazy to review, I don't understand what happens, or for error explaining. Also, it's very useful for like teaching new things. So if you don't know some domain, you can just ask some examples and things like that, and then start from it and use it for learning.
I know Alex had a hot take earlier that says if you introduce CI/CD and source control, you're no longer an indie dev. Is that what you said? But one of my favorite features with AI Assistant is once you add files to your Git, it'll actually summarize the work that you've done in a commit message. So I think that's kind of a cool feature as well. So folks, when you get to AAA, like Alex has gotten to, you can just let the AI assistant write all your commit messages. On that note, any other questions, I guess?
Actually, I fixed this material property block issue finally.
There you go.
It was shame.
No, this is good. This is kind of what people go through. So I think this is kind of a good thing to show folks. Alex, do you have any other questions, or should we let this Alex go?
No, just to iterate on the topic of the VCS and my hot take. I mean, Dropbox's history functionality can go a long way with the game development, you know?
Yeah, that's true. That's true. Yeah, if anyone's using Dropbox, please let us know in the chat. I think that would be an interesting thing. So on that note, Alex, thank you so much for these Ryder tips and tricks for Unity development. Hopefully folks learned a lot. I think somebody said you went really hard on those Unity tips. So thank you so much again.
Yeah, thank you.
Yeah.
Bye-bye.
Yeah.
All right, Alex, we don't have enough Alex. So go ahead, introduce the next Alex here.
All right. The next speaker introduction requires at least a drum roll, because we are waiting for an Alex drum with a game engine with C# and Ryder. So please meet and greet. Hey, Alex.
Hello.
I'm starting to feel outnumbered here. Maybe I just changed my name to Alex and
Alex's Unite.
Yeah, I'm joining the Alex group. That's it. It's easier.
One of us.
I'm actually excited. I know I say this about every talk, but I am excited about this because earlier we did the dev ecosystem survey, and I feel like you're in that other category of custom C# engines. So I'm really curious to see what you have.
I've built more than one. And the fun thing is I kind of get to piggyback off of the last Alex a little bit, because I'm going to play with the profiler, at least in passing. So
okay. All right. Well, the stage is yours. Folks, if you're watching live, please put your questions in chat. We'll gather them up and ask them at the end. On that note, good luck, Alex, and we'll see you in a bit.
All right. As introduced to everyone, hi, my name is Alex Drum. I am a software engineer at Illustrals, and we'll go more into that in my About Me here in a minute. But my talk's going to be on game engines, specifically with C# and how you can leverage Ryder to dive further into that. So a quick coverage here. This is our agenda for the day. We're going to do a quick About Me. What are game engines? Why am I choosing C# for this? What are some Ryder tools we can use for this? We'll dig into memory management and optimizations for memory management. We'll talk about file compression, but in a very different way that can assist with your game engines. And we'll wrap it all up and go over an example. So let's dive into it. First of all, about me. As I said before, I'm Alex Drum. I am one of the software engineers at Illustrals LLC. I've done more than one custom game engines in varying languages. I've built proof of concepts in C++, and I most recently have really gotten into C# because of Unity and Unreal. With Unity specifically, I really got into C#, and now I'm here with C++ in Unreal. So digging into that coding background, Unity was kind of where I got into C#. I didn't really explore it before. Unity has created some truly incredible games. Hollow Knight, Subnautica, Among Us. I mean, there's so many mobile games that are made with Unity now, and it's one of the biggest platforms for game development today. So I really wanted to get into it, and I had to learn C# to do it. And my programming journey as a whole started in HTML, which was fun. It's definitely not a C-based language, or really it's kind of up in the air whether it's a programming language or not, but I think it is. I dove into C, learned how some memory works with C++ and C as I started playing with kind of rendering things to the screen, and learned object-oriented programming when I got to C++ because of the implementation of classes. And now I'm using C# on the regular, especially with Unity if it's available. So let's talk a little bit about the meat and potatoes of what we're going to get into today. What are game engines? Now, this is something that's really important to understand before this talk, because a game engine isn't a game. It's not. It's the thing that a game is built on. And the important part of that is understanding where that line is drawn. So I've made a couple of key points here on what a game engine is. I didn't really go over what it isn't, but first and foremost, a game engine will render objects, either 3D or 2D space, 3D objects, images, literally anything that you can come up with that is going to be displayed on your screen has to be rendered in some capacity. And there's a million ways to render it. I listed a couple under the bullet point there. There's a million for every different platform you could think of. And some work for 2D, some work for 3D, some somehow work for both. It just depends on what you're trying to do. But a game engine implements this API so that when you're writing the game, your focus is on writing those objects that are rendered, not on writing the rendering code to do it. Next up, they're going to calculate and manage the physics and physical interactions, which again, collisions, falling, movement, internal like jumping and gravity changes, inverted gravity. Running all of the math for all of these physics is something that only the game engine will do. The game engine is the only one that's going to handle all those physics-based interactions. Even if you're telling it what to do when those interactions happen and you're passing that to the game, it's important to remember that you don't normally calculate the physics in a game engine. Like in Unity, we don't calculate the collisions ourselves. Unity handles that for us. We just let it go. Scripting systems for development. Things like adding C# so that in your game, you may write your game engine in C++, but I cannot remember her name. She did a talk 2 games ago about C-sharpifying your development and implementing C# into a C game engine. That's exactly it, is writing that into a game engine. That's something the game engine has to handle. But also you can add in functional languages to make scripting easier, like Lua, or Ruby's a really good one. And I've used Ruby-like languages in implementation because they're really easy to implement and run. And then a couple of other things, audio, animation, asset management, world design, user input. All these things are handled by the game engine and then passed to the developer for the game. So it's very important to not write a game, but to write something that another person could write a game on, which that could be you. You could write a game on your own game engine, but it's important to understand what the purpose of the game engine is first. Following that up, we have some unknowns. And these are things that people just don't quite think about. The biggest one is the core of the game itself, which, think about it this way. The core of a car is the engine. And the engine in the car is what makes the wheels move and what makes the car move itself. The engine has the ability to take an input, like pressing the gas pedal to accelerate, but it doesn't drive the car for you, which I know doesn't really work in today's day and age, but that's the big thing about cars is it set you up for an input. Someone designed that input for it, and then you can drive it, which is a similar concept to what it is. It's what the game is built on. And I'm going to read this word for word. Bad game engines lead to bad games. And this is something that I will live and die by. If the game engine isn't built to handle the game, then the game will not run like it's supposed to. And it's super important to understand that building your engine can take place over the lifetime of building the game. You don't have to worry about writing the perfect engine the first time, but that's okay. Because the purpose of this is to bring the game engine into the background, make it a shadow. And that's where the memory management comes in. The game engine and the game will both need memory to do what they do. And because of that, that means that the engine needs to take up as little computational memory as possible, be it a processor power or memory, which is what we're going to talk about today, or operations onto the file system. All of these things need to be as small as possible. It needs to be a shadow in the background of the game. And we're going to talk a lot more about memory management later, but it's important to at least understand that the game engine needs to be in the background. And we're going to talk about how to put it in the background here in a little bit. But now that we understand what a game engine is, it's time to talk about the language itself. Why did we choose C#? Why did I choose C#? Why did I write a game engine in C# when most programming languages are done in C and C++, or all of these languages where you have much firmer control over memory, there's no garbage collectors, things like that? Well, I have a couple of reasons, and I'm going to lay them out. First and foremost, it's an object-oriented programming language. And if you think about video games as a whole, all video games are object-oriented games. Well, not all of them, but the vast majority that you play are just object games. Think about a game where you pick up a gun and now you're holding the gun and running around. Well, your player's an object, the gun is an object, and all of these things are objects. So the engine has to be able to handle objects and use them natively. And the best way to do that is to use a language that has objects built into it. And while everyone is going to be like, but C and C++ are so much better because they have that garbage collector, it's true. But you have to then write your own object system. And most times it's not as good as the pre-built ones, like the C# object language, which has been iterated and tested in we're at .NET 8 or 9 now. Like, it has so many versions of itself that it already has a lot of the optimizations that you would have to spend your time making instead of focusing on building your game. And that's important it's important that you can take the time to build what you want to build, rather than taking your time to write how an object works. But the other part of that is it's still C at its core. It's still a C-based language. A C-based language is a C-based language. C#, C++, C. They're all C languages. And that's important because there is still low-level memory management at every level of this. The difference is that C# implements a garbage collector, which is great. It's wonderful to see a garbage collector in a language, but it does slow you down. And obviously they talked about the GC time, which is the garbage collector time, which we'll talk a little bit about the garbage collector later. But we still have pointers. We still have references. We still have memory allocation and freeing. We can still do all of these things. It's just a little less necessary, but also a little more difficult to do in C#. But I will actually show a code example of using memory allocation and dynamic memory freeing a little bit later. There are enough libraries in C# that I could not find an actual number on the amount that exist. I did try. I looked around for about 2 days and I could not find a legitimate number. So the best number I could find was tens of thousands. Upwards of 50,000 was the best guesstimate I was able to find. And that's important because we talked about all of those rendering frameworks, OpenGL, Vulkan, DirectSDL, like all of these different things that have to exist. Well, there's already a library for it. You just have to import it with Nugget and you're done. Then you can just use it. And that's a lot easier than in languages like C++ and C#, where we have to really focus in on bringing in the header libraries, building the library, all of these things. We can focus our time on specifically writing our implementation for these libraries, just because we can import them. We also have testing frameworks like NUnit, or I don't think GTK Sharp has testing library anymore. NetEF is an entity framework library, which is super helpful for things like Unity, which has their dot system and the entity framework. Obviously, they don't use the NetEF package. They have their own, but the NetEF package is helpful if you want to build something that's a data-oriented structure approach. And finally, we'll go to GTK Sharp now, which is something like I'm GUI, which we can use to make tools and like a world editor or a properties manager, configuration editor, and things like that we can build with GTK Sharp. So there's very little we can't do with C# natively. And really, if you think there might be a library for it, odds are there is. At least someone's written one somewhere, even if it's not perfect. So with all of this behind C#, we have all the things going for the language itself. Now it's time to talk about the actual piece of tooling that we're going to use to program it all. And that's where Ryder comes in. And as you see in the title, it's game engines with C# and Ryder. And really, it is truly one of the best experiences I've ever had. I started with C# on Visual Studio, and it was great. But when I started using Ryder, I don't think I'll ever be able to go back, because it is just such a nice implementation of all the tools I need in one place. So let's talk about those tools, and let's talk about why Ryder should be your choice. And I'm not saying that because I'm sponsored or at a JetBrains event, but because I genuinely believe that if you use Ryder, you will appreciate it. And here's why. It's all one GUI. We're going to go over 2 more tools after Ryder itself, and they're all in the software when I install it. I don't have to install all these other tools on top of Visual Studio. It's right here. I install Ryder. It's available to me. And it's all, there's windows built for it. There's tabs built for it. It automatically starts some of these things when I run programs in it. Like, I have all of these options that are built directly into Ryder, and it's so helpful to just have them at my fingertips. There's plugins, frameworks, integrations. Like, if you've ever looked at the JetBrains marketplace, which if you haven't, I really recommend you do. There is such an army of free plugins that can do anything. And one of those plugins was actually brought up in the last talk. And it really was such a big and tricky thing to have all of these language servers and bits and pieces that you want, that it's just, it feels a little loose to spend your time writing a code server for a language that someone else has already written. So having these plugins that we can just install and then it works is excessively helpful. Now, it isn't just limited to C#, but I mean, that's what I'm going to be sitting here talking about is C#, but they also have all of the .NET suite. So MAUI, WinForm, WPF, like they have all of these options for things we can build. But other than just .NET, we have F#, which is the functional version of C#. I'm pretty sure. I've never used it, but I've heard it's fun. And C++ support. I think they have C support kind of loosely in there. Like, there's so many languages that this supports. And if it doesn't support it already, there's probably a plugin to support it for things like Ruby, or I think there's actually a Perl plugin, which is kind of cool. But there's all kinds of things that Ryder itself will support with just a little bit of editing. Of course, we also have our integrations with Nugget, Docker, databases, cloud providers, AWS, GCP, SQLite, MySQL, MariaDB, Postgres. Like, there's, I think it has Kubernetes support now too, which is a recent addition. But there's so much power in this that if I wanted to write game servers that I'll deploy on Docker, I can deploy them to Docker from inside Ryder itself. And it is so helpful to just have that right there. I can manage these containers from inside of Ryder, and it just makes your workflow so much smoother. I don't have to go open a Docker page. I don't have to go open different bits and pieces because it's all right there at your fingertips. Obviously, there's unit test management included to some extent. I really hope they expand on their unit test management a little bit more, because the implementation is still a little shaky when you're using frameworks like NewTest and things like that. But it is a very good and helpful thing to just have all your tests in one place. And finally, version control. Ryder has built-in support for so many version control systems like Perforce, which if you saw the roundtable today was pretty cool. GitHub, GitLab, all of these things it has integrations with to allow you to directly design your Git commits, your messages, your diffs, see pull requests from one place to another, make code reviews in Ryder itself. It is just so nice that all of these tools are in one place. But I'll stop rambling about Ryder. Let's go into the tools that Ryder has implemented for us to use. First and foremost is .trace. .trace is the profiler. And we saw it in the last talk, if you were here for that, with our previous Alex. .trace gives us so many tools underneath. We can see thread executions. We can see CPU usage and consumption by individual classes or threads. There's GPU render times and execution calls, which does require a plugin that I didn't provide because I didn't think about it. But there is a plugin that very specifically lets you trace GPU render times. You can see database query times. There's CI and CD support for .trace to let you profile your thing. And if it's outside of a certain bound, it can reject it in the CI. There's SDKs for you to integrate the profiling directly with your code. That way you get exactly the notes that you want. And then obviously there's lots of things that you can do with performance comparisons where you can take a snapshot from this run and a snapshot from this run. Let's say this one was my last stable branch and I want to compare the performance. I want to compare the performance between the last section and this section. And really it is so pretty to be able to see when your render time goes down. So having that comparison is very, very helpful. And our final tool that we're going to talk about is dot memory, and this is our main focus for the day. This measures our memory usage across the entire runtime application from top to bottom, including the debugger memory usage, which I just found out was added in the last version of Ryder, which is super neat. The important things is we can see the real-time consumption of your memory, and we'll actually look at that graph a little bit later. You can see snapshots of memory usage from one point to another. Even in the same debugging session, you can set up snapshots to watch them. You can do I/O analysis for the memory, watching allocation versus freeing IOPS as things go through, which is neat to see. But you can also see how it interacts with the file system. And I say memory leak detection. It's not going to flash in bright red if you hit a memory leak, but you are able to see where one thing starts to stack over and over and over and over to see which class may be compounding infinitely to cause that leak. And these tools, all built into Ryder, really let us do some truly incredible things with managing memory, optimizing systems. There are some truly beautiful things that we can do with this. So let's dive into the actual content that we're going to get into, including an example here in just a minute. So, memory management. One of the biggest things in game engine, game development, software development, like all these things, is to use as little memory as possible to do as much as you possibly can. And while bigger studios may not do this, you're just you, or maybe you're a small indie group of a couple of people. It's important to realize that managing your memory early is the best way to manage your memory later. So let's get into it. These are the important things for our focus. Memory in Ryder is never representative of the final built product. The only way to do that is to profile the product once you have built it and execute it from outside of Ryder, because there is some overhead that Ryder has and injects that causes the memory to be different. It may only be a tiny little bit, but that tiny little bit can matter. It is very helpful for debugging development builds. It's not very good at debugging a public build that you've striped everything together, obfuscated, and moved on. It's really hard to debug that in C# specifically, but with things like ILSpy, it can help. Now, memory leaks and overallocation is the bane of all programmers everywhere, and you'll see why here in just a moment. But it helps us to find where those leaks are coming from, like I talked about before. It's not going to flash up in red, but you can see all these classes adding more and more and more, and that's problematic. And then you can see where the memory allocation came from to an extent. You can see what class called it, but you can't see where that class was generated from, at least not in Ryder at this time. There are some ways to use ILSpy with memory snapshots to do it, but we aren't going to go into that today because that is extremely difficult. And finally, we can test across hundreds of breakpoints, hundreds of frames, and we can watch this memory in all of these places to see maybe when I click this input, it starts leaking. Well, there's where the overallocation came from. And that's the stuff that we're going to look at. So let's talk about runtime memory. Runtime memory is where that graph that I've been talking about so much comes in. And this is when we're going to start getting into practical examples. So first of all, the memory graph. It's a beautiful thing. It is a time-based memory usage graph from the start of your program running to its current moment in time. It shows where in the stages, which we'll talk about all the stages in just a second, the memory is allocated and why it is allocated there. And then finally, it shows where the core of your memory usage is. It's kind of neat. Finally, what are heap generations? We see them here. We have heap generations 0, 1, and 2. Obviously, unmanaged memory, total use, and LOH and POH we'll talk about in just a second. But the heap generations are important to understand because it's where the garbage collector goes to free memory. And if you understand where things are and where they're allocated, it can help you move things in those allocation layers to shorten garbage collector time. So generation 0 is the extremely short, very temporary, like it's going to be there for, I don't know, 4 or 5 seconds, and then they're going to cleanse it. Or maybe even less time than that. A lot of things like dynamic variables that are only going to be used once, like all of these individual pieces that may be a single function call or this, that, and the other are going to go into heap generation 0 when they're needed. And then the garbage collector goes there and removes it first because it's not needed anymore. So it's going to go away, which means that this one is generally where we see not the most amount of memory stored, but a large amount of it. Secondly is generation 1. Generation 1 is kind of the buffer between generation 2 and 0, where memory kind of sits in limbo. It's been here for a little bit, and it's going to need to be removed by the garbage collector soon, but we don't want to remove it yet. So it's going to wait in generation 1, and we'll go to generation 0 when it's time for it to be cleaned up, or the garbage collector gets to its generation 1 cleanup. And finally, generation 2 is the long-lived data, static data, like your static variables, an object that exists for the entire time, like your player object. I don't know what these pieces all are that may fit into this, but anything that's going to exist over the lifetime of the game will go into generation 2 because it just stays there. That only goes into generation 1 if it stops being used, and then it gets put into generation 0 and removed. And this only happens occasionally. Things that live in generation 2, there's very, very few things you'll see in generation 2. That's why in that graph right there, there's 0 megabytes in it. There's actually a couple hundred kilobytes, but there's no megabytes in it because it's so small that there's no need to put a lot of things in it, which is why we don't really focus on generation 2. Now let's talk about that LOH and those POH values. LOH, or the large object heap, is any object allocated over 85,000 bytes in raw size, which, by the way, is truly ridiculous if you allocate a single thing over 18 megabytes. But it does happen. I understand. So we're going to talk about it. The garbage collector does not compact the objects in the LOH at all. It stays in its raw form, which, as I listed here, it causes fragmentation, but it also heavily causes over-allocation. This is where the biggest of the over-allocation is going to come in, is in the LOH section. So that's one of the sections that you really want to watch for lots of memory. Logically, it's a part of the generation 2 heap, which means that it can be deallocated to generation 1 and 0 for cleansing, but it is logically going to show up in heap generation 2. Finally, we go down this list, is the POH, or the pinned object heap. The pinned object heap is the newest form of memory sections in .NET. It was added in .NET 5, and it's used to allocate anything that someone defines with the garbage collector to allocate. That's because it pins this memory. It keeps it here. We want to keep it and make sure it stays. POH is used to reduce the impact on the LOH because the LOH causes fragmentation, and on the 3 generational heaps. It also does compact the pinned object heap to a certain extent. It doesn't do complete compaction like it does in the heap generations, but it does compact it to some extent, which the LOH does not do. Logically, again, it's a part of generation 2, but it has a separate garbage collector budget, so it will not deallocate to generation 1 and 0. It'll be garbage collected by itself separately. Let's talk about why it's important, and then we'll get into the practical examples. Runtime memory is where the leaks show up. And I'm not going to go into it too much, but most programmers will understand why leaks are so dangerous. And if you've ever had a blue screen, then you probably understand why memory leaks aren't great. Runtime memory is dynamic. It scales over time, meaning that if you have something that lives for the lifetime of the application, then other things are just tacked on top of it over and over, especially if you keep adding things to that LOH heap. it stays there forever, which means that it can grow rapidly as the program expands. And then profiling a running game is incredibly difficult. So how do we profile a game? How do we profile a running game? How do we track down a leak, and can we prevent leaks? Ryder answers all three questions I just asked. And we've talked about how we can prevent leaks a little bit, but let's go into it a little bit further with probably my favorite tool in all of Ryder. Oh boy. The class system. So let's talk about what we're looking at really quickly. The first column shows the C# class name. I have specifically omitted one piece of it. I omitted the thing before localized string, and that's because it's a piece of the game engine that this came from. So that is all the class names. We see system.byteArray, we see system.string, we have my render GUIs for glyphs, we have packed glyphs, we have dictionaries, int32 arrays, object arrays, we have all these things. The size on the right is in bytes, which means that larger numbers are actually a lot smaller. But it is important to know that that size can fluctuate. So it is good to know that that size is in bytes. All this is doing is it's showing us the amount of memory that each class is using. So system.string is using approximately 1.7 megabytes at this point in time. It's using 1.7 million bytes, which is approximately 1.7 megabytes at this moment. And then byte is using 4.1 megabytes. So you can see where all of this comes in. And you can change the size. You can change it to kilobytes, megabytes, all these things. But I just find it easier to leave it in bytes for the things that are only taking up like 10 bytes. And the other thing is memory diffs. Memory diffs are huge, and it should sound exactly like get, because it is. It's a diff. It's the difference between one frame and the next. It is important to note that the diff is not the change in bytes. It is the change in the amount of objects. So you can see the count in the diff, which is why I put them next to each other here. The diff means that we have added 61 objects to that second count. So you can see where this quickly spirals out of control, but it also helps you see which ones are stacking. That's where we find these memory leaks. And it's super helpful to see all these things in advance instead of when you're in runtime and start crashing computers or crashing your applications because it runs out of memory or things like that. So now let's actually get into the fun things. How do we fix it? C# does a lot of it for you. C# has a built-in garbage collector, and it should catch a lot of the things that cause memory leaks, but it doesn't catch all of them because it's a managed garbage collector. Let's say you keep allocating things to the large object heap. Well, the garbage collector won't catch that. So if you're constantly allocating to the large object heap, it's going to be messed up, and there's really no way to stop it. So you have to be careful with what you allocate, even though C# helps you with it. But overusage is the thing we really can fix. Optimized programming helps. It lets us remove the variables that are causing these high memory allocations. On top of that, it also lets us compress our external data to better use our I/O resources. One of the biggest memory consumers is file operations. And we're going to talk about file operations in the file compression section here in just a couple of minutes. But it's good to know that if we compress our external data, we can reduce these I/O resources. And that optimized programming is something really important. So we're going to talk about optimized programming. Let's get into it. Optimized programming is important, and it's important to understand why we need to optimize our software before we implement it. So let's talk about classes and structures. So we're getting into real code now. Classes take up a ton of memory, like a ridiculous amount of memory. And that's because it has to have all of its functions, all of its properties, and then all the stuff for just the class itself and all the overhead for what it implements and what it has in it. And it's a lot. Classes just take up a lot of space. And they have a lot of scaffolding, especially in C#. In C# specifically, they have a lot of things built around it to make it easier. Now, the best upside to classes, which I list below, is they pass values by reference, which we're going to talk about in the next slide. So we're just kind of going to skim over that. Structs, we're going to talk about why structs are so important in a little bit, but structs are designed for data types. They're designed to handle collections of data variables, and they're designed to handle like 32 variables in one and compress to very small sizes. The issue is, though, is they aren't as modular. We can't add as defined interactions between structs, and it's really just, if the struct is just for data, it's not for writing functions around it, but we can work the two together. And it's important to talk about references so that we can link them together. And I like my title on this one specifically because references are amazing most of the time. They have some issues. And look, here's why. Passing a thing by value means that we can we can modify the value as much as we want, and it doesn't change the original variable. Passing things by reference means we're changing the original variable. And so it's a little bit problematic if we accidentally use a reference where we don't want to. So let's talk about the semantics of references, because I made some nice bullet points. They allow us to control exactly how we pass variables and values to functions, meaning we can pass them as the same memory address as what we passed the first one. Or we can not use a reference, and we can pass the actual thing that is stored in the value. Structs and references, meshing them together, reduces our runtime and allocation memory. And that's what I wanted to talk about. Classes pass things by reference. So if we pass a struct by reference to a function, then we're passing all of the values in that struct as a reference, meaning that we use less memory. And we're going to talk about references and why sometimes we want to modify a reference back to its original form in the next slide. But it is helpful to understand that references, you're modifying the data that you passed in the original function and in this one. Prior to refs, we had to use the unsafe variable, which, if you know anything about C#, the unsafe modifier and declaration is not something you ever want to use. So you had to use constructs, pointers, and raw memory management to pass things as reference, which really no one wants to do. So we're going to skip over that, but it is important to know that references are very important because we can start doing things like this in C#, which is kind of why I wanted to start building game engines in C#. Passing and returning references means that all the memory is in one place. Technically, you don't ever have to return a reference. If you modify the value and then just return out of the function, the value's modified in the main function that called it and in this function. So you would still want to return it, but you don't have to. And finally, references have a value-safe context, which means they don't escape a thread-safe instance. Specifically, they will not break out of a threaded reference. So if you have 5 threads open, you cannot pass a reference between 2 threads. So you have to pass it by value between the 2. But it also means that if you alter a reference in one, it will not change on the other, for the most part. There's some nuances with that come with thread safety, but we aren't digging into thread safety today. But references are crucial because of object pools. Object pools are what allow us to have a set. Let's say we have a set of 10 objects. We're going to write 10 new object variables. When we do this, we are only going to use these 10 objects. So if we have 10 objects displayed on the screen, there are these 10 objects in this array. Now let's say we want to change one of the objects. We're going to change all the values in the reference to the object in the array. And that's it. We aren't adding more memory. We aren't taking away any memory. It is the same exact object for the entire thing. All you have to do is just change the values of the object. But this is one of my only Unity comments. And they provide an object pool class by default, which is an incredible thing. And their object pool implementation is wonderful. If you would like to see it, go play with Unity and create an object pool class. It's worth it. Object pools cut down on the amount of allocation because we're only having 10 objects. And because we only have 10 objects, we can just pass them all by reference the whole time. Reducing allocation calls by just reusing the memory is faster for your CPU and your memory. So it optimizes the speed at which your game runs. And this is just kind of a warning. Use of object pools with references can be dangerous. If you accidentally overwrite an object that you don't want to overwrite, it's gone. There's no way to get it back. So you have to be very careful and make sure you're very meaningful with how you reference your objects and that you know what object in the object pool is at all times. Finally, there's a couple of small little optimizations we can do. Caching frequently accessed data, specifically out of the file system, can reduce IOPS calls, but it kind of messes up memory because now we're allocating memory to bring all of that file into memory. So if you implement caching for everything, it's not going to help you. That's not an optimization. But if you implement it for this one file that you call every 5 minutes, or even every 30 seconds, or every second or something, yeah, it's a very useful optimization because then you're reducing your IOPS times, and then that little bit of memory usage is worth it. The other thing's variable scope. Variables take up a varying amount of memory, varying. If they're global variables versus local variables, if they're functional variables, and that's because of where they're stored on the heap. Global variables are stored in generation 2 by default, and if they're static, they're stored in the large object heap. The other thing is that variables inside a function are stored in generation 0, meaning that they're cleaned up quickly, and they help clean up the amount of memory you use, which is always helpful. They also help reduce CPU time because you don't have to spend time jumping between lines. Like, I need to jump up and get this value and then use it here. So your CPU would have to jump back up the function, then jump back down and implement the value. And if the variables are as close to their calls as they can be, it makes it easier. So now let's look at a real-world example of some of these optimizations. In file compression. File compression is cool, really cool, but not zip files. Let's talk about why. We aren't talking about less space. We're talking about less files. IOPS are a huge thing when it comes to individual pieces of data. And I actually just had this in the example that we're going to look at here in just a minute. And that's because I had a single file for every creature in my game. And that was 193 files individually. I managed to compress this all into a single file, which means that I need one file operation to open that file. I don't need 193 operations to open every single file. And then I don't have to cache them, which makes it so much smaller. We also keep all our original data in a single place. We aren't compressing it. We aren't making the data smaller. All we're doing is compressing the amount of files it is. But here's where the question shows up. How do we know what file is what? And we'll talk about that here in just a minute. Checksums are super helpful, and I'm going to cover that in my example. But now let's ask, how does it help? And I preface that because it's less I/O stress, which we've talked about I/O stress this entire time, and I/O stress is a huge thing. So here's why. The biggest memory consumption comes out of accessing a file on your file system. That's because it comes out of what would be an SSD or a hard drive or an M.2 drive or any of these things that are physical storage, and it loads it into memory for accessing, which means that your program is now using the memory size of that file, which obviously causes issues, which also means, why are we compressing it all into one file? Aren't the smaller files better? Well, no, because if the file name is really long, let's say it's in assets, creatures name, data files, file.bin. Let's say that's the list. It takes a really long time to execute because it has to tree through all of those individual chunks of folders is what we see them, but all those individual chunks of memory storage, it has to go through each piece to find it. And it has to do that every single time because we don't have something like the CD command. And it looks cleaner. Yeah, that one's just kind of funny. It looks nice. It's good for readability. Yeah, I really don't have much there. I just thought I'd throw it in because it looks pretty. And then it's also harder for others to modify the raw file itself. And if you're focusing on a game that may have people cheating it, this is important, but it's really not the biggest, most important thing that you could do. Encryption stuff is better for that. So let's talk about that 100 files problem, but a little bit smaller. How do we convert 20 files into a single file? Obviously, we have something like zip files, which just put them all in one, but it also compresses the data. It's a lot harder for us to read this out on a single operation call because we have to load it, we have to unzip it, and we have to do all of these operations on it. Instead, here's what I did. And this is where we're going to start getting into code. I'm obviously not going to open Ryder, but we're going to get into the code itself. My approach was split into 3 pieces. We have the file header, the checksum, and the file header with a checksum. Now, the reason that I split the file header and the file header with the checksum is because I didn't want to checksum every single individual file because that adds a lot of data to the file. Even if it's only 256, SHA-256 is in bits or bytes, I don't remember. But even if it's only adding a tiny little bit for 193 files, it's a lot. So let's talk about this first image of code right here. First of all, we're making a byte array because we're going to write this directly to a byte file or a bin file. And all we're going to take is a string to the path of the input file. The goal here is we're going to return the file header without altering any data at all. We don't want to alter the file itself. So we're going to take the file info, which is a class in .NET, which gives us tons of helpful information about the file itself, loading the path to the file. Secondly, we're going to take a struct that I made called the file header, which I think I have a screenshot of later, but it's basically just the file size and the file name. The file size is an integer of the length of the file. And I have this right here. The integer cast is extremely dangerous, and I'll talk a little bit about why later. And then we have the file name, which is just the name of the file itself. We're going to convert the header to bytes, which I had to write a function to do, and we're going to talk about that in a little bit. And then we're going to return the bytes itself. That's it. That's how we build the file, or at least the header, is it's just a struct, which we talked about structs a little bit earlier. That's all this is. It's just a struct of bytes. So let's talk about checksums now. Checksums are going to help validate the data in the file itself. If the file bytes don't match the checksum, something is wrong and you should rebuild the file or re-download it. This helps prevent cheating. The checksum I did off the file stream. There's a million ways to make a checksum. This is how I did it. Oh, look, I wrote it in. SHA-256 is built into .NET, which is extremely helpful for us because that's what we're using for our checksum. It's 256 bits of data, generally used for password hashing, and it will come out the same if the file is unmodified. So if you throw the data in, it will come out the same every single time. That's why checksums are so helpful. So we're going to make a file stream from the file path. We're going to open it and read it. We don't need the ability to write to it, so let's only open it to read because it uses less memory. Then we're going to create a SHA-256 method, or we're basically allocating the memory for a SHA-256 string here. We're going to take a byte array, which is our hash bytes, and we're going to compute the hash of the file stream into our SHA-256 variable. So using this converter, we're going to compute the hash of this file stream, which returns a byte array of the actual checksum bytes. We're going to take a bit converter, convert it to a string, replace all the dashes, because it does use dashes, with just nothing, because we don't want the dashes in there. They take up a lot of memory, dashes specifically, and they're just harder to read. So there's no point in including them. And then we're going to do it in a to lowercase method, which you don't have to do, but I choose to do all my checksums in lowercase so that we don't have the uppercase. As a note, SHA-256 generates them in all uppercase. It does not generate a uppercase and lowercase character in the same string. They're either all uppercase or all lowercase, and I just want to lowercase them because it looks better to me. Finally, the second file header. The second file header is the one with the checksum. So you can tell it has a file header CS, which is checksum, instead of no CS. It's the same implementation up here and below. The only difference is we're adding header.checksum equals that calculate checksum function, and we send the full path of the file. Let's talk about this cast right here. Why is it a bad thing? The file length is a long because the actual amount of bytes in a file can be long enough to overload an integer value. Because of that, we have this simple cast right here to convert to an integer. But that's dangerous because if it's greater than the size of an integer, it will fail. You should implement this with a long, but I didn't want to write a way to convert the long over. Yeah, SQLite databases can be up to 3 terabytes. Yeah, with that size difference, it's dangerous. And so you really want that to have the space to grow. So I would re-implement this with a long if I was building for production, but I just wrote this as a quick example. Finally, let's talk about the full compression. Now that we actually have the code to generate, and I know this is really small, I apologize. We're just going to take the output stream, which is the file that we're writing to. Obviously, I have hidden a lot of information in this, unfortunately, but it is some code that I didn't want to show, mostly just string names. But we're writing the file header, which is building this header right here, and then it's going to write it out to that stream. And I'm going to show the actual code for how we take the 2 bytes in the next slide. But the important thing to note is we're just going to iterate over every file we want to compress into a single file, and we're going to write it with that header, including the checksum, into a single file. Then if we want to look and find a single file, all we have to do is look for that file's header in the very large file. And finally, we're going to talk just a little bit of memory because we have to talk things back a little bit, and that's how the 2 bytes function work. I talked a little bit about how C# has the ability to allocate things, and I also talked about pointers. That's what I did here. What I did is I wrote an allocation script to individually allocate the data. That way I can convert something into its bytes. May not make sense, but I promise it is a beautiful thing. And this code is very succinct and very quick because I have optimized the crap out of it, basically. The important part to note here is that I'm allocating H global, which means I'm allocating to the large object heap. It's kind of dumb because I'm just going to get rid of it. But because I have this free H global here and I'm freeing it myself, it's easier to allocate it to a heap that I can see faster than one that I can't. So all we're going to do here is we're going to take the size of the struct, which is the size of it in bytes. We're going to create an array of the size, which is the amount of bytes that it's going to be. We're going to create a pointer, which is just a memory address of the size that we need. We're going to convert the structure from the file header CS into a pointer, which we're going to convert it in its data into this pointer here. We're not going to delete the previous struct. That causes a lot of issues, so be careful with that. And then we're just going to copy the pointer data, the data from the pointer to the array from the first value, and its length is the length of the struct. Then we're just going to free the data and return the array. And that is how we convert it to bytes. And a lot of methods have a 2 bytes value into it, but this is easy to do. So all we're doing here is creating an array, putting the structure into it, and then returning the array itself. And that's all we're doing. And this is important to note because of this allocate and free. This means that we can control our memory with a fine-tooth comb if we choose. And because of that, we have the opportunity to have very fine-tooth control over memory if we want it, but we don't always have to. And this is just one such case where having that individual, like byte by byte memory control is helpful. And this is just some code to show you how to do it. The Marshall class is what comes with .NET. It is how you do all of the individual memory-based allocation and freeing systems. So if you're ever curious, feel free to go take a look at that. Now let's wrap everything up. I only have about 4 more minutes, so let's do this wrap up quickly because I wrote it to have about 7 minutes to wrap up. So let's do it quick. C# and Ryder. C# is very powerful. Thousands of libraries. Any application you can dream of, including game engines. And there's so much that C# has that if you leverage it all, it can be incredibly versatile and very helpful to how you do things. Ryder makes all of it easier. With all of its tools, Ryder gives you insights that you can't get anywhere else. It has those memory tools with .memory. It has the ability to look at render times with .trace. And you can look at all these things in C# that you really can't get at the degree that JetBrains has made anywhere else. Memory is important. There are tons of different memory types to keep up with. There's all of those heaps. There's the LOH, the POH, and there's so many different pieces of memory that you have to keep up with that it's hard to remember what you're using and what you aren't. Because of that, don't always try to remember every piece of memory that you use, but try to keep the amount of variables that you use to a minimum. Try to keep your footprint low. The lower you keep it, the better it's going to be. And finally, optimize your structures. Data structures can speed up everything. It reduces the memory consumption like we saw with the structs. You don't have to call your CPU like to jump all over the place. And you can optimize your data as small as possible to reduce your memory as easy as possible. And a final note from me, just keep trying. Coding is never mastered in a night. This example that I showed just earlier took me over 2 years of development to get to. Optimizing that single 2 bytes function, I think I wrote the 2 bytes function in 2023. It's been around for a very long time, and I've optimized it all the way to where it is now. It used to be a much longer function, but now it's so small because of that time. And you're never going to get all the nuances. You're never going to know each individual piece of how to code something, but that doesn't matter. All you need to know is that every time that you program something, you learn from it. And as you keep learning, you get better. Don't expect perfection, ever. This game engine and that optimization function, or that 2 bytes function that I optimized, still isn't perfect. I'm certain of it. I'm sure there are better ways I can improve it. But you often learn better when things aren't perfect. You learn better when you don't succeed for everything. And because of that, set yourself up to succeed but don't be upset when you fail, because when you fail, you learn. And when you learn, you get better at programming. And with that, thank you all for coming into this talk. I'm pretty sure we have a Q&A section afterwards, which I think our lovely hosts will pop in for here in a moment. But thank you all for coming and hanging out with me.
So, Alex, I have your suitcase of cash. No, I'm just joking here. Actually,
Right.
our Alex has a really good question, so I'm gonna defer to him.
Yeah, this session was a trip, and one thing I wanted to ask really hard, if like the writer is really great, you made a lot of great points, but the question is it possible to make it even better? Like maybe you have a suggestion or something? Maybe you're missing something?
Ooh, for Ryder? Yeah, actually,
Yeah.
I have a couple of things. It's just for me using it a lot, so don't take it to heart. But my biggest thing is unit testing. Still, it's really hard to look at the unit tests for when we get into that memory optimization. If I'm writing unit tests to test assertions against the amount of memory that is allocated against a single size, I'd like to be able to integrate dot memory with that better. And dot trace and dot memory don't have a good integration together for me to be able to use that profiler to read out byte sizes. So being able to assert that in my unit test is almost impossible. You can kind of cheat to get to it, but it would be nicer if dot trace and dot memory had an integration where I could pull the byte size of a single class and then read it through like that and be able to use it in my assertions when I do unit testing, which Ryder obviously is built in. But having all of those linked together a little bit better so that I can assert memory sizes or assert CPU call times or GPU render threads so that I can test it. And I'm like, in my CI section, I can look through and go, that takes a lot longer than I want it to. Let's pull it back. Let's not publish it and let's take a look so I can see if I can reduce it any further. If I can't, I just increase the bounds of my unit test, but it'd be nicer to have that control.
I have an answer for you, sir. We actually have a NuGet package. I think it's called there's dot memory unit, which lets you write like memory unit tests, and it uses dot memory. So that's kind of cool. But we also have a NuGet package that lets you actually execute dot trace and dot memory stuff. So check that out. Go to NuGet.org and just type JetBrains, and you'll see a bunch of packages there that you can actually use.
Y'all gotta advertise those packages better.
Yeah, we do honestly. Yeah, we could do a better job.
That would be huge for even just Unity.
Yeah,
I promise, folks, this wasn't scripted.
You can do that. You can also ship a lot of that code with your applications, so you can programmatically run things like dot trace and dot memory. So if there's a particular scenario you need profiling for, but you don't want to sit there and like stop it, you can actually program a lot of that stuff. So check that out. It's pretty cool. And yeah, let us know how you like that kind of stuff.
I'm gonna go dig into that. That sounds cool.
Yeah. Any other questions Alex? Now I have to, there's too many Alex on the screen. We should just rename it Alex Conf. I think it'll just be easier. Go ahead, Alex. Do you have any other questions?
Yeah, I have just one. The thing is with the one big file to accommodate for all the resources bundle in one really strikes to me as a database, basically, when you just shove all the resources in a file. Were you thinking maybe to use some of the existing solutions inside of rolling your custom one?
There's a lot of good already built solutions for what I went over today. And a lot of them have a lot of build frameworks that do that file compression into one. But my biggest issue, I run into them, and I saw, I don't know which one. One of you made a comment in the stream chat about SQLite. SQLite would be really good for rolling all this data into, except for the fact that it compresses it. And in my instance specifically, I needed to avoid data compression because data compression would cause a couple of the variables to flip because I was getting real close to some integer limits, and it could flip bits at the end of it when it compresses, which I found out the hard way. and I would be getting some really garbled data in it. And because of that, for the most part, using SQLite or using a database or using really just zipping it all together for really is probably the best way to do it for most people. My custom solution looks into uncompressed file merging is really the big thing that it's a part of. And the entire purpose of it was to reduce IOPS instead of reducing file size. And because I wanted to reduce IOPS, but keep the memory as raw as possible and keep the data as raw as possible, it was better for me to focus more on that piece of how do I merge them into one file instead of how do I compress them together. And that's where the difference is. These custom solutions are really good for merging them all together and then compressing it, whereas mine's a lot better at just merging them together if you don't want that compression step to ever run.
All right.
Yeah, you said you call this IO stress, right? Given the state of like the games that you work on and the platforms that you're deploying them to, do you still feel like memory pressure is kind of like the biggest bang for your buck? Or are there limitations with CPU or GPU resources that are also potentially big problem areas?
Yeah, that's a really good question. I like that one. We're going to talk specifically about consoles and mobile here because, to be honest, with PC, the only time you're going to run into GPU and CPU bottlenecks is backwards compatibility with older systems. Memory has become not cheap, but it's more commonplace to have 32 and 64 gigabytes of memory in those higher gaming rigs, that focusing on optimizing your assets when you get to those really high res assets isn't necessary. Obviously, in AAA games and a lot of the games I still work on, you have a low res version and a high res version, and it downloads the version that it wants. Like from the Steam thing, I can upload a high res version of the game and a low res version of the game, and I can have it download whichever one I want based on the specs of the computer. And because of that, I don't have to focus on optimizing the high-res assets as much as I used to. The difference comes with consoles and mobile applications. With mobile applications, we're hitting a serious CPU bottleneck. I know Snapdragon just announced their newest processor that's meant to break out of this a little bit, but mobile applications are heavily CPU bottlenecked to this day. I mean, I have 16 gigabytes of memory in my phone, but I hit CPU bottlenecks before I get anywhere near those 16 gigabytes of memory. And I hit GPU bottlenecks in the mobile applications all the time, but that's because it's using integrated graphics. So graphics on mobile are their own beast, but console is where things get kind of interesting. Let's look at the Xbox Series X, because this is my favorite one to compare to a literal physical PC. It is basically a PC that they hand you at a cheaper price. Bone to pick with Xbox later. The GPU is never the bottleneck on the Xbox. I've never run into throttling on the GPU. And I've built some like almost Cypher for the Xbox, and I cannot peak that GPU. The CPU, I start to hit pretty heavy. I'll get up into the 80s and 90% on utilization across all cores, but I hit the memory so fast, it's terrifying. Like, they only put 16 gigabytes of memory in some of these systems, and the PS4 only had 8. Like, the early versions of the PS4 had 8 gigabytes of memory, and I run into that really fast. And now that we're having to play the backwards compatibility game with Xbox Series S and X and PlayStation 4 and 5, it gets really difficult when you're building for consoles because we start to hit that pin limit really fast.
Yeah, I saw that PS4 is still like heavily used as like current gen consoles. So
we're still encouraged to build for it on current gen. Absolutely.
Wow. So
I think folks were just too spoiled. Some of the older games can fit in my CPU caches.
I know, it's great. I can run Doom on my webcam. Like,
Hey, I want my PS6. Okay, where is it already? No, I'm just joking. So
32 gigs, please.
Hey, I'm a gamer, not a game developer. So it sounds like a you problem, not a me problem.
It is a me problem. One I run into a lot. Thank you.
Oh, that's good. Well, I think that's a really good place to kind of stop here. So, Alex, really awesome talk. I enjoyed it. I like seeing the code, the cache, the suitcase of cash is headed your way. Thanks for all the kind words for Ryder.
Awesome.
Yeah, on that note, have a great day. And
thank you so much.
Yep. Bye.
Okay.
Bye.
See ya.
All right, Alex.
Yeah. To say bye to Alex. And this time it's for you to introduce our next guest because we are all out of Alex today.
Yeah, we're out of the Alex streak. So our next guest ends that streak. You may know him as Turbo Makes Games. Johnny Thompson is really the the dots expert. Whenever I go to YouTube, he's all I see. It's kind of wild. So without further ado, let's introduce Johnny. Hey Johnny, how you doing?
I'm great. How are you guys doing?
Doing pretty good.
Awesome.
Yeah. I mean, we exposed Alex to a little bit of C#, even though he wouldn't touch it with a 6-foot pole, as he would say. I got exposed to C++, so that's, fair game, I guess.
Just awesome.
So yeah, I'm excited about this talk because dots is really a hot topic, and I think you're kind of, for me, the de facto expert on the topic. So let's give you the stage. Folks, if you have any questions, be sure to ask them in chat. Alex and I will be watching, and we'll ask Johnny those questions after his presentation. So good luck. Yep. Bye.
Awesome. Thank you guys so much. All right. Hello, everybody, and welcome to my talk today. It's going to be called Why Dots is Unity's Silver Bullet. So anyways, just a real quick introduction into myself. So my name is Johnny Thompson, and I'm a fully independent Unity developer. So I do a lot of, contracting and consulting type work. So, while that I talk about Unity a lot, no, I don't work for Unity. I am, fully independent and all that. And yeah, like, many people may know me from my Turbo Makes Games YouTube channel, where I do a lot of dots related stuff. So I'll put up a lot of tutorials on there, as well as showcase videos where I just, make cool things with Unity dots and kind of, share them all with the community. And then more recently, within basically this year, we started doing a live stream with a couple friends of mine. It's called the Hot Path Show, and we do it every Friday. And we talk about basically solving problems in game development using data-oriented design. Now, because the three co-hosts for that show, we all are very familiar with Unity and Unity dots and all that. That's, a lot of the topics that we talk about on that show. However, we have started to kind of like get into, other kind of like data-oriented programming languages and talking about how they can be used for game development as well. So anyways, I'm just going to give a real quick introduction to this talk. Again, it's called Why Dots is Unity's Silver Bullet. So in this talk, I'm just going to be going over, kind of like what is dots, the importance of dots, why I think it's really cool and all that. And then later we're going to be talking a little bit about the future of Unity dots, because Unity has recently kind of announced that they're kind of, having this like kind of ECS for all initiative, where ECS is going to be kind of like the backbone of a lot of parts of the game engine. There's a lot of really exciting stuff with that. So yeah, I think this is going to be a fun talk and ready to get into it. So first off, we'll start off with what is data-oriented design. And I'm just going to be doing kind of like a high-level overview about, what is data-oriented design and introduction to ECS and all that. But if you do want a little bit more of an in-depth introduction to data-oriented design, actually last year at the JetBrains GameDev Day, I did a talk, and you can actually scan the QR code right here to see the YouTube replay of that talk, where it was just a little bit more in-depth introduction into, the concepts of data-oriented design. And, it's just kind of giving like an introduction into, what writing ECS code looks like and all that. So it is just a good kind of introduction if you do want a little bit more information on data-oriented design. So real quick, just at a very high level, data-oriented design, the way that I kind of typically define this is by saying, data-oriented design is when you're making architectural decisions in your application based on how the computer will best store and process this application data. And so it's really important to know that, the solutions are specific to your problem. So, each problem that you come across in your game, you really want to kind of, analyze that and determine, what is going to be the best solution. A lot of times it is going to be, how can I make this run the most efficiently, structuring my data and processing and everything like that. But then, other times it might be, okay, maybe this doesn't need to be as efficient, but I can make it, more convenient for me in some other ways. So it really is just kind of like, looking at every problem as individual things and not like, using a turnkey solution for everything, but, just really kind of testing things out, getting good metrics, and, solving the specific problems that are right in front of you. So a couple ways that you can kind of approach this data-oriented design is structuring your data to avoid cache misses. So a lot of times in object-oriented programming, as we have, all these different objects that, maybe inherit from different classes or, reference different objects and everything like this, we're going to end up going to have a bunch of objects kind of, scattered out through our memory. And, it just ends up being quite inefficient as we try to, access a bunch of these different things. We're constantly having to go to different places in memory, and most often that memory is unfortunately not going to be stored within the CPU cache. So we're going to have to, go out to main memory, which can be a lot slower to access, as opposed to something like data-oriented design. We might want to structure our data in a way where data that we're going to be accessing very frequently, together, is going to be stored contiguously in memory so that, as we're accessing things, it's more likely to be within the CPU cache, which just leads to really fast and efficient processing of that. Another thing with data-oriented design is we're kind of wanting to, avoid these complex inheritance structures. There's a couple of reasons for that. One is just kind of, like I said, the memory layout of all, if we have all these, different objects that inherit from other objects and having subclasses and everything like that. And, all along the way from all these different classes, we're getting, different properties and methods, again, as we're kind of like, accessing those different things just in that one class, again, we're going to be having to bounce around, a bunch of different places in memory. And then, personally, from kind of like a readability standpoint, I just don't prefer having these inheritance structures where, we might have to be jumping around a bunch of different class files to follow kind of, like one logical path of something. It just, I don't like that structure. I'm going to be showing kind of like, some other ways in data-oriented design that, I kind of prefer structurally. So now we can kind of move towards some more Unity specific topics. So what is DOTS? So DOTS is a Unity concept. It basically stands for their data oriented technology stack. So DOTS is an acronym. And it really is just a collection of Unity packages that are built off of these principles of data oriented design. So some of the main packages that you'll come across are the entities package, also known as ECS. This is kind of the core, I'd say, most important package when it comes to Unity DOTS. And basically, this is kind of the entity component system. We're going to be going into a little bit of detail on what this is in just a second here. But really, it is kind of the core structure of how you typically want to structure a DOTS application within Unity. Now, I should mention that all these packages are pretty much interchangeable. So if you're, quote, using DOTS, you don't necessarily have to be using Unity ECS. You could use some of the other features that I'm going to be mentioning in just a moment here. However, they all are kind of intended to work together. And when you're using all of them, they work together really nicely. And you're able to kind of, take advantages of all the different packages, when you're using the most amount of them. Another really important package is the jobs package, also known as the C# job system. And this essentially enables multi-threading within Unity. Now, typically when you create a Unity application, most of your game code is just going to be running on the main thread. And this ends up, being a little bit of a problem when you're starting to do, more complex logic. We have maybe more dynamic entities, or maybe they're doing really heavy calculations and all this. And that's going to end up kind of really just taking up a lot of resources on the main thread. And now your main thread is like, kind of having to wait for some of that work to complete before proceeding. With the C# job system, we're able to actually schedule some of that work onto some of the worker threads on our machine, because nowadays we have PCs and consoles that have many threads and cores available to us. So it's like, why not take advantage of that and be able to kind of offload some of that work onto some of the other threads. Another very important one is the burst compiler. Now, the burst compiler basically takes all this high-level C# code that we write and compiles it down into really fast and efficient assembly code. It does a lot of really nice optimizations as far as SIMD, or single instruction multiple data, which basically means maybe we have multiple bits of data, and we can kind of pack those all into just one single instruction call to process those, which just ends up being really fast and efficient. And the burst compiler is actually pretty easy to use, especially again if we're using the entity component system and job system. These other packages kind of have some restrictions that we need to follow, and same thing with the burst compiler. And as long as we're kind of following those restrictions, it's pretty easy to just enable the burst compiler, and we pretty much instantly get at least 10x performance boost from the burst compiler. So it's really amazing stuff. There are some other dots packages that I do want to mention. So there is a physics package, again, all based off of data-oriented design principles. And also there is a version of the Havoc physics package that is kind of built off of dots as well, that is available. There is an entities graphics package, and that's kind of used for rendering entities within the ECS world. There are a couple limitations of this right now, unfortunately, but they are kind of working towards getting it to full feature parity with just regular Unity rendering technology. There is a mathematics library that is compatible with the burst compiler. So a lot of these math functions are just basic things that you would find in like the mathf library as well. However, they just work a lot better with the burst compiler and can compile down to really fast and efficient machine code. There also is netcode for entities, and Unity seems to really be pushing this netcode for entities as a way to have kind of more ambitious and competitive type games built in Unity, because these data-oriented principles again are kind of geared towards fast and efficient gameplay. And so, it has a lot of benefits for, doing competitive multiplayer games, and there's, netcode rollback and different prediction algorithms and things like that. So it just really leads to a better player experience for competitive type games. And actually on my YouTube channel, I did create a big netcode for entities tutorial, just kind of walking you through creating a full game with netcode for entities. Again, yeah, it's just available on my YouTube channel. So dots right now, it is still fairly separate from Unity game objects and mono behaviors, but they are kind of working to close that gap a little bit. So there are, some tools that we have available to us, like manage data components, or this new thing called Unity Object Ref, that basically allows us to, reference game object and mono behaviors from the ECS side. However, it can be still a little bit cumbersome to work with, which is a little bit unfortunate. However, in the future, Unity has stated that they're kind of having this whole entities for all initiative, and they're kind of unifying the transform system so that game objects and entities will both kind of run off of this same unified transform system. And I'm going to be showing a little bit of that, kind of towards the end of the presentation here. But, it is really exciting that Unity is kind of working towards getting it kind of a little bit more integrated in the engine, because right now it still feels like something that's a little bit separate. Whereas, when we kind of want to interact with some of the existing Unity features, it's definitely doable, but sometimes it's just not necessarily the cleanest way. So here we can talk a little bit more about ECS. So ECS itself is just kind of a concept that's actually been around for decades, and Unity kind of has this entities package, which is essentially an entity component system, or ECS. So when we talk about the entity component system, well, it's actually a separation of three different things. So we have entities, components, and systems. So the first one that we want to talk about is an entity. So an entity is really just a thing within our game. So this could be, a player character, this could be a vehicle, or this could be something, a little bit more, it doesn't necessarily have to be something that's rendered in the world. This could be, some kind of more high level game logic. Now this is a little bit misleading because, really an entity, it's not actually anything. All an entity really is an index. Now this is kind of like an oversimplification of how it actually works. But basically we can think of, when we start having like all these data components, just data associated with these different entities, these are going to be just stored in like big arrays of data. And this entity is really just an index into those different arrays. Now, because the way that things are structured, they're kind of going to be structured in parallel arrays. So basically, if we key into any array at a specific index, we know that that data is all going to be associated with one single entity. So again, an entity, it really isn't anything, but it's just kind of like an index saying, hey, this index and all these different arrays, let's kind of like, associate that together to be, one kind of thing within our game. Now, when we talk about data, again, we're talking about data-oriented design. So data is really kind of like at the center of all this. So, we have these things called components, which is the second part of ECS. And this is actually where we store all of our data. So in this case, we have this thing called an iComponent data interface. And, that's basically what Unity ECS says, hey, this struct is, a data component that we can use within ECS. And you can see that these components are really just containers for data here. We're not doing any, there's no methods or functionality. This is just kind of the raw data. Again, these are the things that are going to be stored in those arrays that we key into, when we say want to associate something with a specific entity. Now, for example, in this case, we have, say, some like enemy attack properties. Now we can think of this as maybe some data that's not going to change throughout the life cycle of our application, where we kind of have, a number of hit points where, how strong the attack is going to be. And we also have a cooldown of, how long the enemy has to wait between the different attacks. And then maybe we also have, say, a separate data component, and this can be some kind of like value that changes. So for example, we have this enemy attack cooldown timer. So, anytime that an enemy attacks, maybe we can reset this value to this cooldown timer value here. And then we can kind of have some systems that actually, decrement that attack timer so the enemy knows when they can attack again. So kind of speaking of systems, we can kind of move into the last portion of this, which is the systems. And this is actually what operates on that data. Now, these systems are really cool because basically we can just say, find me anything with these, specific sets of components, and let's go ahead and just operate on that data. So you can see in this case, we just have a little bit of a character move system where we do this thing called an entity query, where we can basically just say, again, find me every entity with this specific makeup of components. So in this case, we have a local transform, a character move direction, and a character move speed. And then you can see on this line here, we're basically just, applying that transformation, just a pretty basic transformation here. So again, these systems kind of, work on these groups of data. And there's kind of some really good efficiency gains, which we'll be talking about in just a second here. But for a second, I do just kind of want to talk about composition over inheritance, because this is kind of like, one of the core concepts of ECS. So, for example, if we're looking at inheritance from, say, like an object-oriented programming perspective, we can say like, oh, okay, we have this, Toyota Camry within our game. Now this Camry, it might inherit from a sedan class, and that sedan class inherits from a car class, and that inherits from some vehicle class, and that all inherits from object. And again, we kind of have this whole, big inheritance structure where we have, all these, different things. And again, along the way, we kind of are like, getting all the different properties of, sedan and car and vehicle and everything like that. And so, again, we're kind of like, getting access to data and functionality as we kind of like inherit from all these different classes. Now, to contrast that with data-oriented design, we do kind of more of a composition model, where instead of saying, inheriting from, all these different types of objects, let's go ahead and say, we'll just create something, and this thing has a motor, this thing has wheels, this thing has, some amount of doors, this thing has some amount of seats. And we're just kind of like, adding these, essentially data components to this one thing. And then basically from that, we kind of end up getting the same functionality result. We're kind of, building up to the same car, but the way that we get there is a little bit different. And, kind of one of the advantages of that is now we can say, we don't really care that something is a car. We don't have to specifically define anything in our code that says, oh, hey, this is, a Toyota Camry, or, this is a car. We're really just kind of, adding these little building blocks to this entity. And then from that, we can again use these systems to run that processing logic across that data. So yeah, real quickly, I do just kind of want to talk about, entity querying and kind of, go into this a little bit more. So, for example, we can say that we have some amount of entities within our game. So we have, say, an entity with a transform component, a move speed, hit points, and player inputs. Well, in this case, this is going to be, say, a player entity. We can also have something very similar that has, the same first three components, transform, move speed, and hit points. But in this case, this has an enemy AI component as well. Now, for this, maybe we have, some amount of entities within enemies within our game. And then, finally, we have something that's a little bit more basic that just has transform and hit points. And these can be kind of, environment elements within our game. So maybe we have some rocks and trees and walls. And again, we're never specifically defining anything that says, this is a rock, this is a tree, this is a wall. We're just kind of, adding the necessary components to get that functionality within our game. And then, from that, we can kind of get these essentially different behaviors here. So let's talk a little bit about, doing some entity queries on these operations. So, basically we can say, let's find everything with a transform and a move speed component. Well, in that case, that's going to return all of our players and all of our enemies, because all of those both have those transform and move speed components. And it's going to be ignoring all of our environment elements because those don't need to move. So maybe if we're, want to do some logic to, move everything within our game during, one particular update step, we can kind of look for all those and apply those transformations. Now, let's say we get everything that have hit points. Now, in this case, everything has hit points. So, maybe we want to, kind of apply some damage to everything within our game. We could do that this way. Or maybe if, say, the player wants to, damage other things, then we can say, let's ignore anything that has this player input component. So, we can say, get all these enemies and trees and everything like this. So it ends up being really nice to, be able to query different groups of things very quickly and efficiently. Another thing that I do just want to kind of bring up real quick is getting into kind of some of the memory layout aspects of it. So in Unity ECS, they kind of have this concept of chunks. Now, a chunk is basically just a 16 kilobyte block of memory that kind of, pre-allocates all this data for us when we, so for example, if we say, spawn our first enemy, in this case, the first time that we spawn an enemy, the computer is going to basically set aside one of these 16 kilobyte blocks of memory called an entity chunk. And it's basically going to, set aside data for enough entities to fit within that 16 kilobyte block of memory. So even though we're instantiating just one, it's still going to allocate that whole 16 kilobyte block of memory. Now, when we want to add more enemies to our system, that memory is already, pre-allocated for us. So we don't have to allocate new memory. All we're really doing is just setting the data on this. So for example, we spawn 3 enemies. We can just go ahead and set these specific data for, the transform, move speed, hit points, AI, and all that. And then we still have room later on when we want to spawn more enemies that, all this data is kind of blocked off already for them. And then, basically, we're just setting the data values on those. And again, you can kind of see like what I was talking about a little earlier when I'm saying that an entity is really just an index. So we can think of all these different data components as like a linear array. So this is the transform array, and this is the move speed array. And then when we have these different enemy entities, again, we're really just indexing into those arrays at that specific point to get that data for that specific entity. So it ends up being quite fast and efficient to again operate on groups of this data, as well as just find that data in general. So I know we're kind of getting a little bit into the weeds here, but let me just take a step back and we can just talk a little bit about who should actually use Unity ECS, or even just ECS in general. So there's two kind of broad categories that I'd like to talk about. So one are performance critical applications, and the other is games with dynamic architecture. So going into some performance critical applications, a lot of times we see this for games with large numbers of dynamic entities. So for example, we have, say, real-time strategy type games where, maybe we have lots of these dynamic units who are all, needing to do some complex pathfinding logic, and they're going to, need to navigate around all these environment elements and do some targeting to, find enemies within a range. And then, all these, enemies from different groups, they can battle each other. So there ends up being a lot of stuff going on. And, we can kind of use some of the advantages of ECS to, process all these dynamic entities. Another example of a game like this would be something like, management games, tycoon games, city builders, things like this, where, maybe we have a lot of people, and these people all kind of have their own, different goals and desires and things that they do within the world. And then we also have, maybe buildings or roller coasters or things like this that, kind of have some of their own properties, and maybe they're kind of, occasionally doing logic to, for like certain events to happen, or, in the case of Roller Coaster Tycoon, where, having all these, roller coasters go around and everything like that. So there ends up being, again, a lot of dynamic entities, a lot of kind of, simulation logic happening within the background. So this is something that would be a really good candidate for Unity ECS. And then also, I think an interesting example are like some puzzle games. So there was this game that came out last year called Humanity, where you basically are controlling this like giant crowd, and you're kind of like directing them through these puzzles. And it actually is a super interesting game. I would recommend checking it out if you haven't, because it ends up leading to some really interesting gameplay when you kind of have this like giant mob of people, and it's like, how does that kind of how does the people kind of interact with each other as you're kind of navigating through this whole maze, and how does that kind of change the world? And so there's a lot of like really interesting things that you can do from, say, like a puzzle game perspective. Also, good candidates for ECS are when you're running applications on performance critical devices. So of course, mobile, of course is really big, especially in certain parts of the world. And, this is where performance really, really matters, where, we're kind of typically running our applications on lower end devices that have, limited battery life and things like that. So, there are a couple, of course, this allows us to create kind of, more, exciting and more feature-filled games, on these lower end devices. But also it just kind of helps our regular games run a little bit better. So that means that, the processor isn't going to be, completely maxed out. We're not going to be, chewing through, battery life. The phone isn't going to be like overheating. So it's really key, I think, in these performance critical devices that, we're being really efficient about how we're processing data. Another example of our performance critical devices are, virtual reality, augmented reality, where, it's a lot of the similar constraints to mobile, except for now it's, strapped right on your face. So if something's overheating, you don't want that to be overheating on somebody's face right there on a, extremely sensitive part of their body. And also there's the whole thing about how we want to have, not only a really high frame rate, but we also want a very consistent frame rate. So, as we're kind of, moving our head around, we want to make sure that there's a really good consistent frame rate. Otherwise that can kind of lead to motion sickness. I think another example of a performance critical device would be something like a kiosk where, a lot of times you see these things in museums where they have like some, tablet or something set up like this. And a lot of times these actually are running Unity applications just because Unity is really good for, just creating little interactive things. And I was actually at a museum a couple weeks ago, and they had like a little Windows kiosk that was running, just kind of some basic application that's, again, kind of showing some images and maybe some 3D models. But the processor or the fan on this thing was just, cranked to the max, just going full speed. And it's like, okay, if that thing's running, all day, every single day, what actually ends up, being the cost, like the energy cost of that if you're, just constantly running that thing completely maxed out. So, again, maybe these situations where we're having something that's running, constantly, I think that's kind of like a, where we want to look at the, performance of our systems. Also, I think non-game applications, there's a lot of really cool things that we can do within these non-game applications. So actually, not too long ago, I had the ability to develop this project called Aviar Graph. And basically, it was kind of took these like Neo4j databases and ingested them into Unity. And then we're actually able to kind of view these graphs in a virtual environment. Now, this ends up being a really kind of performance critical application because all these, essentially nodes and relationships, they're all kind of, putting physics forces on each of them. So as you kind of, move things around in the application, the graph kind of reacts to that. So, this application actually was originally built out using regular Unity game objects. And, the performance ends up being pretty capped out at, around maybe 100 nodes or so. And again, this needs to work in a virtual reality environment where, again, performance is extremely critical. Now, with Unity Dots, we're able to, really ramp this up and get to, a place where we were able to simulate graphs with, thousands of nodes and relationships. So, I think anytime where we have some applications where we need some type of like real-time simulation of things. And, maybe we're doing a lot of, complex logic, especially across large numbers of dynamic entities. Again, this is a really good candidate for Unity ECS. So yeah, real quick, I just want to talk about, why ECS is a good fit for these performance critical applications. So one, like we kind of already mentioned, is the whole data layout aspect. Again, with object-oriented programming, if we have things kind of, scattered throughout memory, again, we're going to be having to go out to our main memory to, access a lot of that data. So that ends up being very slow. And in some cases, it can actually be 1,000 times slower to access things in main memory as opposed to, some of your caches that are closer to the CPU. And again, with data-oriented design, we're kind of, structuring that data where it's, our like data is going to be stored contiguously in memory so that, when the CPU goes out to memory and it fetches that first bit of data that we're working on, well, it's also going to, prefetch the data that's, comes after that. So that basically means that as we start processing that data, well, the next data that we're going to be needing to process is, just kind of, right there available to us. So that's kind of, again, some of these advantages of structuring these things in arrays and processing things in groups, because we can kind of, take advantage of how the CPU, best wants to, process this data. So it ends up being, very fast for that reason. Another reason, again, is the burst compiler, where we're kind of, compiling things down into this machine code. Actually, what you see right here is the burst inspector. So you can actually see in Unity the, actual output of some of this data that, or the assembly code that gets, compiled down. So for example, I have this, say, player move system, where we're saying, defining a new vector, and you can see that, this is the actual machine code that ends up getting ran. And again, a lot of this stuff is very efficient, uses single instruction, multiple data, operations on all this. So again, that's another massive speed up in performance. And then finally, the job system, kind of like I mentioned before, we have kind of some logic running on the main thread here, but then we also have all these worker threads down here, and you can see these kind of green sections here are where we're actually, kind of offloading some of that processing across all these worker threads. Now, again, you can see all this stuff is running in parallel, and there's, other things going on in the main thread. So, we're able to, process these things kind of like in parallel in groups. So, again, if we have large numbers of dynamic entities, we can, push off that processing across many of these available worker threads to us. So again, that's another massive efficiency gain for having large numbers of dynamic entities. Then again, I do just want to talk a little bit about games with dynamic architecture. So some games with dynamic architecture are maybe some things like roguelikes, where, for example, we have, this game called Spelunky, where there's a lot of different things within the world. And it's really cool because, all these things are kind of, different concepts, but they still kind of have like a consistent rule set. And, this makes, I think, really interesting gameplay because, basically, if there's any like essentially object in the world, well, we can pick it up. And if there's something that we can pick up, maybe we can also throw it. But each thing maybe has some of its own slight variances. Like, so for example, if we say we're to pick up this crate and throw it on some spikes, well, the crate is going to break open and maybe it's going to, have some things in it that are going to kind of spill out on the ground. Or maybe for example, we have like this brick of gold. And if we were to throw that on some spikes, well, kind of by the architecture in our game, we don't have that break on the spikes. Instead, it just kind of, falls down to the bottom. So again, we can kind of do some interesting things with dynamic architecture here. Another example is a game called V Rising, and they actually did a stream with Unity a little while ago where they kind of were showing some of the technical aspects of their game and how they actually used Unity ECS to do some really interesting and dynamic things in their game. It's quite a long stream, and there's a lot of really interesting things that go into it. So if you're interested, I would recommend checking that out. Again, this is V Rising by Stunlock Studios. So why is ECS a good fit for games with dynamic architecture? So again, when we have object-oriented programming, the data and transformations essentially live together. So maybe we have this character mono behavior. This kind of has some vectors for the move direction and position, and we kind of have some update loop that's getting player inputs and moving the character, and applying this updates to the position and all this. So again, we have these data and transforms that live together. And of course, I've already talked about some of the inefficiencies of kind of having things structured in kind of a way like this. But in data-oriented design, we can kind of contrast that. So the data and transformations are separate. So maybe we'll have some struct for our move direction, and then we have some system here that says to get the player input, and then we have another system that is kind of like our move system. So things are a little bit more separate. You can see that it ends up being approximately, I'd say, like the same amount of lines of code to create these data transformations as object-oriented programming here. However, you can see that some of the lines end up actually being a little bit longer. We need to kind of define more things. So that's just kind of like one thing to keep in mind. But one of the advantages of kind of having these separate data and transformations and all this is, again, we can kind of like don't necessarily need to define anything specifically. It's more just we're kind of operating on these groups of data. For example, where we have this say get player input system, we're listening for keyboard input from player, and we're setting this move direction and then applying it in the move system. Well, maybe if we have some enemies, we can say have some enemy AI system that determines this move direction here. And then, this enemy AI system, or the enemies, can also take advantage of this same move system, because we're in both cases, whether the player or the enemy, we're setting this move direction component here. So again, in this move system, it doesn't matter that we're working with a player or working with an enemy, we can apply this, movement in the same same manner here. And actually, well, another thing that I wanted to mention real quick on having separate data and transformations is, because things are a little bit more separate, it actually ends up being a little bit easier to kind of test things out, because things are a little bit more isolated. We can kind of test things just as they are, and we don't end up having this whole nasty web of kind of like dependencies, or maybe it's a little bit more difficult to test. And then also, I think refactoring, it's actually quite easy to do, because things are so separate. We can literally just, if we wanted to make a different move system, we could just say completely disable this move system, and we'll create a brand new move system. And as long as we're operating with the proper data components that our entities have, then we're able to create new systems with new behavior. And that's been one of the major advantages for me, that when I've worked professionally on projects that use ECS, is that I've done major refactorings on some of these core systems, and I was able to just kind of rip something out pretty easily, add something in, and again, I'm not having to untangle this whole nasty web of dependencies, which has been really nice. Okay, so another thing that's really cool is we kind of have control over system state. So for example, if we were like making a game where we kind of have maybe some kind of like narrative section or some exploration section, where we still want the player to be able to walk around within the world, and they're kind of searching for things, but again, it's kind of like a narrative scene. Maybe we have these two characters who are like talking to each other. Maybe just kind of like, for the mood of our game, we don't want to enable combat here, because we don't want Nathan Drake to just start like attacking Elena for no reason in this scenario. So we can kind of control the the combat systems, where we can just say, let's turn off all the combat systems within this one section, and then we don't have to like keep a list of who are all the characters within the game that can like attack each other. Okay, we need to like go on to all these entities and change some state on those specific entities, and then now we need to remember to re-enable that when we want to re-enable combat. Well, again, we can just do this more at the system level, where we could say, hey, this section of the game, let's just disable those combat systems, but we still want to keep all the movement and exploration interaction systems enabled. And then when we get to a point where we come up on some bad guys, let's go ahead and re-enable the combat systems. And then, all the entities that have the ability to participate in these combat systems can just, start using combat if they want. Okay, so real quickly, I'd just like to give a quick demo in Unity here, kind of demonstrating some of the advantages of this composition over inheritance that I think leads to really cool modular architecture here. So what I have here is just a little thing running in Unity. We can see that we have this little green character that we can move around, and it can shoot off some attacks out into the world. Now, these attacks don't really do anything. You can see that they're just kind of, moving through these other enemies here, and they're kind of just like going off into the distance. So let's kind of like go to these attacks and, add some functionality to them here. So for example, we see this, I've called it a capability. And so here we have a projectile speed. And if we want, we can, really ramp up this projectile speed. Of course, this data is, fully editable to us. So, now when we shoot them off, the attacks are going much faster out into the world. But we'll just go ahead and leave this at 7.5 for now. And so let's go ahead and add a new component here. So we'll go ahead and add the damage on collision. So in this case, we're just adding a new component that says, now when we collide with one of these entities, we're going to apply 10 points of damage to them. So we come over here, and then now we can shoot this off, and then we can see that these guys are now taking 10 points of damage. We have some little damage pop-ups that are kind of going there. So let's say next, maybe in this game, we want this to be kind of like more of a cannonball or something. We don't want it to like, pass through these enemies. Maybe it hits the enemy, and then we'll just kind of destroy that. So we can say, go ahead and add a destroy on collision. And then now this kind of gives us the ability to basically kind of destroy this on collision. So we'll go ahead and collide with one of these enemies, and you can see that it no longer kind of goes through, it just collides with the first one here. Now we can do some other interesting things. So maybe, for example, we want to say, spawn something when it gets destroyed. So, for example, we can go ahead and spawn an explosion. In this case, so now when I shoot this, it's going to go ahead and actually spawn this explosion. This explosion will kind of now damage some entities in the surrounding area. And that's because I've created this explosion to also have some of these similar scripts that damages the other enemies when it collides with them. So it's kind of built off of the same thing that this initial projectile was built off of. And then of course we can remove components. So for example, say we don't want to have this projectile speed on here. Maybe we want to make something that's kind of like more of like a landmine. So for example, now I can press that, and then it just kind of spawns that off into the world. And actually, I forgot to add one thing on here. So we want to actually add a destroy on timer as well. So this will actually destroy after, we'll say 5 seconds. So now we can come back here, and now we can add a landmine. So we can go ahead and do that. And then after 5 seconds, this should explode. And then that again applies damage to the surrounding enemies there. So yeah, you can see that we kind of have like, again, we never like define something specific where it's like, oh, this is a fireball, this is a cannonball, this is a landmine. No, we kind of just like created these little building blocks, and now like our designers can go in and they can create, whatever different types of behavior that they want. Again, without specifically defining things, we just kind of have these little building blocks that we're using to, add up to create these new and different behaviors. And of course, we're just doing this within the editor here, but there's no reason that we can't say expose that to our players to have some maybe big skill tree of, different things to, upgrade our different attacks where, our attacks are starting to get more capabilities or they're getting more powerful. We can definitely do that as well. So there's a lot of really cool things that we can do with these kind of modular dynamic architecture of this game. And those are honestly kind of some of the things that excite me the most about using Unity ECS. So I'd just like to go ahead and kind of talk a little bit about the current state of Unity Dots, and then kind of go into some of the future of Unity Dots as we kind of close things out a little bit here. So the current state of Dots here, what I like about it, of course, there is a lot that I like about it. I think I've kind of shown some of the things throughout the presentation here, but I really just prefer the ECS and data-oriented design architecture for the performance and modularity. So of course the performance stuff is really cool. Again, it allows us to make interesting games that we weren't necessarily able to before. Just because, again, all these, performance, again, all these specific things that, kind of Unity provides us, where we can get these like really big performance numbers. I think this unlocks kind of more, interesting gameplay that we weren't necessarily able to create before. And then again, the modularity is something that, I personally like. There's kind of some cool things that I've created with that little combat system that I kind of demonstrated, and some other things along that nature that, I really just prefer the ECS workflow. And frankly, as I've, gone on and, maybe worked on some other game object-based projects, I really find myself missing a lot of the, features in Unity ECS. So it's like, oh, it would be really nice if I could just, kind of like, query for all these entities and just kind of, do some operations on those. There's definitely things that I end up missing when I'm, developing more game object-based projects. Now, it's definitely not perfect. There still are certainly some issues and limitations. So for example, is definitely missing some features like UI and animations. And, I think for something like UI, this isn't necessarily something that needs to be ECS based. However, in our games, we definitely need UI to, kind of inform the player about what's going on within our game. And right now it ends up being a little bit cumbersome about, how we kind of, have to send data over to our UI. And then if we have some, UI events, how do we kind of, make things happen back on the ECS side? So there ends up still kind of being that split between, entities and game objects. And, again, all this stuff is completely doable, but sometimes when I'm doing this, I'm just like, oh, this is really not ideal the way that I have to do this. Another big thing is animations. So right now, there's nothing really like built into Unity that's, this is how you do animations with Unity ECS. Right now, again, the way that you kind of have to do that is maybe use some game objects or, do some other limited approaches. I will mention that there are some solutions that are available on the Unity Asset Store and some other animation libraries that people have created kind of as like a little bit of a stopgap. Unity is working on their own solution. We'll talk about that in just a second here, but again, that still is a little bit of a limitation. And again, a lot of these limitations kind of have to deal with linking things on the entity side and the game object side. And, like I mentioned a few times, that ends up just getting messy. Unity has given us some tools where, we have this thing called like a Unity object ref, where we can, reference, just regular mono behaviors, things like transforms or UI sliders or, really any kind of Unity object type thing. And, there are kind of some cool things that we can do with this Unity object ref, and it is definitely a nice feature. But again, it just ends up being a little bit messy when we actually want to, kind of use it. And again, send things back and forth between essentially the two sides, because there still is a decent split between the two right now. I will say that it also can be a lot of code for simple mechanics. The project that I just showcased where, I had all these, different combat things and we're kind of, building up these capabilities and all this. It ends up being kind of like a lot of code, a lot of like just like setup code to get to that kind of like starting point where we have all these building blocks, that our designers can kind of use. Because again, for each of these, aspects that I'm kind of adding to these different attacks, well, I have to create like a new data component and I have to create a new system that, processes all that data. And so it ends up being a fairly large volume of code, just to create kind of like, simple mechanics, especially, this is really apparent when you're like creating something like a game jam or just, prototyping something out. You have to do a lot of setup code to get to the point where you're like, actually testing out your, features for the first time. So it's not necessarily ideal for prototyping. Of course, unless you're like, prototyping something that's like, really core to ECS and it's important that you're using ECS. However, I think that stuff kind of ends up evening out a little bit over time, just because, once you have these building blocks in place, you can kind of reuse a lot of that code to, again, create new behaviors with it. So, I think in the long term of a project, the volume of code kind of evens out with a regular object-oriented based project. Another cool thing that Unity is doing is they take a lot of advantage of source code generation. So here, for example, we have a character move system. And, you can see that it ends up being just a pretty simple thing here. We have an update method. And then again, we have this kind of like for each statement where we're iterating through, everything, this transform, character move direction, character move speed. And you can see it's, pretty simple how we're just kind of, applying this data here. Now, this is actually not the code that's running. Again, Unity takes advantage of source generation, and actually within JetBrains Ryder, we can inspect that source code. So you can see that there's this little thing that says dots right here. And if we click on that, it comes up with this little menu, and this says show generated source code. So if we click on this, we can actually see the source code that gets generated, from kind of these different operations. Now this ends up being quite a bit of code. So just this short little system right here, this actually generates into about 175 lines of code. Now, not all of that is like, actual code. Like you can see a lot of this stuff right here is we have this like hashtag line 198. And this is kind of an interesting thing that Unity does to, basically map the code that it's running to the code that you wrote. So this actually ends up being kind of like a very helpful for debugging. So, when some, particular line that fails again on the code that's actually running, the debugger can basically look at this, little line attribute above that and it points to the place in your code that the actual error is happening on. So again, even though the code that you're writing is not necessarily the code that's running, you can still see the line that it's erroring out on. So that can be, a little bit confusing, especially if you're kind of newer to some of these ECS concepts. But it is really cool that in Ryder we can access this generated code very easily, because there are definitely some times where I want to kind of look at some of this generated code and be like, okay, what is the code that's being generated here, and like is this the most efficient way that I could be going about things, or again, if there's some errors, every once in a while I need to kind of jump into the generated code. For the most part, you don't need to worry about it too much. But again, it's nice to have in those few cases that you do end up needing it. So as we close things out here, let's talk a little bit about the future of Unity dots. So a lot of the things that I'm going to be mentioning here, Unity basically showed off in their Unity Engine roadmap talk that was at the Unite conference. I would definitely recommend checking out this talk if you haven't already. I think it's about 45 minutes long or so, and they talk about all different types of things, not just dots, but a lot of things on graphics and, other cool things. And, a lot of the stuff in that talk, just really made me be excited about the future of Unity. So anyways, let's talk a little bit about some of the Unity dot specific things. So one thing that they announced is this kind of ECS for all initiative. So again, what this kind of means, and again, there's still a lot of questions about how this is practically going to come into play, because they basically said that this is going to be kind of a major feature of the engine in kind of the next generation of Unity after the current Unity 6 version. So this ECS for all, basically it's a way that a lot of the kind of regular features within the Unity game engine can take advantage of ECS, even if you as a developer don't have any familiarity or experience with Unity ECS, which is really great. Everyone can kind of take advantages of those performance aspects of it, without having to worry about it. And then I think one of the things that they kind of mentioned is that each game object is now also going to have an entity associated with it that can kind of do some of that more efficient processing and everything. So that's really exciting to see. And then, they've also kind of said that, if you want to, for the power users, the people who are familiar with Unity ECS, you can kind of essentially dig a layer deeper and then, create some of those systems yourself, or kind of, manually manipulate things on the ECS side. And kind of one thing that they showed off is this essentially unified transform system where now we can have game objects and entities live side by side, because right now in Unity ECS, all these entities are kind of limited to something called a subscene. Now there are a lot of advantages of subscenes, and there's some cool things that you can do with them. However, one of the limitations of them is you can't do cross-scene references between this subscene and the main scene that your game is running in. So for example, if you want to have a camera follow the player, you can't just drag in the reference of the camera to that entity, because they essentially live in different scenes. So you can't have any kind of cross-scene references like that. So again, that kind of comes back to the point of how it's a little bit annoying to kind of bridge that gap between entities and game objects. We have to come up with different solutions for kind of doing those cross-scene references. But again, in the future, we're going to kind of have this unified transform system where entities can kind of live within the same scene as game objects. So that's going to be really nice to see. And they've also showed off a new animation system, which is really cool. A lot of very exciting features on that. It is compatible with game objects as well as entities. And again, they showed this little scene here where there's 1,000 of these knights kind of storming this castle here. And they're all, skin mesh renderers using the new animation system. And again, it's all built off of Dots tech. So everything runs, very efficiently, uses ECS, jobs burst, everything like that. And it's also just a really cool animation system. I think there's a lot of features that people are going to like in there. Again, check out the roadmap talk if you want to see some of the things they previewed there. And they also showed off some of these new world building features. So if we want to start, creating more, complex and interesting terrains, again, all this stuff is built off of DOTS technology. So we can kind of, really take advantage of the, just kind of making more ambitious worlds essentially. So again, a lot of really cool stuff there. Again, this is all built off of DOTS tech. So yeah, to kind of close things out a little bit, as you can tell, I definitely am very much a fan of, all the data-oriented design concepts that Unity, kind of has given us to this point. And then, I'm just really excited that Unity kind of, continues to see how important this is and kind of use this as kind of a lot of the backings of kind of their game engine, and that more people will be able to take advantage of these technologies. So yeah, I just think there's a lot of really exciting stuff. And again, I think it's really cool that you don't necessarily have to know anything about ECS to take advantages of some of these performance aspects that it gives you. However, if you want to start getting a little bit into the nitty gritty and kind of dig a layer deeper and kind of get into the ECS side, again, all that stuff is absolutely available to you. So again, if any of this stuff sounds interesting to you, I would just recommend, starting to get familiar with it, because it sounds like it's going to be a much more important part of the Unity game engine within the coming years. And yeah, so that's pretty much my talk here. So thank you very much for listening, and thank you very much to JetBrains for having me back on for the Game Dev Day this year. It was a ton of fun.
What up, Johnny? It was
hello.
something. This is great.
Thank you so much.
One thing I've noticed, and it's coming from a true C++ C developer with a bunch of experience back in the day, and watching the last 4 talks, you C# Unity folks sure do have a lot of problems with memory.
Yeah, it's a real problem. But yeah, I mean, again, I think there are a lot of things, especially on the DOT side, where they're like, okay, we recognize that this is a problem. Let's do some things to actually solve this.
Yeah, I couldn't help but notice the similarities with a particular Rust game engine. I mean, what are your feelings? Where's the overlap? What do you think Unity does better than the Bevy game engine? And what do you think Bevy does better than, say, Unity's implementation of data-oriented design?
Yeah, I'm unfortunately not super familiar with the Bevy stuff. I haven't written any real Rust code myself, but I actually did, as part of my YouTube channel, did kind of a collaboration with someone who is, kind of a programmer with, Rust and Bevy. And we basically did a game jam together where we both created the same game, and I used Unity ECS and he used, Rust and Bevy. So we can kind of did a little bit of a comparison between the two. So yeah, like I mentioned, there's a lot of kind of limitations with Unity DOTS about, kind of integrating with a lot of the existing features in the game engine. And the cool thing about Rust and Bevy is kind of all that stuff is designed to work together. And again, it's all built around an ECS. So, everything is just kind of like a system by default. We're not adding this stuff on top of an existing framework.
Mm-hmm. Yep.
All right. So we actually have a couple of questions from the chat.
Great.
So the first one will be, can iSystems send messages to the mono behaviors or just mutate the data they share in a thread-safe way?
Yeah, so most often the iSystems are just going to be modifying the data directly. There is another concept called system base, which is kind of more like a managed system. And on there, you can have more traditional C# events if you wanted to, and you can kind of listen to those that way. So there, again, is the ability to do that. But again, it gets a little bit messy, and it's not necessarily something that I always recommend. But again, like I say, there's some cases where you can't really get around that, and you kind of end up having to do something like that.
Mm-hmm.
Gotcha. And another question, can Link be burst compiled too?
No.
Yeah, I'm curious if the new version of Unity, as they kind of get into Unity 6 and move towards .NET 8, I know the Unity team is making a lot of headway there. I'm curious if they'll actually be able to convert a lot of that link code into something that's friendlier. But I guess
yeah, it will be really interesting to see. Again, one of the other things that Unity has kind of been talking a lot about is this migration to the core CLR backend. And so, yeah, it will be really interesting to see, kind of what, are all the advantages of that, both on the regular game object side as well as the ECS side.
Yeah, although our previous speaker, Andreia, was saying like she still thinks mono is better than the core CLR.
Okay.
That's how I interpreted it, but I'm curious to see what the trade-offs are going to be once they move to that. This is actually like for me is kind of more of a personal, like human question. So you showed that great demo using the Among Us little creatures there. I love that. But as you're building these components into your game and you have a large team of, game designers and developers and stuff like that, how do you communicate that these new systems are coming online, and how do you communicate how to use these new systems?
Yeah. I don't know. I guess that just kind of is just the same thing that you would with like any other, just, making sure that you have open communication lines with, the different teams. And, as people are requesting features, you're kind of communicating to them that, these features exist and kind of give them some information on kind of like how to use them. But yeah, I don't know.
Well, here's a personal question for you, kind of related to that. Like, as you were building systems into your games and stuff, have you ever found kind of any emergent like side effects of combining two systems together that you found like funny or surprising to you?
Yeah, that is something that comes up from time to time because again, we're kind of running these systems on groups of components. So every once in a while, you'll forget to specifically add some component that says, only look for these specific entities, or maybe to exclude these entities. And so yeah, there's definitely a bunch of times where like, I'll add some new system and then like, some other thing that I like finished a long time ago will start like having that same behavior. And yeah, so I mean, there's definitely like some funny things you can do. I think I showcased one time where I had a couple different move systems. So maybe there was one that just kind of, moves the player just around the map, just kind of like normally like they would. And there was like another system that had them kind of like hop around a little bit. But then you could just kind of like, have both those systems apply. So you can kind of have like that movement and the hopping happening like both together. So
yeah, that's pretty cool. Alex, do you have any other questions?
I guess not, to be honest.
Okay.
I'm still all puzzled.
Well, I guess let's end on this question, because I think you had a call to action at the end of your talk, but to just check out all the things that you showed in your presentation, what do you think is like a good first project for folks? Like if they're starting with a blank Unity project, what would you recommend the hello world of all this to be?
I think the hello world would probably just to be like, I mean, literally just like spawn like 10,000 cubes and have them all just kind of like, spin or do something simple, just to kind of like familiarize yourself with the whole workflow of Unity ECS. I will just kind of call out that Unity does have a lot of really good learning resources to help you get started. Like if you just look at the entities package, there's like some good documentation to get you up and running. We also have some really cool sample projects. You have a couple of Git repositories up on GitHub, just again with a lot of kind of basic things, but then there's also some more complex ones. Like they recently released this kind of like whole galaxy sample where there's like all these like factions that are kind of like battling each other, and it's really cool.
Yeah, it sounds pretty cool. So yeah, I guess on that note, thank you so much, Johnny. Great talk as always. Definitely check out Johnny's YouTube channel. I posted links to his podcast in the chat, so you can kind of scroll back, check out his podcast. And also check out his official visits to kind of the Unity channels. I've seen you on there a couple times. So
yeah,
that's pretty cool.
There from time to time.
Yeah, so on that note, thank you again, and have a good day.
Awesome. Thank you guys so much. And
Hey,
yeah, glad
hi,
to
Yanni.
close out the JetBrains Game Dev Day today.
All right, Alex, there was a lot of good stuff today, don't you think? Pretty good.
Yeah, for sure. It was hot. It was a lot of new stuff for me specifically. I am mentioned multiple times. I am not like I am now. Probably will stick to a 5 feet stick when it comes to C# and Unity instead of 6. Like you're slowly converting me to your religion.
Hey, remember, memory management is super important. I think that's what we learned today when doing with C#. But we've talked a lot about the features in the present, whether it's Ryder, Unity, Unreal, Godot. But I think for the folks who are sticking with us now, it might be a good time to talk a little bit about features and things coming to Ryder in future releases. So I'm going to give you the stage since you're talking about or you have the Unreal Engine hat. Let's talk about some of the Unreal stuff that's coming for folks.
Oh, that's a good question. Actually, like a lot of stuff has already like mixed and matched in my head. I think one of the hottest topics that been going on and even like showcased it in the early access preview at the Unreal Fest Shanghai, the addition of the mixed C++ and blueprints stack trace. It's like super great. When I was working on the Unreal Engine project, especially when you dig deep a lot, really deep into the UI code, and there's like all the way like make some spaghetti going C++ UI, C++ blueprint, C++, and you can never find the trail like where that is coming from. This helps like a lot to you. And in general, it's not specifically for Unreal Engine, but we've dedicated like great amount of resources this year to become the ultimate game dev IDE, and you cannot become an ultimate game dev IDE without carrying few consoles support in your pocket. So stay tuned. We are in the process of like releasing Sony, PlayStation 5, Xbox Series S and X, and Nintendo Switch support. Although for the last one, it will be like take a little while, but we hope we will all deliver them soonish.
Yeah, see, I'm even wearing my PlayStation sweatshirt. So
Gotcha.
so yeah, if you folks are developing for consoles, check that out. I think it's still in preview, so if you're interested, reach out to us. I think that's going to be cool. We also have Live++ and Noesis support coming. So if you're doing Noesis GUI stuff, that stuff looks kind of cool. That's coming. I will say for the folks who are doing Fortnite development, I do see some exciting news coming up for you. Alex, you want to talk about that?
Yeah, for sure. I mean, the verse, the language, the myth, the legend. Actually, like I talked with the Team Sweeney during the event, and he like specifically directly to me said that you should not add support for the verse language to your tool. I'm like, what? But we are crazy folks. We are like IDE developers. We don't listen to anyone. We just do what we do, and it's fun. So we are adding support to the verse step by step. You already can add support by basically, enabling the text-made bundle plugin that comes along with the Unreal Engine Fortnite installation. The second step that's coming along quite quickly, we are adding support through the LSP server that also comes along with the Unreal Engine Fortnite. But we'll, I guess, wait for the full-blown release to get the first-class support, like the official one from the JetBrains IDE that will enable a whole another class of integrations and new features that's only like our tools can provide. But we'll see.
Yeah, I mean, it's all exciting stuff. I mean, if you're in game dev and you're using Unreal Engine, I think Ryder is awesome. But let's talk about some Unity stuff. So IL to CPP debugging improvements are coming for Unity folks. So we're working hard on that. Again, no assist like support for Unity games as well. We're also actively working on shader debugging and mixed mode debugging. So you mentioned that for Unreal. I think some of that's coming for Unity. And go to everything, find in files, respecting the solution scope. So that is a feature. Something for Godot folks, because Godot made a big showing today. I think there's a lot of exciting stuff coming there. So folks who are doing C# access for Godot, we're going to bring hot reload during debug and potentially edit and continue support. So we don't have an exact version number for the Ryder release, but we are working on that. We are improving debugging support as well for GDScript. Actually, I saw a pull request go into the official Godot repos, so that should improve just Godot debugging across the board for everybody. I think that's pretty cool. And finally, I think this applies to all game developers and even non-game devs, but .trace is bringing in native profiling. So if you're using native code or whatever code you're using to execute, you'll be able to use .trace to profile it. So GDScript, C#, Rust, Kotlin, I guess, anything really. So I think that's going to be exciting. So on that note, Alex, any final words before we kind of close out the conference?
I mean, it was awesome every single year that we managed to gather so many talented people to provide their valuable knowledge to and share it with you guys. I feel like grateful for the community and for the company, and I hope for the next year to go even bigger, even stronger, and finally bring more Unreal people, because I am not against listening to C# Unity folks every day, all day, but I just want to steer it just a little.
Hey, we're gonna convert you sometime, but yeah, I want to thank the folks who made this conference possible. So our previous hosts of Anastasia and Matt did a great job today. I want to thank you, Alex. I want to thank all the Alexes.
You're just too sweet.
Yeah, I want to thank.
Best.
Oh, thank you. Thanks so much. I want to thank our marketing team that made, put the word out there and got people invited, our speakers, our video team that kind of helped puts all this together. And finally, I want to thank the people that joined us live throughout this whole, conference, because we do this for you. And chat has kind of been great. So on that note, thank you for joining us this year, and we'll see you next year. Bye, everybody.
Peace and love. See ya.